In this video, I will identify strategies for deployment of full-stack solutions to local and cloud servers. There are various strategies when deploying full-stack or FSD applications to local and cloud servers. These include Big Bang, rolling deployment, blue-green deployment, and canary deployment. Big Bang deployments, unlike traditional FSD deployments, deploy an application in one swift step and do not use an incremental approach to deployment. This technique is more risky than traditional incremental deployment methodologies, but may be required for some applications. A rolling deployment basically installs parts of an updated application on different servers at different times to reduce application downtime during an update, and also to reduce the likelihood of major errors or bugs entering an application during an update. A blue-green deployment deploys a new version of an application in a parallel environment to an existing version. Once the new version is verified and confirmed to be working as expected, existing traffic is rerouted from the old version to the new and updated version of the application. A canary deployment strategy is similar to a blue-green strategy. However, it gradually increases the percentage of traffic going to an updated version of an application from an existing version. And once the updated version proves that it's stable and reliable, then the rest of the traffic moves over to the new updated version of the application. The Big Bang deployment model shuts down an existing application and redeploys a new one without a graceful rollout period. Advantages to doing this are that the deployment is easy to set up compared to incremental deployments, and the deployment also immediately gets all users using the updated application. Downsides include the fact that there is a considerable amount of application downtime, as the old application is shut down and the new application is being booted up and getting set up. Users may also have to update their own client-side installation by downloading and installing new software packages or programs. A major disadvantage of the Big Bang deployment methodology is that it is not designed with rollbacks in mind, so that if a major bug or issue occurs when deploying the updated application, there can be significant cost and user experience implications. The ramped or rolling FSD deployment strategy deploys an application in stages, and because of this incremental fashion, the application remains available to end users during an update. The idea is that parts of an application update are deployed to different servers at different times. Once the features have been verified, a load balancer redirects user traffic to the new updated instance of the application, while the old instance is shut down. The speed at which the overall deployment occurs can vary depending on things such as the parallelism of instances being rolled out and the number of instances not available during rollout. Advantages of a rolling deployment strategy over a Big Bang deployment strategy are that a rolling deployment has no downtime and that features are adequately tested before live traffic is rerouted to them. Downsides include a slower overall length of deployment, having to support multiple various APIs, and the need to accommodate various volumes or loads of traffic during the update process. The blue-green deployment methodology differs from the ramped FSD deployment strategy in that an updated application is deployed fully and in parallel to an existing production application. Both applications share the same database backend, so it is important that the database stays in sync between the two applications. Tests can be run on the new application instance, and once they are completed, traffic can be redirected to the updated application in one go. Advantages to this method include a quicker rollout and less work keeping track of incremental feature versioning issues. Also, an application can easily and painlessly roll back to the original version if any errors are encountered in the updated version as the two environments are running in parallel. Downsides of this method include costs, as two environments are required to run in parallel, as well as ensuring that proper end-to-end testing is completed on the updated application before traffic is switched over. Canary deployment shares a lot in common with the blue-green deployment methodology. However, it is designed to minimize risk compared to the blue-green deployment method. This is because, instead of switching all users to a newly updated production application in one go, the canary deployment method takes an incremental approach, where a percentage of users are switched to the updated application at a time, and if all goes well, the rest of the users are switched over at a later time. This method has advantages to the blue-green method if there are insufficient test cases to test an application update before rolling it out into a production environment. Disadvantages of this method include a slower application rollout time compared to the blue-green deployment method. In this video, I will identify security strategies when developing and deploying full-stack solutions. Full-stack application security is of paramount importance as it can make or break the success of an application. Application security is not only relevant when running in production, but also during deployment time. In order to ensure that an FSD application will be deployed in a secure fashion, it is important to step back and go over important deployment details such as security requirements, security compliance details, password protections, and user privileges. In order to determine security requirements, meetings should be held with key stakeholders and customers to determine the application functionality and which types of sensitive data needs to be stored. Asking questions can help determine whether security solutions are up to standard and if they are compliant with application requirements. Password protections can help mitigate brute force attacks by forcing users to have two-step authentication, limiting the number of login attempts, and ensuring that strong passwords are used with a mix of digits, numbers, and special characters. The principle of least privilege means that users or roles are basically granted the minimum amount of privilege to accomplish what they need to accomplish within the application. An example of limiting user privileges is to reduce the number of users with administrator or admin privileges and to limit the number of users which can modify critical high security objects such as user profiles. There are various steps that a team can take in advance to rolling out an application into production in order to harden its security. These include involving all stakeholders in security decisions, hardening the security infrastructure of the application, and limiting the scope of initial application deployment. All stakeholders need to be involved in the security decisions in order to arrive at an optimal product. Developers know how to implement the security of an application by securing passwords and limiting privileges for certain users. However, without the stakeholders or customers giving them input on the type of data stored and application workflow, it is difficult for the developers to guess which data and processes need to be treated in a more secure fashion. Infrastructure hardening can be at the hardware, application, network, or operating system levels, and that basically ensures that an application removes or mitigates as many security risks as possible before being deployed. Examples of this can include removing unnecessary software, updating operating systems to the latest version, securing ports, and implementing the principle of least privilege. Instead of deploying a new application to the masses, it can be deployed to a smaller, limited subset of users or beta testers to ensure that everything works as expected and that no security policies are being breached. After a satisfactory outcome is achieved, the application can be rolled out to a wider audience with a lower risk of something going wrong in production. Some other things which can harden a full-stack application development and deployment include adding a security audit, implementing SSL for network traffic encryption, and implementing effective logging. An external application security audit is done by a third-party company or security contractor in order to surface any security threats which were not caught by the original development and testing teams. This can help speed up and harden application development, as a fresh set of eyes looking at a codebase and application functionality can often reveal new problems which existing developers may not be aware of. Using SSL certificates enables a website to implement the HTTPS secure and encrypted protocol for transferring data over the internet, which is crucial for modern-day high-security full-stack web applications. Logging is another key requirement for a secure application. Using an effective log management platform such as the ELK stack helps to surface bugs and security breaches more quickly, and they could be more easily identified, and this reduces the downtime and time required to fix production-level security issues. In addition to the things we have discussed in previous slides, we can also protect network ports, use real-time security monitoring tools, and we could also ensure that the physical server security access restrictions are in place. A firewall can be used to define security rules in order to protect network ports by specifying which types of traffic can access an application running on an internal or external network. Certain ports, such as the HTTP port 80, may be exposed to the public to access the web application. However, other ports for more secure connections, such as connecting to an admin dashboard or interface, should be secured behind a firewall. In addition to firewalls, a real-time security monitoring tools such as Screen can be used for a full-stack application. These tools work alongside an application to protect from and report security attacks by using various modules for implementing application security protections and by displaying security vulnerabilities and attack insights through a browser-based dashboard or API. Physical access to a server hosting an application is another thing to think of. If a server is in an unsecured location, or if the administrator computers aren't properly secured, a malicious attacker can physically alter the software or hardware configuration of a server and render it unusable. A few other things to consider are staying informed on the latest security trends and threats, keeping servers and software packages updated, and encrypting all data. Security vulnerabilities to full-stack applications change with time. Security vulnerabilities such as XSS, injection, and CSRF attacks are tracked by several sources, including the OWASP Top 10 Security Risk Document. And this is basically a report compiled by security experts all over the world that outlines the top 10 current security vulnerabilities related to web application security, along with tips on how to avoid them. Keeping the server running the application software on it up to date is crucial to security. This can be done by either manually, by approving and installing updates, or by using an automatic update tool such as Windows Update or cron job. Framework packages and third-party libraries should also be updated and tested with the latest stable version of software available, and this can often be done through framework-supported package managers. Encryption of data should be done both at rest and in transit. Data should be encrypted in transit using protocols such as HTTPS to avoid man-in-the-middle attack. Data at rest, particularly sensitive user data such as credit card numbers and social insurance numbers, should be encrypted in a database so that malicious logged-in users or users who fail login checks cannot access and exploit it. In this video, I'll identify the key differences between deployments for traditional software project versus FSD and agile software project. Deploying a software application is done differently depending on the type of software development methodology used to build the application. Waterfall is the more traditional software development methodology, whereas many modern-day full-stack applications use the agile methodology instead. There are various advantages to using the waterfall development methodology, specifically in cases where the time and cost for a project are fixed, or where there are regulatory or compliance standards which must be adhered to, and this is because the design and architecture of an application is set out before it is built, and it tends not to change too much during development time with the waterfall development method. On the other hand, the agile software development method is best for changing or unknown and flexible requirements. It is also useful in situations where stakeholders of a project are very active and give constant feedback on the development process. A waterfall development methodology is the classic modular or step-by-step software development process. In waterfall development, the roadmap or architecture for an application is laid out after requirements are gathered. This architecture tends not to change too much during development time, as the waterfall methodology depends on the stakeholders of a project having a good idea of what they want from the start. The entire system is then built step by step with approval from key stakeholders required to move on to the next step. Once the entire system is completed, tests are executed, and only then is the final fully working application deployed. Once the application is running in production, maintenance tasks can be performed on the deployed application. The main advantages of the waterfall method are that it keeps the development costs and time more predictable, as a detailed and accurate roadmap or architecture is in place from the start, and there is less of a likelihood of needing to make big changes during development time. This also makes it quicker for developers and especially newer developers to write code, as they don't need to make many architectural decisions or consultations with key stakeholders. The waterfall method isn't the best choice for all projects, however, and comes with its set of disadvantages. Since a project is built in a sequential fashion using a number of stages without much flexibility, and tests are run near the end of project development, it becomes difficult, costly, and time-consuming to fix late-stage bugs and errors with the waterfall development method. Additionally, there is also the need to have rigorous documentation in place in order to outline the project requirements and get approval to start developing the project. This can cause delays in starting the actual software development phase of a project, as it may get stuck in the planning phase longer than intended. Requirements are also fixed and not very flexible, which means that if a stakeholder requests changes or if insights on how to improve an application arise during development time, they would be hard to implement, as it would require the process to start from the first step, incurring a large cost and time penalty. Unlike the waterfall methodology, the agile methodology embraces flexibility, change, and continuous improvement to an application. The process starts with the gathering of stakeholder requirements, but the overall architecture is less set in stone than in the waterfall development method. These requirements are then translated into sprints, which are units of work that are generally somewhere in the range of 1 to 4 weeks. During the sprint, developers build the features they are responsible for, and at the end of the sprint, the idea is to have a functional, tested piece of software which can be deployed, presented, and tested for user experience requirements. Agile benefits from continuous deployment methodologies as features are rapidly prototyped, tested, and deployed to ensure that they meet stakeholder needs. If there are any changes or opportunities discovered by the stakeholders or the development team, These can be implemented in future sprints so that the application is always at the optimal state. The Agile methodology benefits from its flexibility and ability to quickly test and deploy application features, but it also comes with its share of downside. Since there is no set plan, as in waterfall development, and the timeline for developing a project is flexible, there can be issues associated with cost and time required to build an application. Additionally, there needs to be a strong relationship and participation in architectural decisions during development time from both developers and key stakeholders in a project. Stakeholders need to be involved in evaluating each feature and suggesting ways to improve it. Developers also need to have the ability to make architecture design decisions, which may be difficult for junior developers without much experience. Due to the collaborative and flexible nature of the Agile methodology, team members need to trust each other and to have open channels of communication in order to work closely in developing new project features. In this demo, I'll demonstrate how to use continuous deployment tools to deliver and deploy full-stack solutions. Continuous deployment allows developers to push software changes and updates to clients in a production environment in a seamless and automated fashion and helps speed up the development lifecycle, especially in an agile environment. In a continuous deployment setup, a code update by a developer would automatically get pushed into a production environment, assuming it passes the build and all the associated tests run against it. We will start by building a simple GitHub-based Hello Node project using Node.js along with Express.js, and we will add an automated test case which will be invoked by Travis CI, which is a continuous integration service for GitHub project. Travis CI will run automatically through a webhook whenever an update is pushed on the master branch. Once the automated test case is passed, Travis CI will then deploy the project onto a Heroku production environment. So the requirements to follow along with this demo are to have Node.js version 10 installed, along with the Git command line tool for Windows, a GitHub account, as well as a Heroku free account. So let's get started. Here I am in my hello_node project in the Atom code browser. I'm going to take a look at my files and explain what the project does. It's very simple, and then I'll run the test. So my main file is index.js, and basically here I'm defining an Express app on lines 1 and 2. I then only have one route, which is just for the / route, and I'm just going to be displaying hello node. It's going to be running on port 3000, and it's going to be listening here between lines 11 and 13. So just a very simple project, just basically a hello world, except it's displaying hello node. So then I'm going to go inside my package.json file. So in here, I'm basically going to take a look and make sure all my dependencies are installed and added. So I have a Mocha dependency and a Supertest dependencies on lines 17 and 19. So these are required for my automated test case. So on line 6, I'm also defining scripts from line 6 to 8. And under the test parameter in quotation marks, I have Mocha space -- exit, which basically means that once the Mocha tests run and pass, they will exit. Other things I have inside my project, I have a proc file, so this is needed when we're actually deploying to Heroku. So this is going to tell Heroku how to run our project. So node space index.js, which is our main service file. We have a git ignore, we have a .travis.yaml, which we'll go after later. We have a test directory with a test.js file. So if we take a look at this, this is just requiring Supertest, which is needed for our HTTP tests, as well as on line 2, we're requiring index.js, and we simply have one test case, which is going to, between line 4 and 13, make sure that we're displaying hello node with an exclamation mark. If it's not, it's going to throw an error. Otherwise, it's going to succeed, and our test will be passed. So let's go inside our Windows command line and go to our directory, so hello node, and then I'm just going to run npm test to make sure that my test passed. So we see Mocha is running, we see displays hello node, and the test passed. So now what I'm going to do is I'm going to open up a browser, and I'm going to go inside my GitHub, and I'm going to define a new repository. So I'm just going to call this repository hello node Boris. I'm going to leave it as a public description. I'm going to leave no git ignore and no license and no readme, and just click create repository. So once that repository is created, I'm going to get some steps. So what I want to do is I want to open up my Windows command line window, and inside my hello node directory I want to do git init, and then I want to do git status to look at all my files, and then git add dot git commit space -m first commit, and then I'm gonna want to add my remote, so I'm just gonna copy this command. So git space remote space add space origin space and then the link to that repository that I just created. Enter, and then I'm going to do a git space push space u origin space master, which is going to push it into my repository in the master branch. So once that's all done, what I'm going to do now is I'm going to go ahead and I'm going to go into Heroku, and under dashboard.heroku.com/apps, so I'm logged into my Heroku free account. I'm going to click under the Heroku icon, go to the home screen, click new, create new app. I'm going to call it hello-node-boris. The region will be United States. And I'm going to click create app. Then I want to configure the app. So for deployment method, I'm going to select GitHub. I'm going to scroll down. I'm going to want to find my repo name. So hello node Boris. I'll put in and I'll click search, and it found my repo. I'll click connect. I want to also choose the branch, so I'm going to leave the master branch. I'm going to select wait for CI to pass before deploy, so because we're running continuous integration services, and then I'm going to click enable automatic deploys. So once that's all done, we should be able to automatically deploy via Travis CI. So next I'm going to go to Travis CI. Under travis-ci.org, I'm going to click sign up. That's going to log me in. If I'm not already signed up, it'll take me to the sign up page. You can see I have no repositories here, so I'm going to click the plus sign to add a new repository. And it's going to show all my GitHub repositories. So I'm going to want to select hello node Boris and simply turn it on, and that's all I have to do. So now that all of that is done, what I want to do is I want to go back inside my Atom code editor, and we'll talk about this .travis.yaml file. So I'll go ahead and open it up. So inside this .travis.yaml file will basically tell Travis CI how to configure, test our application, and how to deploy it to Heroku. So inside here on line 1, we have the language as node_js. We have the version on line 2 and 3, so version 10. The cache directory, so we're going to tell it not to cache the node modules directory because it's going to be rebuilding it on lines 5 to, or on lines 4 to 6. On line 7, we have the before install directive, so we're just going to be installing npm globally. And on line 9, we're going to be defining some scripts. So it's going to run npm install, and then it's going to run npm test. So the test is actually going to run with those tests that we defined in test.js, and they have to pass in order for our application to get deployed to Heroku. Then for the deploy settings, our provider is going to be Heroku. The API key, so just a note on this, in practice, you wouldn't want to put your actual API key. There's an option to put the secret API key. However, to do that, you have to install the Heroku CLI as well as the Travis CLI. And so due to the amount of work required for this demo, I'm just going to put an actual API key. So to get your actual API key, we'll go back to the browser. We'll go back to Heroku, and we'll click on our Heroku profile. We'll click on account settings. We'll scroll down, and we have the API key. If we click reveal, we could look at the key, copy and paste it, and put it in for the API key setting here on line 14 in our travis.yaml file. The app will be called hello-node-boris. Very important that it actually matches the app's name that you created in Heroku. And the repo, we're simply going to put our GitHub repos, so bmislgn/hello-node-boris. The branch is the branch that we want Travis CI to run the build on once it's modified, and that'll be our master branch. So it's a very simple configuration. So once that's done, we're going to save that file, and then we could make a small change, like let's just make a change to our comment here in the test.js file. So here on line 6, we're going to say make sure that we are getting hello node in the browser, for example. We're going to go save that, and then we'll go back to our command line. We'll do a git status, Then we'll do a git add space dot, git commit space m second commit. And then once again, we'll do a git space push u origin master. So that's going to actually go ahead and push those changes into our master branch in our Hello Node Boris repository on GitHub. Then through a webhook, it's actually going to go into Travis CI, and we'll be able to see a build happening and track the build. Once the build passes, it'll be deployed onto Heroku, and we'll be able to launch our application and see it running in a live production environment. So if I go ahead and I go to dashboard under Travis CI, we could see that we have a build that started. I'll click on that build, and we could see it's our second commit. And here we could track inside the log the actual steps of the build. So it's going to go ahead and set up the environment. Then it's going to clone our branch. It's going to run our npm install as well as all of our tests. And then once all of that passes, it's going to deploy it to Heroku, and we'll be able to see it running. Okay, continue. So we could see that our build actually ended up passing. It took 1 minute and 23 seconds. Let's go back into Heroku for our dashboard. We'll click on hello-node-boris, and then we'll click on open app, and we could see we're getting the hello space node with the exclamation mark. So that basically means that we've now successfully made a change, pushed that change into GitHub that built with Travis CI, and it got deployed into a live production environment in Heroku. In this video, I'll identify the available tools for deploying full-stack solutions. Continuous integration, or CI for short, is a DevOps methodology which has been gaining popularity over past years. This is largely in part to the growing popularity of agile software development. The idea behind CI is to make the process of rapid feature development, automated testing, and software compilation as painless and automated as possible in order to minimize time-consuming manual integration. Continuous deployment, or CD, takes continuous integration to the next level and takes a newly committed code change all the way through automated tests and build phases to a deployed application running in a production environment. A DevOps CD pipeline is composed of various parts which all work together. These parts include automated test frameworks to run on code updates and newly developed features, source control tools such as Git or Subversion to enable developers to collaborate and sync their code base to the latest changes, continuous integration build automation services such as Jenkins to streamline compilation and build processes, and continuous deployment tools such as AWS Code Deploy, which automates the deployment of software onto Amazon EC2 servers. Automated test cases are crucial for continuous integration as they save testing time and help verify that a developer is pushing a code change which is bug-free and does not break any existing features. Some automated test case frameworks include the TestNG framework for Java, NUnit for Microsoft.NET, and JUnit, which is also for Java projects. Automated test cases are created with these frameworks, and they could be automatically run by continuous integration services when a developer pushes an update or commit into version control. TestNG is an open source framework for automated testing in Java. It is more powerful than JUnit and NUnit as it offers the ability to do concurrent testing and offers detailed comments and explanations for test cases. NUnit is written in C# and is a unit test framework for the .NET language. It was ported over from JUnit and is open source. JUnit is the core Java unit testing framework, and it provides a straightforward method to write unit test cases. Version or source control is used on software projects to keep track of code changes and updates and to ensure that each developer is working with the latest codebase. It is crucial in multi-developer teams and is a key feature of continuous integration and continuous deployment. Generally, when the developer pushes a change into version control, if there is a CI service in place, there will be an automatic trigger to run test cases, and then if these test cases pass, the build and later on, the deployment phases can be run. There are various source control tools available, including MS Team Foundation Server, GitHub, and Bitbucket. The Azure DevOps Server, which is also referred to as the Microsoft Team Foundation Server, is a tool by Microsoft to provide version control to an entire CD cycle, including automated builds, test execution, and deployments. It uses either Git or Team Foundation Version Control, or TFVC for short, as the version control system. It runs either in the cloud through the Microsoft Azure cloud or in a local environment through Visual Studio. GitHub is the most popular place to host open source projects created with the distributed Git version control system. It has various plans available from free ones to paid enterprise plans, and also incorporates additional features such as bug tracking and task management. Bitbucket is similar to Git in a sense that it also uses distributed Git version control system, along with the Mercurial version control system. The main difference is that while GitHub is designed with public open source projects in mind, Bitbucket is designed with private enterprise-level projects in mind and is used more by private businesses. Build automation is a key step in the CI pipeline, and it involves the compilation, packaging, and automated test execution on a piece of software. There are several continuous integration tools which can do build automation, including CircleCI, Bamboo, Jenkins, and TeamCity. CircleCI is a continuous integration tool that works with GitHub in various programming languages such as Java, Python, Node.js, and PHP. It offers containers for building projects in parallel, with the first one being free and a total of 16 containers supported at a time. Bamboo is an on-premise CI solution built by Atlassian, the same company which owns Bitbucket and Jira. It works with Jenkins configurations as well and supports both Jira and Bitbucket version control systems. Bamboo comes with a 30-day free trial, and after that, there are paid versions available. Jenkins is written in Java, and it is a GUI and console-based open source CI tool for multiple platforms. It is not only free to use, but is also very flexible and powerful thanks to its wide array of plugins available from the open source community. TeamCity is a CI tool by JetBrains, and it is available on many platforms, and like Jenkins, contains a wide array of plugins. It gives developers the options to have up to 3 build servers and up to 100 build configurations for free. It supports multiple frameworks, programming languages, and version control systems such as Git, Subversion, Perforce, and ClearCase. Continuous deployment or CD tools allow an application to go from a developer code change and commit to a fully deployed production application automatically by navigating through the entire DevOps pipeline. Examples of continuous deployment tools include Octopus Deploy, AWS Code Deploy, and Google Cloud Deployment Manager. Octopus Deploy is one of the best CD tools for use with .NET projects. It supports both on-premise and cloud servers and works with Docker as well. AWS Code Deploy is designed to automate the deployment of applications to both on-premise as well as the Amazon Cloud EC2 instances. It works with code in Amazon S3 storage, GitHub, Bitbucket, and more, and integrates with several CI tools such as Jenkins and CircleCI. Google Cloud Deployment Manager is used to continuously deploy applications to the Google Cloud Platform. It uses a template-driven configuration and is easy to use and supports multiple Google Cloud Platform components working together, such as the Cloud Storage, Compute Engine, and Cloud SQL or SQL components. In this demo, I will demonstrate how to use Azure DevOps Services to deliver and deploy full-stack solutions. Azure DevOps Services is a cloud-based online browser-based DevOps tool by Microsoft. It has features such as cloud-hosted private Git repos, the ability to create and share build artifacts, and the ability to implement the CI and CD pipeline. So in order to get started, all we need to do is go to the actual link. So here I am on docs.microsoft.com/en-us/azure/devops/user guide/sign-up-invite-teammates. Under this page, I could go to the Azure DevOps link to actually sign up with a personal Microsoft account. So I'm going to go ahead and click that. This takes me to the Azure DevOps page, and it gives me the option to either start free or start with GitHub. I'm going to click start with GitHub to log me in using my GitHub. So once I'm logged in, I could go ahead and create a project. So I'm going to call this project Hello Boris, and it's simply going to be a private project, and I'll click create project. Now that's going to create my Azure DevOps project, and then I'll be able to initialize a Git repository. So under repos, I'm going to click repos in the left-hand menu. I'm going to scroll down, and I'm basically just going to initialize the repo with readme and no git ignore. So I'm going to click initialize at the bottom. That's going to create my repo with the readme.md file. I'm going to click the plus sign with new at the top toolbar, click on file, and I'm going to call this file hello boris.ps1. It's just going to be a PowerShell script, and click create. Once that's created, I'll just paste some statements in here. So I'll just copy my statements in and I'll paste them in. So basically I'm defining two parameters between line 1 and 4. One is going to be the string person and the other is going to be the string trigger. On line 5, I'm just going to write the host hello Boris from person. So that's going to be basically the person that invoked the CI build process. And then the trigger is going to be what actually happened here on line 6. So if it's a manual trigger or if it's automated CD trigger, so based on a commit, so that's going to display there as well during our build. So once that's in, I'll click commit, and I'm going to just leave the default comment, added file hello boris.ps1, the branch is master, and I'll click commit. Now once that's done, I'm going to go to this left-hand page again, this left-hand scroll bar, click on pipelines. Under builds, I'm going to click on new pipeline. So now I'm going to go ahead and create my build pipeline. So I'm going to click use the classic editor to create a pipeline without YAML. And here I'm going to select Azure repos git. I'm going to select the project as Hello Boris and the repository Hello Boris, just the one we created. The branch will be master. I'll click continue. Then I'm going to click with, and then I'm going to select the template or start with an empty job. So I'll click empty job to start with an empty job. The name, I'll just leave the default. So hello boris-ci, agent pool, Azure pipelines, agent specification, I'll leave as VS 2017-Win 2016. So under agent job 1, I'm going to click the plus sign. I'm going to go to utility. I'm going to scroll down until I find PowerShell. And this just says run a PowerShell script on Linux, Mac OS, or Windows. I'll click add. And I'm going to click on that, and I'm going to add the script path by clicking on the 3 dots to the right. I'm going to select the helloboris.ps1 file we created, click OK. So for the arguments, I'm going to actually go ahead and copy these arguments in. So the person argument is going to be build.requested4. So that's just going to be the person that requested the build. And the trigger is going to be the build reason. So once again, either manual or due to continuous integration. So I'll paste that into the arguments. And once that's done, I'm going to go ahead and create another agent job. And this agent job, once again, under utility, I'll scroll down. And I'll select publish build artifact. So this says publish build artifacts to Azure pipelines or Windows file share. I'll click add and I'll click on that. And the path to publish, I'll click the 3 dots, hello boris.ps1. I'll click OK. Artifact name, drop, and artifact publish location, Azure pipelines. So once that's all in, I'm going to go up here on the top menu bar, click on triggers. I'm going to enable continuous integration on Hello Boris. So that basically just means that we're going to start a build whenever we create a new commit. And the branch filters, we're going to include the branch specification master. So once that's all done, we could go ahead and click save in queue and then save in queue. And we'll click save and run. Now, this is actually going to go ahead and trigger a build because we're manually running it. Once that's done, we're going to be able to create our release pipeline and then see the continuous deployment in action. So we could see that the job is starting. We could follow along here in the log file so we could see what's happening. And we should expect at the end of this, we see all these steps are pending. We should expect all these steps to be passed. And once that's done, we basically have a completed build and a completed build artifact, and we'll also receive an email to our user account saying that the build passed and that everything's working as expected. So if we just click on this PowerShell script step, we could see here that hello Boris from Boris Mishenchevich, the trigger was manual. So now that we have our build pipeline working, let's go and implement our release pipeline. So under pipelines, we'll go to releases here. And it says no release pipeline found. We'll click on new pipeline. And we're going to simply start with an empty job here. So we'll click empty job. Stage 1 is going to be called QA. The owner will be Boris Mishanchevich. And we're going to go ahead now and add an artifact. So I'll click the plus sign, add an artifact. It's going to be a build artifact. Project will be Hello Boris. The source will be Hello Boris-CI. The default version will be latest, and the source alias, so we'll just leave what's in there. We'll click add, and then we'll click the lightning bolt beside the artifact, and we're going to click continuous deployment trigger, and that's going to be enabled. So that basically means that a release will be created every time a new build is available, and we'll click the X at the top. Under the QA, we'll click the lightning bolt. We'll make sure the trigger is after release, and all of these other things could be disabled for now. Then we're going to go ahead and click on the tasks at the top menu. Agent job, we're going to click the plus sign, go to utility, scroll down to PowerShell, and click add. And we're going to select the script path. So under the linked artifacts, under drop, we'll select helloboris.ps1 and click OK. The arguments, we're simply going to copy them here. So the person's going to be the release.requested_for, and the trigger is going to be the build.definition name. So we're just defining the arguments that we need from within our PowerShell script. And then we're going to go ahead and click save and click OK. Back to pipeline, we could now go ahead and clone the QA stage, and we're going to create a new stage called production. In here, we're going to click the X sign at the top, where you could click the lightning bolt on production and make sure that it runs or it's triggered after the stage QA complete. Once that's done, we could give this pipeline a name, so hello Boris, and click save and click OK once again. Now that that's done, we could go down to the releases menu item, and we could basically click on create release and click create, and that's simply going to create the release. So we could see, if we click on that release, we could see the status. So it says waiting in Azure Pipelines queue. Once it starts, we could see that now we've started the tasks. We could click on it, or we could click on the logs as well to take a look at the logs down here, and we could basically look at what's going on in the QA stage. Once that finishes, the following stage is going to run the production stage. And once the production stage completes, basically our release pipeline will be complete, and we'll have successfully deployed the application. So it's just finishing up now. And if we click on log, we could see that we've succeeded here. We could go back to releases, and we could see that both stages have succeeded. Now let's just try and see if we change something within our file here. So we'll go back to repos helloboris.ps1. We'll click on edit, and we'll just click on write host, and then we'll just have two quotations. This will space trigger build, and then we're going to click commit, and we're going to click commit once again. Now if we go back, we should see that under pipelines we're going to have a new build running, and we see we do. We could click on that. Once the build succeeds, we're actually going to have a new release that's going to get automatically deployed as well, and we'll be able to track the progress. So basically everything's now in the CD pipeline. We just need to make a code change, commit it, and the build runs automatically. We could see it passed. Now if we go to releases, we should see that we're going to get a new release starting up, and we see it here. We could click on it, click on the log, and we'll see that it's starting up. And once that passes, everything will be running in a production environment. So we could see that release 2 has passed. We could click on production for logs, and if we just click on the PowerShell script, we could see hello Boris from Boris Mishanchevich. Trigger was hello Boris CI, and we see our message here. This will trigger with a build as well. So that's how we could go and implement a very basic CD DevOps pipeline using Azure DevOps. In this demo, I'll identify the various software stack types and how deployment for each is different. There are several popular software stacks which can be used to develop a full-stack application. A software stack is comprised of a set of components to build an application from the back-end database all the way to the front-end user interface. Choosing a popular software stack for a project has many benefits, as components of the stack are proven to work together optimally, and there's also plenty of documentation, open source libraries, and packages to build any type of application. Some of the most popular software stacks for FSD applications include the Mean, LAMP, Python, Django, and MERN stacks. The Mean stack is composed of a MongoDB NoSQL database, Express.js as the backend application framework, AngularJS for the front-end framework, and Node.js for the runtime environment. It uses a JavaScript everywhere approach, and along with the MERN stack is one of the most popular stacks for new full-stack applications. When a Mean stack application is deployed, Angular will create the application frontend, Express.js will create the application middleware, APIs, and routing, and the backend database will be created and managed by MongoDB. The application will run in a Node.js JavaScript runtime on the web server instance. When deploying a full-stack application, most continuous delivery and continuous integration tools will have an option to edit the configuration files and select the application type to deploy. For example, you could select Node.js. And they will also allow scripts to be set to configure pre-build options to install different packages, libraries, and so on, as well as post-build options such as to run tests and deploy options. In this way, it becomes straightforward to modify configuration files depending on the software stack being used. The LAMP stack uses Linux for the operating system, the Apache web server, the MySQL relational database, and the PHP programming language. It is currently the most widely used software stack, and it has been around for a long time. The LAMP stack applications are traditionally deployed to a server running the Linux operating system. However, both macOS and Windows can be used without an issue. The web application itself is deployed to an Apache web server, which is a cross-platform open source HTTP web server. The backend language for the LAMP stack is traditionally PHP, although Perl and Python are sometimes used as well. Since it contains no front-end framework, the LAMP stack is typically considered a backend stack and isn't truly full stack. The database for the LAMP stack is the open source relational MySQL database, which is one of the most popular relational databases in use for web applications. The Python Django stack uses the Apache web server, MySQL, or PostgreSQL database and the Python-based Django framework. This framework is popular for its ability to quickly build a simple full-stack application. The Django framework, written in Python, provides libraries which speed up the creation of an application. Django is primarily a backend framework for manipulating data sources, generating routes and APIs, and updating the object model. However, it also includes front-end features such as a templating engine, cache hooks, and an authentication mechanism. The web server for Django is usually Apache, although a Django application can be deployed on Nginx using WSGI or Junicorn web servers. The database in use for the Django framework is either MySQL, as in the LAMP stack, or PostgreSQL, which is an object relational database with more advanced features than MySQL. The MERN stack is identical to the Mean stack, but instead of Angular, the front-end framework is React and Redux. It is one of the most popular FSD frameworks for new projects, as it uses JavaScript at both the front and back end. And the React framework is also gaining popularity, and it's becoming the most popular and widely used JavaScript front-end framework. The main difference between Angular on the Mean stack front-end and React and Redux on the MERN stack front-end is that Angular manages state by data binding, while React with Redux manages application state by one-way immutable data flows. In this demo, I'll demonstrate how to develop and deploy a Java Spring full-stack solution. The Java Spring framework is designed in order to allow developers to build enterprise-grade web applications on top of Java Enterprise Edition. In this demo, we will be using Spring Boot, which allows developers to quickly create production-ready standalone Spring applications and to deploy them. We will create a simple Spring application using Spring Boot and then deploy it to Heroku by using the Heroku CLI and Git. The dependencies required to follow along with this demo are to have Java 8 to version 13 installed in your local environment, along with Maven 3.3 or above and the Java Spring Boot CLI, along with the Heroku CLI installed locally. There's also the requirement to have a free Heroku account set up and Git for Windows installed locally. Okay, so let's get started. The first thing we're going to do is we're going to go to the Oracle website and we're going to go to the Java SC downloads. And once we're on the JDK 13-downloads page, we're going to scroll down to the bottom and download Java SC Development Kit 13.0.1. I'm going to select the exe file for Windows. So that's the one second from the bottom, 159.84 megabytes, and download it. Now, I've already went ahead and downloaded it. So basically what you want to do is once it downloads in your downloads directory, you simply want to just double click it, go through the installation. It's very simple, and Java will be installed. Now what we have to do is we have to edit the environment variable. So we're going to open up our system properties, and under environment variables, we're going to go down and we're going to have to define an environment variable for the Java home. So it's just going to be all caps Java_home, and we're going to want to set the location where the JDK installs. So it usually installs under program files in the C directory in my case. So I just have it under C program files Java JDK-13.0.1. Once that's done, we also want to add Java home to our path. So we have here %sign Java_home %sign /bin in our path. So once that's done, we're going to go ahead and download Maven. So Maven's downloaded at maven.apache.org/download.cgi. And we want to download this one, the binary zip archive apache-maven-3.6.2-bin.zip. Once that's downloaded, we're simply going to want to extract that into a directory. I just extracted mine into program files. So I see here apache-maven-3.6.2. And we're going to want to go back to our environment variables and add that to our path environment variable as well. So you could see here I have C program files apache-maven-3.6.2 /bin in my path environment variable. Finally, the last thing we want to install is we want to download and install Spring Boot CLI. So if you do that manually under docs.spring.io, we have this page that simply tells us how to get started with Spring Boot and Spring. We could scroll down, and section 3 is installing Spring Boot. The manual installation is if we scroll down under 3.2.1, and we simply want to download the spring-boot-cli-2.2.0.release-bin.zip. Once that's downloaded, similar to how we installed Maven, we just want to extract it into a directory such as program files. So if I look at my program files, I have this spring-2.2.0.release. Then we want to go back to our environment variables. We want to have a Spring home environment variable, just like Java home. Add that location in there, and then add that to our overall path as well, just like we did to Java home. Once that's all done, we could open up a command prompt, and in here, we could make sure that everything's installed in as we intended it to be. So Java space -- version is going to give us our version of Java. MVN space -- version is going to give us our version of Maven. And Spring space -- version is going to give us our version of the Spring CLI. So once that's all done, we could actually go ahead and create a new project. So in order to do that, I'm going to be running the Spring space init space -- dependencies equals web command, and I'm going to specify the project name as Hello Spring. So that's just going to create an empty template project for Spring called Hello Spring. So I'll paste that in. And once that's created, I'll cd into it. And then what we could do is, now this project doesn't have any code that does anything. It's just an empty template. So we could go ahead and add some code. So I'm going to use my Atom code editor. We could also use Eclipse, but just for sake of time, it's a bit quicker to load up Atom. I'm going to use that. I'm going to go to Open File, and then I'll just find my project. And I'm going to go to Source, Main, Java, COM, Example, Hello Spring, and open demo application.java. So in here, I'm simply going to paste some code, which is going to be displaying Hello Spring. when we go to /. So just copy that in, go back to Atom, paste that in, save it, and then we could go ahead and run the application locally. So in order to run the application locally, we could run the command maven space spring-boot:\run. That's just going to run it locally on port 8080 by default. So back to our command prompt under our root directory, we'll run that command. And that's going to build and run our project. So once it's running, we could see it started. We could just go to localhost 8080. We'll just refresh this and we could see hello Spring. So everything's working as expected locally. So we're just going to close that. And now what we could do is we could actually initialize a Git repository, and then we could create a Heroku application to deploy it to. So let's do git init to initialize an empty Git local repository. And then we could do git space add space dot, which is just going to add all our files, git space commit space -m first commit. So we're just creating a commit. And once that's done, we could do Heroku space login to log in using the Heroku CLI. So I'm just going to enter a key. It's going to launch a browser, and we're going to be able to log into Heroku. Says it's logged in. Now we could close the page. We'll go back to our command prompt. Then we could run Heroku create. That's going to create an app, and then we're going to run git push Heroku master. Now once we ran Heroku create, it also updated the remote repository links to the newly created remote repository with the Heroku app. So if we run git push Heroku master, it's simply going to push to the master branch in that newly created remote Heroku repository. That's going to do a build, and it's going to launch our application. And we could use the Heroku open command to view it running on the web. So we could see that our application is deployed. So let's run Heroku space open. And that's just going to go ahead and open up our browser, and we could see that we're now running in Heroku, and we have hello space Spring exclamation mark. So that's how we could go ahead and use Spring Boot to create a very simple Java Spring application and deploy it to Heroku using the Heroku command line and Git. In this video, I will identify deployment strategies for different tiers of the full stack solution. Continuous integration, or CI, and continuous delivery, or CD, is a crucial piece in modern-day software development. As a quick review, CI involves building and compiling a project, running unit tests, code analysis, and packaging a project for delivery. A CD pipeline takes CI one step further and takes code from a developer commit to a fully deployed and tested application running in a production environment. There are various strategies or best practices when implementing CI and CD pipelines, including performing daily mainline commits, using version control tools, automating and releasing often, using virtual test environments, and displaying reports and build logs. We will dive into each one of these in more detail in the next few slides. The idea of developers merging small commits on a daily basis from their local branch to the remote mainline branch and running automated test cases on each commit ensures that an application won't have large integration issues when it comes time to do a release into production. With a proper CI or CD pipeline, automated unit tests can be run by a developer in their local branch once they are done their code change. If all the tests pass, the developer can then commit the changes and merge them into the mainline branch, at which point the CI service would trigger a build to ensure that everything is compiling and testing as expected. Version control tools such as Subversion and Git help to keep all the files of a project in a central location with a history of all code updates, and they also ensure that all developers are working on a sync code base. Version control tools can run either in the cloud or locally, with a typical setup using a tool like Git is having developers install Git locally and then push their code changes to an online-based repository such as GitHub. The version control repository should store not only source code, but also things such as configuration scripts and database script files, as they are crucial in successfully building an application and may be needed to be modified by developers when new feature changes are added or existing features are updated. Open source version control tools such as Subversion and Git provide good documentation and are high quality with support from a big development community, and they're often adequate for most project needs. Version control tools enable the use of multiple branches in parallel, which basically means that there are different environments where different code changes can occur, such as bug fixes and new feature development. Branches can also be local tracking copies of a remote branch, such as the mainline branch, where developers can do work locally and commit to the mainline remote branch once they're done. Branches can be merged into other branches once features and code changes are adequately tested. There's generally one mainline branch, which is the branch that most developers work out of and is the main branch for a project. Generally, a project should limit its number of branches to only the essential branches required to avoid merge conflicts and out-of-sync code bases. With the help of continuous integration tools such as Jenkins, builds can be run in a consistent and automated fashion through the use of build scripts. These build tools can also check to see which packages need to be rebuilt and only build the newer or updated features and their dependencies instead of doing a full fresh build every time. Once the build passes, the CI tool can deploy the application to a testing environment, which is often a clone of the production environment, where it can automatically trigger an automated test suite to run on the application to ensure that new changes work as expected before being deployed to production. Automated rollback scripts are especially useful if deploying to a production environment, because if an error occurs, an application can automatically roll back to a safe and working state. Automated rollbacks give developers confidence to update features more frequently and to push them into production, as they have the peace of mind that if something breaks, it won't cause the application to crash. A continuous integration pipeline uses multiple environments to run unit tests, performance tests, and integration tests. In order to automate the deployment of the application into any one of the environments, scripts need to be used. As I mentioned in the previous slide, a test environment is often the clone of a production environment and contains the same libraries, hardware, networking, and database setup as the production environment. This is because the test environment needs to simulate the same type of conditions that an application will be under when it goes into actual production. With the popularity of virtualization and virtualized environments, a fresh test environment can be created on demand, and multiple test environments can often run in parallel on one machine. When the testing completes, the test environment can be taken down in an automated fashion by the use of scripts. Sometimes, due to communication and performance limitations, there is the need to have two test environments, one for post-commit tests and another for pre-production secondary testing, such as integration, performance, and security testing. Displaying reports and build logs helps team members get a big picture view of what is happening in the CI or CD pipeline. Build logs can display things such as build status, unit and integration test completion, and error messages. Oftentimes, it is easy to figure out why a unit test may be failing, but with more complex integration tests, this becomes more difficult as there are more modules and software packages in play. That is why logging frameworks needs to be used, which logs errors in detail and provides insightful error messages to help fix problems. One thing to consider with logging is the performance penalty for logging too much data. Generally, production-level applications should keep logging under normal circumstances to a minimum and only provide detailed log messages in case of errors. The status of the mainline build needs to be available to all team members and developers, and this is often easy to integrate with a CI tool such as Jenkins. Jenkins has a web dashboard which team members can view, and it displays sunshine for a passing build and storm clouds for failing builds. It can also send automated emails to all team members on a daily basis on the status of the build and include any error messages if a build fails. Log files need to track all CI and CD pipeline activity in order to help paint a complete picture of what is going on with the build, test, and deployment phases of an application. By having a strong logging foundation in place, it not only gives team members a big picture view of what is going on, but it also helps surface critical issues for quicker repair. In this video, I'll identify how to deploy full-stack solutions to Git and other platforms such as Heroku and DigitalOcean. Git is a popular distributed version control system for tracking code changes during a software development project. Source code versioned with Git is stored on the internet by hosting providers such as GitHub. Git projects can integrate with many CI/CD tools such as Travis CI and Jenkins. Heroku is a platform running in the cloud for deploying applications written in various languages. It uses Git version control to manage and deploy its projects. DigitalOcean is a cloud infrastructure provider which allows users to deploy and scale applications on virtual machines which they call droplets. Projects using the Git version control system can be deployed automatically using CD tools and scripts to DigitalOcean droplets. There are several alternatives to deploying projects using Git, including SFTP, FTP, SCP, and rsync. SFTP, or Secure File Transfer Protocol, is a network protocol which uses SSH, or Secure Shell, to securely encrypt, transfer, manage, and access files between a client and web server. FTP is the same as SFTP, but data is not sent over an encrypted channel. SCP, or Secure Copy Protocol, is a network protocol intended for transferring files using SSH between either two remote servers or a local host and remote host. rsync is a data transfer and synchronization utility which typically runs in a Linux environment. It is used to synchronize files between two systems. Advantages of using SFTP, FTP, SCP, and rsync over Git is that these tools can transfer an already pre-built application to a server for more rapid deployment. With Git, applications need to be built on the server after code is pushed to it, so server downtime is increased. Git has an advantage over other tools mentioned in the previous slide, as it keeps a detailed version history of all files which are being deployed, and only changes to an application code base are pulled into the repository at any given time, so that it is faster to transfer files. Some of the commands most used with Git are git pull, git push, and git remote add. Git pull is used to fetch the latest version of an application's code from a remote repository into a developer's local repository. Once a developer makes changes to the source code, they can add and commit any source code files that they have updated, and then use the git push command to connect to the remote repository and update the local commit code changes into it by using either a secure SSH or HTTPS connection. Git remote add is a command which is used to set the remote repository URL to push and pull from. For example, the command git space remote space add space production, followed by the URL of the Git repository, would use the HTTPS protocol to pull and push changes to the remote repository production branch. In order to deploy a project to the Heroku Cloud Platform, a project must first be initialized to use Git version control. You would then need to use the Heroku create command, which when run from an application's root directory will automatically add Heroku as a remote repository to the application. The Heroku remote repository can then be renamed with git remote rename if there is more than one Heroku application using the same application code. And this would be the case if there are multiple environments being deployed, such as separate applications running in staging and production environments all using the same codebase. Once the remote is set, the git push space Heroku space master command can be used to push code changes to the Heroku remote master branch for deployment. As I mentioned, DigitalOcean uses virtual servers, which they refer to as droplets, for deploying applications. When creating the droplet, the Ubuntu 14.04 droplet image is a good choice for compatibility with CI and CD environments. There are various ways to deploy an application to a DigitalOcean droplet, including pulling code changes from a repository using Capistrano or SSH, copying deployment files from the CodeShip CD tool using SCP, and copying CodeShip deployment files by using rsync. Capistrano is the deployment option of choice for Ruby on Rails projects which are to be deployed on a DigitalOcean droplet. Capistrano is a remote server tool for automation, and it executes scripts on multiple remote machines in parallel using SSH. It allows the copying of code from Subversion or Git repositories using SSH and can execute pre- and post-deploy functions such as restarting a web server and migrating databases. SSH can also be used to provide commands to a DigitalOcean droplet by using a script in order to do things such as git pull and restarting web servers. The other option is to specify scripts on the DigitalOcean droplet to copy deployment binaries built with an external tool such as the CodeShip CD tool using SCP or rsync, FTP or SFTP. It is important to include the CodeShip project SSH key into the DigitalOcean droplet to ensure that files can be copied over without any issues. In this demo, I will demonstrate how to use Git to deploy full-stack solutions. Git is a free, open-source version control system which runs in a distributed fashion. It is used by software developers in order to keep track of software and code changes during software development. The most popular place to host software development projects on the internet is GitHub, which is a hosting platform for projects built with Git. In this demo, we will be creating a simple Node.js and Express.js application with one automated test case. We will add this application to a GitHub repository, and we'll create two branches, one used for development, which will be the default master branch, and one used for production, which will be used to push and deploy our project to Heroku using the Travis CI continuous integration service. In order to follow along with this demo, you need to have a free GitHub account along with a free Heroku account, as well as Node.js version 10 and Git for Windows installed in your Windows 10 environment. So let's get started. Here I am in my Atom code browser in the Hello Node project, and I'll just quickly go over it. So I have my main server file index.js that simply has one route that's sending Hello Node between lines 5 and 7, and it's listening on port 3000. I also have a test directory with a test.js file, so that's running supertest and mocha tests. So I have one test which is basically ensuring that I'm getting the Hello Node displayed in my browser under the /root. I also have a proc file, so in here it basically specifies how Heroku is going to run our project. So node space index.js, which is our main server file, package.json, which specifies all the dependencies, and on line 7 for the tests it specifies mocha for the testing, and then space -- exit, which means that mocha will exit once the tests pass. I also have a Travis.yaml file, which I'll go over later, a git ignore, and I have my node module. So a very simple project. If I go to my Windows command line, I could go inside my Hello Node directory and just run npm test to make sure that all my tests pass locally. And I could see here that I am getting Hello Node displayed and the test is passing. So let's go into our browser now. We'll go to github.com/your account. We'll go to the top right, click the plus sign, and new repository. I'm going to give the repository a name, so I'll call it hello-node-boris. Description will be blank. It'll be a public repository, and all the other fields will be just the default. I'll click create repository. And then I'll go ahead and open up my Windows browser. I'll minimize it a bit for my command line here. And I'm going to run these commands here to initialize my repository. So git init, which is going to create a new empty repository. I could do a git status then, and that's going to show all the files that are going to get committed. So git add dot to add all those files, git commit -m, and I'll type in the comment for the commit as first commit. Once that's done, I'm going to have to add my origin, or my remote origin. So git remote add origin. I'm going to specify https://github.com, my username / my repository.git. So I'll just copy in that command, hit enter, and then I'm finally going to do a git push u origin master, which is simply going to push that commit to our master branch inside that GitHub repository we created. So once that's done, I want to create another branch for our production. So I'll run git space checkout space -b, and I'll call it production. So that's going to create a new branch and switch to it. So if I go git branch, I should see I'm in my production branch. I could now push the changes to the production branch as well. So git push origin production. That's going to simply update my production branch with the code inside GitHub. So once that's done, I'm going to want to switch back to my master branch, which is where we'll be doing our development. So git space checkout master, and then I could go git branch and make sure I'm in my master branch. So now that we're all set up here with GitHub, we're going to go into Heroku, and under dashboard.heroku.com/apps, we'll create a new app. We'll go to new, create new app. We'll give it the name, so hello-node-boris, and the region will be in the United States. We'll click create app. Under deploy, we'll scroll down. Deployment method will be GitHub. We're going to want to connect to GitHub, so under my username, I'm going to search for hello node, and I could see my repo comes up. I'll click connect. Once that's connected, I want to go to automatic deploys. I want to choose the branches production and select wait for CI to pass before deploy and enable automatic deploys. So now that Heroku is all set up, we could go to Travis CI. So I'll go to another browser window, travis-ci.org. I'll click on sign up. That's going to sign me in. It's going to update all my repositories from GitHub. So if I click the plus sign here, add a new repository, I could see all my existing repositories here. So hello node Boris, we're just going to want to turn that on. And that's all we need to do. So now we're going to go back to the Atom code browser and we're going to edit our .travis.yaml file. That's basically the file that tells Travis how we actually want to configure and run the builds and how to deploy to Heroku. So we're going to specify on line 1, Node.js, the version's 10. Before install, we're going to install npm globally. We're going to have some scripts, so we're going to run npm install, npm test, which is going to run our test case. And then for the deploy settings between line 9 and 15 is just going to be our deployment settings to Heroku. So the provider will be Heroku on line 10. On line 11, the API key. So just to note, this API key is supposed to be encrypted in the production environment, but since we're just doing it for a demo, we just have the actual API key. To get the API key, we'll go back to our browser, enter Heroku, we'll go to our account at the top right, click on account settings, scroll down. Under API key, we could click reveal, copy and paste that in to our .travis.yaml file. Finally, the app name, it'll be the app we created in Heroku, so hello-node-boris. On the repo on line 14, bmislgn/hello-node-boris, that's our GitHub repo we created, and the branch to push to Heroku's under production. So once that's all done, we could save that file, put it into GitHub. I've already done that, so what I'm going to do is I'm just going to go to test.js and I'm just going to edit the comment on our test case. So I'm just going to delete on our browser on line 6 and simply have make sure that we are getting hello node. I'll then go file, save. Once that's done, I could now go to git status and I could see I'd modified my test.js file. So I could go git add space dot git commit m, and I'll simply type modified comment. And once that's done, I could go git push origin master, which is going to update that commit into our master branch on GitHub. So once that commit is pushed, we could go back to GitHub. And if I go back to my hello node Boris repository, I could click on new pull request. And what we're going to do is we're going to select the base as production and we're going to compare it to master. So you could see here that we have an addition we basically deleted on our browser in our comment. And that's going to get pulled. It's going to be a pull request to pull that into our production branch. So I'm just going to leave a common updated comment text. And then I'm simply going to click create pull request. So now since we have Travis CI hooked up, it's actually going to create a new check. It's going to run the build and run our automated test case. And once that works, we're going to have to merge it in to our production branch. So we could see that all our checks have successfully passed in Travis CI. So now we could click on merge pull request. We're going to leave that same commit message modified comment and click on confirm merge. Now this is actually going to trigger another build with Travis CI. And if we go back to our Travis CI, we could click on dashboard, my builds, and we should see a new build being triggered on the production branch. So once that build's triggered, it's actually going to build based on the Travis YAML file. It's going to run the automated test. And if everything works as expected, it's actually going to deploy our pull request merge into Heroku. So we could see the build starting here. It's going to take a few minutes. Once it passes, it should be up and running in a live Heroku production environment. Okay, continue. So now that the build completed, we could go to dashboard.heroku.com/apps. We'll click on hello-node-boris and we'll click on open app in the top right, and we could see hello node exclamation marks being displayed. So that basically means that the build and test succeeded, and now the app is successfully deployed on a live Heroku production environment. In this demo, I'll demonstrate how to deploy full-stack solutions to Heroku. Heroku is a cloud platform as a service that can deploy and host full-stack applications developed in various programming languages, such as Python, PHP, and Node.js to the internet. Heroku uses Git for version control when deploying a full-stack application, so that an application needs to be initialized as a Git repository first, and then the Heroku CLI can be used to initialize a new remote repository on Heroku and push code to it for deployment. The Heroku CLI by default creates a remote repository called Heroku. This can be renamed by the use of the git remote rename command. One reason why renaming the Heroku remote would be beneficial is in the case that there are multiple instances of the same application deployed in Heroku, running in different environments such as staging and production. In order to follow along with this demo, you will need Node.js version 10 or better and Git installed for your local environment, as well as having a free Heroku account set up and a Heroku CLI installed in your local environment. So assuming you have a Node.js 10 or better installed in Windows 10, which is the environment that I'm using, as well as Git, I'll show you how to install the Heroku CLI. So basically, we just want to go to devcenter.heroku.com/articles/heroku-CLI. We'll scroll down, and I'm using Windows environment, so under Windows, I would click the 64-bit installer. That would download the exe file. I would accept all the defaults, install it, and that's going to add Heroku to my path as well. Once that's done, I could then open up my Windows command prompt, and I could simply type Heroku space -- version, and I could see that I have Heroku installed. So what I'm going to do now is I'm going to open up the Atom code browser, and inside here I'm going to go to my hello_node, Node.js, and Express.js project. So I'm going to go over a few files. It's basically just a hello world project for Node.js using Express.js. So my index.js is my main server file, and here I have I'm defining on line 1 that I'm basically requiring Express. On line 2, I'm creating an Express app. I have one route between line 5 and 7. It's just going to send hello node to the browser, and then I'm going to listen on port 3000. So very basic. In my package.json file, I have all my dependencies. So I need Express here on line 13. I also am using Mocha for my tests, so I'm defining that on line 7. And my dev dependencies, I'm also using supertest for the HTTP request for the tests, and npm. So once I have that defined, I can now take a look at my test.js file. So that's once again under the root hello node directory in the test directory. My test.js file defines one unit test, and it's basically going to test here on line 10 if we're displaying hello node in the browser. If not, we're going to throw an error saying missing hello node. Finally, the proc file is what actually tells Heroku how to run my Node.js project. So I have web:/node index.js. And that's basically going to run my main server index.js file in Heroku. So once that's all done, what we could do is we could go ahead and run it and make sure everything's working. So I'm just going to go inside my root hello node directory in my Windows command prompt, and I'm going to run npm test, and that's just going to run the Mocha unit test. I could see it's passing. It says displays hello node. Then I could run npm or node index.js to run my main server file, and it says app listening on port 3000. And I could go to port 3000, refresh, and I could see hello node appears. So everything appears to be working as expected. So now what we're going to do is we're going to go ahead and we're going to initialize an empty Git repository. So git init. Then we're going to do git add space dot, and then we're going to do git space commit space -m first commit, and close the quotation marks. And then once that commits in there, we're going to type in Heroku space login. That's going to log in to our Heroku CLI. It says press any key to open up the browser to log in, so I'll press a key. The browser is going to open up, and we're simply going to click login. Once we're logged in, it says we could close the page and return to our CLI. So we'll do that. We could see that we're logged in. We have our Heroku free account is displayed. Next, I'm going to type in Heroku space create, and that's just going to go ahead and create my application in the remote Heroku repository. Then I could also type in git space remote space -v. That's going to display all my remotes, so I could see I have my Heroku remote is automatically added. And then I could just do a git space push space Heroku space master, and that's going to push my commit to the remote Heroku master branch, and we could see the build starting. It's installing all the dependencies, modules, and so on. And once that's done, we're going to have the application deployed on our Heroku application in the internet, and we'll actually be able to open it up and see the hello node being displayed in our browser. So we could see that it says here build succeeded, and now it's just compressing, launching, and we could see it's complete. I'm going to go ahead and open up my browser. I'm going to go under dashboard.heroku.com/apps. I'm going to refresh that. We could see one app is created, so Whispering-Everglades-67839. Click on that. And I'm going to click on Open App, and we could see hello space node exclamation mark. To do any changes to our code base, we simply have to add it, make another commit, and then push it again to the master branch to the Heroku remote. It's pretty simple, and it should be running in Heroku. So in this course, we've examined the deployment of full-stack software solutions, including available tools, strategies, and best practices. We did this by exploring strategies for deploying full-stack solutions to local and cloud servers, security strategies when developing and deploying full-stack solutions, the differences between deploying traditional software projects in FSD Agile project, and the tools available for deploying full-stack solutions, how to perform a FSD continuous deployment, and how to use Azure DevOps to deploy full-stack solutions, the various software stack types and their deployment, how to develop and deploy a Java Spring full-stack solution, full-stack deployment strategies and platforms, and how to perform a Git deployment and a Heroku deployment. In our next course, we'll move on to explore the CI/CD pipeline for FSD, including benefits, tools, and the implementation of a CI/CD pipeline.
In this video, I'll describe the best practices for RESTful services. I'll describe the principles that are the basis for a RESTful service. So the REST architecture describes 6 constraints that were originally described by Roy Fielding in his doctoral dissertation in 2000. So they've been around a while now. The first is client-server. Then we have the stateless requirement, the cache requirement, the layered system, the uniform interface, and optionally the code-on-demand constraint. So over the next 6 slides, I'll describe each one of these constraints. The first is client-server. So we think of this as a separation of concern, where the client is concerned about the user interface and user experience, the UI, the UX, and the server is concerned with the computation, the data storage, and the business logic, and each can be developed independently. The statelessness constraint is a tougher one, the idea being that the server and client contexts are independent. So the state of the client application isn't held in the server. The goal is to keep them separate so that they can be developed separately. The server need not know what the UI state of the client is and should not matter when updating a resource. So the server can be built in a way to serve many different client applications. Then we have the client requests, where there's no stored context sharing. So the server need not know what the state of the UI is, the UI state of the client, and it should not matter when updating a resource. And the client doesn't need to send partial updates to a server, and the context of the client doesn't need to be known by the server, nor the context of the server need to be known by the client. And the server persists information, where the visibility, reliability, and scalability is a concern of the server. So the client could potentially replace a RESTful service with another one. So long as they provide the same entities and interfaces, they could be potentially implemented completely differently under the hood. So you could replace a PHP and MySQL RESTful server with a Python and Postgres one, and it should not affect your client application. Again, so long as the outward RESTful endpoints provide the same HTTP interface. Now the interface must be uniform, so that's another constraint. The way we interact with REST architectures is consistent, and the general engineering approach follows the same set of guidelines. So REST is a simplification of interface, and the visibility is an improvement. So the implementation is decoupled or independent of the application, which may be constraining in some applications and might hurt short-term performance or efficiency. But long-term, the application should evolve in a way that's easier to maintain. And it is web optimized, either through the browser or other applications that rely on HTTP requests or transfers. It is built as a consistent resource interface to identify, describe, and manipulate entities that are persisted or computed through a web server. And the system must be layered, usually in a hierarchical fashion, where complexity is constrained so that each component of the system, each library or service or utility, only interact with its parent or sibling layer, but doesn't rely on the current state of the wider system. So we're encapsulating shared intermediaries, which is especially important if you're migrating from legacy services. You can build around the old software with new clients and new architectures while you limit the exposure of the legacy codebase. And it does make it easier to scale and often enables you to load balance services across multiple systems. Now, the drawback here is that it can lead to more overhead and a latency that a monolithic system might not be initially susceptible to. But usually long-term, the maintainability and higher scalability of the layered system provides better overall performance. Then we have the caching constraint. So in order to speed up some client-server interaction, caches are used where possible. So there can be different levels of caching as well. The client can cache some information, some entities it refers to, but it might not be data that doesn't change very often. So we might be able to load it inside the application once and refer to it without re-requesting it for every action. Then at the web server or reverse proxy layer, our HTTP service, we can use caching within our Nginx or Apache web server or whatever server we're working with. And then we have caching inside of our application. So this is one of the most important parts of the cache. So we have in-memory caches, so we don't have to read the information off of disk every time there's a request made. We can use cache services such as Redis or Memcache to speed things up. And finally, we have the optional constraint of code on demand. Now, when REST was first described, the web still had Java applets commonly run in web browsers. So this code deployment is a difficult one because it makes the statelessness and layered system requirements a little more difficult. But if our client is a web browser, which can now run JavaScript, it might be possible to incorporate JavaScript in the REST endpoint response. Now, we often use JSON, JavaScript object notation, as the data format, but that's something different. We can actually return JavaScript code, but we're not limited to that. So most often we don't rely on a server to deploy code for the client, but this is an option and may be useful depending on your application. And that concludes this presentation on RESTful Services Best Practices. In this video, I'll describe some of the challenges related to RESTful services. So 3 of the big challenges in implementing RESTful services are statelessness. So this is managing sessions and layers in your application, dealing with many user agents, so enabling different browsers or HTTP libraries, or command line utilities in some cases, and caching and proxying. So this enables horizontal scaling. So let's talk about these individually. So the first is statelessness. So this often results in larger request sizes, which may or may not be an issue, but we don't rely on the server to keep any information about what's happening in the client application. So keeping that separate often requires the client to send larger requests with each request. Dealing with resource management so that the client doesn't manage persistence without the server or database backends. And then the application state, which is never relayed to the server. So the client keeps that to itself, and the server keeps its own state separate from the client. So one that comes up quite often is dealing with authenticated sessions for protecting resources. So some implementations of REST prefer a session-agnostic server, where an authenticated or logged-in state, managed both on the server and client, is avoided, which strictly speaking, some consider this to break the statelessness constraint. So what ends up happening is the authentication information gets passed as an encoded or encrypted token from client to server on every request, making it a larger request. The server then has to decode the token and determine whether or not the client is allowed to access a particular resource. Now I see the authentication mechanism as something inherent in the HTTP resource access, with an authentication header, which is handled at the protocol level, separate from the resource layer, which is still stateless even with this. The next is user agent support. The challenge here is making assumptions about what the capabilities of the client application are, if many different user agents exist, like the web browser or different browsers or GUI frontends, like command line utilities accessing our service, or as part of other applications through HTTP libraries. One of the goals of statelessness is that the client can be platform agnostic. As I mentioned in the video titled RESTful Services Best Practices, if there's a code on demand layer inside of the RESTful service, it may preclude some clients from using the service. The next challenge is caching and proxying. We could be talking about caching as in local storage in the browser or its cookies, or stored somewhere in the client to cache commonly used but rarely changed data. We could be looking at the server layer, such as HAProxy or Nginx, or Apache HTTP, or some other frontline server or reverse proxy, in front of our application's code. Do we implement a cache at this layer? Is it appropriate for our application? Or do we use an in-memory database or a key value store for frequently accessed information so we can get it quickly when data is requested and re-requested very often? Can we use Redis or Memcached or rely on the database server such as Postgres to cache the data in memory? These are all challenges we need to deal with when working with caching. In terms of proxying, quite often we implement a reverse proxy to enable horizontal scaling or load balancing or even version management, using a regular expression on the URL to detect a v1 or v2 in the URL and route the request appropriately. So we implement URL rewriting to redirect the request to the appropriate service or endpoint, of which there can be several, and nothing stops this from running on different physical or virtual servers that reside in your server infrastructure. All of this can be a challenge, but it's done with the goal of scalability and decreased latency in mind. And that concludes this presentation on RESTful Services challenges. In this video, I'll identify some of the important activities for RESTful API design. So the 4 key elements of the RESTful API design process are resource naming. So resources are the paths or endpoints in an HTTP request which point to an entity. We'll see some examples of resource names, good ones and bad ones, on the next slide. We have HTTP methods, so these are the verbs which describe the actions we're taking on our resources. We have the response codes. These are the HTTP status codes that are returned from our RESTful service. So that gives us the status of the response, whether it's successful or there's an error or something else. And then finally, the data formats. How do we communicate, in what language? How is our data structured in the requests and responses that we have in the protocol with our RESTful service? So the first is resource naming. So let's have a look at some of the examples of good resource names. So we'll start, given an HTTP request, we have a URL with a host name, so www.something.com, and then we have a path after it, / in this example, users, and a number. So this points to an entity, users, and an ID specifying a single resource in that entity. So user ID 48175. The entity names are plural. So if, in this case with customers, we don't specify an ID, which means we intend to return a collection of customers. So it doesn't have to return a single entity or a single resource. It can return a collection of resources. If we have a relationship between entities, let's say between customers and their orders, so an order tied to a customer, we can have an entity like customers, so customer ID 2468, and orders 1243, the order belonging to that customer. So we intersperse the entity and IDs. We can also have version numbers. Let's say we have version 1 and we specify v1, it should come first. So it's prepended to the request path. So we have /v1/auth, and this is the auth entity for authentication with v1 version. So there might be a v2/auth, so it's always prepended to the path. Now, what are examples of poor resource names? Well, using the get request syntax with a question mark and the name equals value ampersand delimiters is generally considered poor form when it comes to RESTful API design. Now, this is fine for other APIs, but in the REST process, we don't use this sort of naming. So /API question mark entity equals user ampersand ID equals 48175 is not recommended. We usually have plural entity names and not singular. So in typical REST implementations, we use plural. Even if we intend to have a single element, we don't say customer with a number or customers for a collection. We just say customers / and an ID. So we always leave it plural in the URL. If there's a relationship between entities, we don't stack them with entities first followed by IDs. We always intersperse them with the entity, its corresponding ID, the next entity or its related entity followed by another ID. So /customers /orders /2468 /1243 as an analogous way of calling the one we have on the left-hand side in the good resources names is not recommended. And then finally, appending the version number is not recommended. The reason why we put it first is it makes it easier for any sort of reverse proxying or direction of resources to their correct applications. So the correct application server, if we look at v1 as the first item in the path, we can always say, okay, go to the version 1 application server, our REST application server, otherwise go to a different one. So we can direct the traffic according to version much easier if it's prepended. Now we have the HTTP methods. So I'll go over the ones that are most commonly used, the ones that you typically implement, and the ones that are not often used, and the ones that we don't implement in RESTful design. So the important ones are GET. This retrieves the data and should only be used to retrieve data and never modify data. So we never modify a resource with GET. If we want to submit a new entity, we use a POST. So we create a resource with POST. If we want to replace a resource, so PUT replaces an existing resource, patch modifies a resource, but it only applies a partial modification of a resource. And the delete HTTP method deletes the resource. So head is not often used, but occasionally it's used to query the HTTP header data for a GET request. So it's used in place of a GET request, and it's quite useful if dealing with large resources, you need to query the size of the resource before requesting it. So the server will return and say the response is going to be this many bytes in size. So if you need to check that, you can always call head if it's implemented correctly. Or if you need to be authenticated, you can always test whether you have access to retrieve a resource before you request it by just calling the head. But that's not an essential method for RESTful design. And the other HTTP methods a part of the standard, connect, options, and trace, are rarely implemented in RESTful design, so I wouldn't worry about those unless you need a particular use in your application that's somewhat outside of the standard RESTful design. But you don't need to implement the ones on the right-hand side, the head, connect, and options and trace, but the 5 on the left are generally implemented. You don't always have to implement patch, but for a full entity, you should implement get, post, put, and delete. Next are the response code. The main one is 200, which is OK, which means success, and it usually returns the data along with the response. There's 201, which means created, and this is often a post request where we create a new resource, we return a 201. And we have a 204, a no content. So this is often a response to a delete, where the request is successful and the resource has been deleted, but no content needs to be returned in response. So it's successful, but there's no extra content returned along with it. 400 is bad request, which means the request is not parsable or there's some error in how it's formulated. 401 is an unauthenticated request. 403 is forbidden, so you don't have access, or you're authenticated, but you don't have access. 404 means that the endpoint you're trying to call is invalid, or it's a valid endpoint and the resource for it can't be found. And then 500, or the 500 class of errors, is for internal server errors. So the server has crashed or can't handle the request in some way where the application fails. And finally, we have the data formats. So we have the common data formats. So we have JavaScript object notation, JSON, which fits well with most web browsers, which all natively support JavaScript. But any client in most modern languages have a way of parsing JSON easily. And XML, which was more common in APIs 10-20 years ago, but is less so now. But it's still used in many RESTful services, and many have XML as their main format or as an option along with JSON. And the uncommon formats that you occasionally see are YAML, CSV, or some binary data format. So these are not often used as the main communication format, but they can be used as a special export format for some applications, or if there's some particular requirement in the application. But most commonly, you'll see it implemented in JSON. And that concludes this presentation on RESTful Services API design. In this video, I'll describe some of the most frequently used categories of packages used to extend the features of RESTful APIs. So there are 5 categories that I'll cover that should be handled or packages be used to manage. So in a framework like Python Flask, there are many Flask extensions used to handle these features. So the 5 are validating inputs. So this is to enforce data types such as integers or strings or floating point values, that the ranges of possible values are enforced, the minimum and maximum values for numeric values, the maximum lengths for strings, and we need to return the correct response code or error code with info when there is an error. We have the data storage, ORM, and data migration tools, which I'll talk about more in the next slide in a little more detail. We need to take care of testing, so using automated testing and TDD, test-driven development. So we use test frameworks such as PyTest, and for each change in an API, the test should be rerun regressively. Authentication, and I'll leave this one to talk about in more detail in its own slide. And finally, data export. I mentioned the data formats in more detail in the video titled RESTful Services API Design, but what I will mention now is the data export feature. So some RESTful services, some RESTful APIs can be built to export data in different formats, even if the way you implement it is in JSON. By supplying additional parameters, you can engineer it so that it returns other formats, maybe PDF or an image or a spreadsheet document. This is separate from the typical operation, but exports often enhance your application in other ways and make it usable by a wider audience. So now I'll take the next two slides, the first one to talk about data storage, ORMs, and data migration, and the following slide to talk about authentication. So what I'm interested in here is data persistence of our resources. So we want our application to save data on the server in a database. So with data storage, we're not necessarily talking about SQL databases, although that's the most commonly used method. We can also use NoSQL to manage resources, and we can even use files. Say if you want to handle image data or video data as part of your application, we'll need to extend our RESTful services to handle these formats as well and store them separately. We often employ an ORM, an object relational mapping, to translate records from our database into objects described in our programming language of choice. So a Python class to hold data from a database record that we read. This also lets us query a database using Python instead of SQL. So it provides a useful abstraction to often simplify things, simplify how we access our databases. And we have data migration. So this is changes to the schema of our data storage. So it's altering our database. So if we alter a table, we need to be able to manage the changes and roll back if necessary. In the case that there's an error, we need to be able to recover from it and revert to the previous version. And the next item, the last item that we need to think about when we're extending our RESTful service is authentication. So this is access control. For this, we use session management with session tokens or JWTs, JSON Web Tokens. So we can use the HTTP headers for authentication or cookies if we want, where we manage access control to our server, or through an encrypted token, a JWT, that is sent back and forth between client and server. So if a particular client or class of users only has access to a subset of resources, our application must be extended to validate the endpoints, and some extensions allow for using Python decorators, so the @decorators for our endpoint methods, to declare them as restricted, or that they require an authenticated user to access. So some endpoints can be public, and some can require authentication before accessing. We can even take the approach where we have read-only endpoints for some users, and allow write or modify access to others. These are common cases when extending RESTful services. And that concludes this presentation on extending a RESTful service. In this video, I'll demonstrate how to implement the tools to sanitize data in our RESTful APIs. So we're going to have a model and schema used to validate the data, as well as create the database that I'll be using in the subsequent videos titled Implementing a Handler for the get, post, put, patch, and delete handlers. So there'll be a video on implementing each one of those. So we'll start in my working folder. In my home folder in Documents REST 06, I have the example for this demonstration. So I'll type the tree command, and we can see what the contents of this directory is. So there's a folder in here called app, and under it there's an API/v1 folder that contains a single file book.py. So this is where the endpoints, the handlers, will be defined in this particular book.py. But we won't be focused on that in this video. There's also an app.py in the app folder, which creates the Flask application, an extensions.py folder, which sets up the extensions that are going to be used by our API. So in the subfolder model, there's a file called book.py. So this contains the model, the SQL Alchemy model that maps to our database. So this is for our ORM. So it maps a table or a record inside of Postgres to a Python object which we define in book.py. What we use to validate the data that we receive is in bookschema.py. So I'm going to explain the contents of book.py and bookschema.py. The other important file is in the current folder initdb.py. So initdb is going to create the database in Postgres, the books database. It's going to create a table called books, and in the book, the actual structure of the table is going to be based on the model, book.py. So it's a SQL Alchemy model that creates a table. And I'm going to use book schema to create a single entry, a single record, to insert into the database as a test record to get us started. So now I'll switch over to Emacs, my editor, and we'll look at the contents of some of the files, the important files that define the model and schema and are used to validate and sanitize our data. So in extensions.py is where I bring in SQL Alchemy. So from Flask_SQL Alchemy, I import SQL Alchemy. From Flask Marshmallow, I import Marshmallow. And from Flask RESTful, I import API, which is not used in this video, but will be used in future videos. Then on line 5, I set the DB equal to SQL Alchemy and Marsh equal to Marshmallow. So I instantiate the objects that are going to be used. So I'll close extensions and have a look at book.py. So this is the book.py in the model folder. So from app.extensions, I import db, which is the file I just had open, and this is our SQL Alchemy link. And then from datetime, I import datetime, because I'm going to use that to get the current date and time. So I define a class book, which inherits from db.model. So this is the SQL Alchemy way of doing it. So we're defining our ORM, our object relational mapping, for a table that's in the database. And on line 5, I have table name with the _ prefix and suffix equal to the string books. So the table is going to be called books. On line 7, I set an ID column equal, so I have ID equals db.column. So again, we're using SQL Alchemy, the column definition. The type, db.integer. The extra parameter, in this case, the ID is going to be a sequence inside of SQL Alchemy. So it's an auto-incrementing number. So db.sequence, and I'm going to call it book_ID_SEQ. And this is the primary key. So I set primary key equals true. I set a title for the book. So title will be a string column, so it's equal to db.column, and a single argument, db.string. The same thing for author, which is also a db.column with db.string as its type. Publication year is another column of type db integer. And created date, in this case, the db column is of type db datetime, and its default is equal to datetime.utcnow. So this is going to give us a timestamp when the entry was entered into the database. And now I have a representation of it, so def of reper for representation with the _ prefix and suffix. So this is a member function of book, and I return the string with the angle bracket book, and then in double quotes, I parameterize it with self.title. So I have the string.format with self.title, and that will return the current book. Now I'll close book.py and have a look at book schema. So book schema complements book. So book schema is a Marshmallow entity, and book is a SQL Alchemy entity, and they work together. So we combine them to set the parameters that we validate our contents with. So from app.extensions, I import Marsh for Marshmallow. From app.model.book, I import book. From Marshmallow, I import fields and validate. And from datetime, I import datetime. So on line 6, I define a class called bookschema, which inherits from marsh.schema. Then I define the fields that I want to validate. So the title field, title equals fields.str, it's a string. It's a required entry, so required equals true. And the validate argument is equal to list of items, so it's opens and closes with a bracket, a square bracket, with validate.length, with a min equals 1 and a max equals 200. So we don't want any empty strings, but we will allow a single character up until a title of 200 characters long. And the same with author, I define it the same way. It's another fields.string, but this is not required. Suppose there's the book where the author is unknown, we'll allow it to leave it empty. So it'll be null in the database. But we still validate the string if we receive the author to be a minimum of 1 and a maximum of 200. The publication year is a fields.int where we validate equal to the validate.range from -1000 to datetime.now.year. So we don't want a publication date in the future, and we don't want it to go back too far. Suppose there's a very old stone or metal inscription or an old papyrus that it dates back to the BC years. We want to be able to put a negative number and go back to a reasonably far date just in case. So in this case, it'll be -1000. And then another part of the Marshmallow schema is the meta class. So class meta has a model equal to book. So we want to map all of the fields from our book defined as a SQL Alchemy model to our model in our book schema. But we only want to validate the title, author, and publication year. So now I'll close book schema. And there's one more file to look at, in this case, initdb. So in this, we import our app. So from app.app, I import create app. So this is a function that's called to create our Flask application. From app.extensions, I import db. And from marshmallow.exceptions, I import validation error to demonstrate how this works. On line 5, I create the app. So app equals create app. I set db's app, so db.app equal to app. And now I need to implement the schemas and models to create them inside of our database. So from app.model.book, I import book. And from app.model.bookschema, I import book schema. Then I call db.dropAll on the database. So if there's any database existing, I want to drop it, and call db.createAll, which will create a new database with a new table called book. Now, it's relatively unsafe to drop your database every time. So I'm going to comment that out. So I haven't created the database yet, not on this computer. So with the db.dropAll, there is a danger of dropping some records in the database currently, and it's sort of an unsafe way of doing it. So I'm going to comment that out because I don't need it here unless I'd like to rerun it, but only in testing. So it's a very dangerous command if this were to be ever put into production. And now I'd like to insert a test record after I've created the database. So book data is equal to dict, so it's a dictionary with title equals Ulysses, author equals James Joyce, and publication year is equal to this number 1922. And now on line 20, I have a try block where I create a book equal to book, so we're creating a book model. Then we're going to do a double asterisk, so it's going to be passed as a quargs with book schema and parentheses. So we're creating a book schema object dot load book data. So the schema is going to load the book data. And if any of the title, author, and publication year don't pass the validation, it will throw a validation error. Otherwise, we'll have db.session.add, we add the book, and db.session.commit to write it to the database. And then I print double braces added.format, so it will have the representation of book added. Except, so if we catch an exception, we have except validation error as E, and we just print E to see the contents of the validation error. So now I'll switch over to my terminal window, and now I'll run Python of initdb.py. And it tells me book Ulysses added. So now if I switch over to my other terminal window where I'm connected as the Postgres user, I can type PSQL of book, and now I can do a select star from books. And that returns the book that was just added. And that concludes this demonstration of sanitizing API inputs. In this video, I'll demonstrate how to implement a GET handler for an API endpoint. So I'll start by setting the stage for the Flask RESTful application. So here on the command line in my terminal window, I'll run the tree command so we can see what files we're looking at. So when I run tree, it shows me everything under the current folder. So I'm in my project folder in Documents REST 07, where I have my Python Flask application. And now under App API v1, I have a file book.py, which creates a Flask RESTful resource that implements a GET handler. So that's the file we'll look at first. Then under app.py, where I create the Flask RESTful application, I actually point the endpoint, the actual URL path, to the get method inside of book.py. So I say the endpoint points to this file or the class that's in that file. I've covered more of the code in the video titled Sanitizing API Inputs. So in this video, I'll focus solely on the code relevant to the get handler. So the final file after book.py, app.py, and then I'll test the code using testget.py. So those three files I'll explain, and then we'll run testget.py from the command line and see what happens. So now I'll switch over to Emacs, my editor, so we can have a look at the contents of the code. Now, this is the book.py that I'm looking at inside of app API v1. On line 1, from Flask RESTful, I import resource and abort. So we use a Flask RESTful resource to implement a get method. Then from app.model.book, I import book. So this is our ORM model for book that points to our Postgres database. So it points to the books table inside of Postgres. Then from app.model.book schema, I import book schema. So this describes the schema that we use to validate, which I described in the video Sanitizing API Inputs. Then from app.model.book schema, I import book schema. So book and book schema were covered in the video titled Sanitizing API Inputs. Then on line 5, class bookView is inherited from the Flask RESTful resource. So our get handler inside of a resource is implemented by the get method. So on line 7, I have def get of self, so it's a member function, comma, ID. So on the URL in the path on the endpoint, it's expecting an ID. So we're going to get the book of the particular ID that's passed as an argument to this method. Then on line 8, book equals book.getById of ID. So this function getById is a class method inside of book that's going to query the database using the SQL Alchemy ORM with the ID and return the book of that particular ID. Then on line 9, if not book, so book is set to none if there's no entry in the database for this particular ID. And if it's not found, I call abort this Flask RESTful method with the error code 404 for not found. So this is the HTTP status code 404. And the message equals book, double open close brace, not found, dot format of the ID. So I return the book ID in saying that book ID is not found. Then on line 12, I set retval, a variable I use to hold the return result, the actual book contents, equals book schema. So I use book schema to serialize it. So the double parentheses, I create an instance of it, dot dump, and I pass book. And then finally on line 14, I return retval. Now I'll close this file and we'll get into app.py where I declare the resource, the actual endpoint. So in this file, I need to import my book view. So from app.api.v1.book, I import book view. So I have access to this resource. Then in my API on line 12, I set api.addResource of book view, and then I specify the path. So /API/v1/book/, and then inside of angle brackets, I specify what I'm expecting on the URL, in this case, the ID, but it's an int. So int : variable name, ID. So int : ID tells me the type and the variable I'm passing to my endpoints. So that's the only change in this create app that I need. So for every resource, I need to add a new endpoint. Now, this is only going to handle the GET request. So if I want to handle other HTTP methods like post, put, patch, and delete, I'll need to implement functions by those names inside of bookView. So I get to these in the videos implementing method handler. So implementing a post handler, implementing a put handler, patch, and delete. So I do those in the other videos. Now I'll close this file and we'll look in book.py. So this was covered in the video titled Sanitizing API Inputs, but I added a method to this file, a class method on line 13, where I have def getById CLS, ID. So this is going to return an instance of this book. So it's going to use the class book, which is a DB model for our SQL Alchemy, and it returns book.query.filter, where book.id is equal or equivalent to, so double equals ID dot first. So we want one, the first one it finds, and it should only find one because ID is the primary key and it's guaranteed to be unique. Now I'll close book.py. And now in the project folder, I have a file testget.py, which will test the endpoint. So to call the endpoint, I import requests. So I import requests on line 1, and then I define a function called getBook, which takes an ID. And what this function does, it prints getting book, and it displays the ID, followed by an ellipsis. Then it sets the URL to http://localhost:5000. So this is where the Flask RESTful application is running. The path, so that my endpoint /API/v1/book/, and then I put in the ID. So I have an open and close brace .format with ID. So the ID will get inserted into the URL. And then I set res, so the result equals requests.get, and I set the URL equal to this particular URL. And then I print the result, so print res. I print res.json, so this is the body of the method, which will be in JSON format. And then I print an empty line. And then on line 11, I call getBook with ID 1 and getBook with ID 2. Now in the video titled Sanitizing API Inputs, I added one book for testing, and that's book ID 1. But there is no book ID 2, so we'll see what happens when it doesn't find the book. Now I'll switch over to the terminal window, and before I actually run the server, I need to go into my Documents REST folder, and I need to enable the current environment, so env rest bin activate, and I'll go into 07, the current project folder, and I'll run Python of run.py. So this will launch the server. And now I'll open another terminal window, and I'll maximize it. I'll go into Documents REST again. I'll do a source. I'll enable the environment, the virtual environment for this project, 07, and then I'll run Python of testget.py. So this will make those two requests and output the results. So it starts with getting book 1. It has a response of 200, so a successful response. And the result is the JSON with title Ulysses, created date, so it has a date timestamp of when this entry was entered into the database, the publication year 1922, ID 1, author James Joyce. Then getting book 2, response 404, so this is not found. And it tells me in my JSON message, book 2 not found. So at this point, we've successfully implemented and called our get handler. And that concludes this demonstration of implementing a get handler. In this video, I'll demonstrate how to implement a post handler for an API endpoint. So I'm building on the video titled Implementing a Get Handler, but we're adding a handler for post in this case, so we can create a new resource, a new book in this example. So I'm in my book.py file where I have my BookView Flask RESTful resource created. And I'm going to add a few lines of code to this, including the post handler. So in the imports from Flask, I import request on line 2. Then on line 3 from marshmallow.exceptions, I import validation error, in case there's an error in the schema that we receive in the post request. So then in my class BookView on line 18, I have def post with self. So it's a member function called post, which is the post handler for a Flask RESTful resource. So when data is posted to this endpoint, it will be handled by this function. So here's our post handler. So inside of it, I have book data equals request.getJSON. So this will parse the body of the request and extract it in JSON format and save it in this book data object in Python. Then on line 21, I start a try block where I create a book. So that's equal to book, which is a book of type model from our SQL Alchemy ORM. So this is our model definition. But to create the data from the model, I want to use the schema to validate the data. So I use double asterisks, book schema with a double parentheses, so I'm creating a book schema object, dot load of the book data. So this is going to load the data, save all the variables into the schema, and transfer them to the book. Then I need to save the data into the database. For that, I call book.save. So this is a method I've added to the book model, the book ORM model. So this is a SQL Alchemy model that has this member function called save, which I will explain in a moment. Then I return book schema.dump. So I create another book schema and I dump the book. So this will dump the variables of the book in JSON format, 201. So 201 is the status code for a successful HTTP response for a created response. So this says the resource was created. And then I have my except block, which is a validation error. So if the schema fails to parse the variables out of our request, and the variables don't meet the definition in the schema, so if they're outside of the range or they don't meet the parameters that are necessary, there'll be a validation error thrown. So I have accept validation error as E on line 27, and then I just call abort with the status code 400 for bad request and E for the error. So the error will get returned to the client with the status code and error code of 400. Now, suppose this fails, I return an empty response with the status code of 500 for internal server error. And I really have this in here for completeness sake to make sure we have a return at the end of our handler. So I'll close our handler and I'll go into the app.py file where we define our endpoints. Now in the video titled Implementing a Get Handler, we had a handler with an ID at the end of the URL. So on line 12, I add the resource book view with the API v1 book and the int ID handler. Now, when we do a post request, we're not passing an ID to the request because we don't know what the book ID is. The ID is assigned by the database, by Postgres, as a sequential number. So this ID is incremented for each book, and we only get the ID after the book is added. So we need to allow the post to an endpoint without an ID. So I have /API/v1/book without a trailing slash. And I do the same thing for API/v1/book with a trailing slash. So it could be called both ways. Now I'll close app.py and we'll go into book.py. Now this is the model. So I described this model in the video titled Sanitizing API Inputs. But for this video, I'm adding the save method on line 18 where I have def save of self. So it's a member function of book of this model, and it does a db.session.add of self. So it's adding itself to the database, but it's doing it through a session, so we need to commit the session. So db.session.commit, which commits the insert transaction and saves this entity. Now, if the entity already exists and we call save, it does an update. And then we return self at the end. So now I'll close book.py, and we have one more file to look in before we run the code. And this is testpost.py. So on this one, I import requests so we can make a request. So this will allow us to call the URL to add a book using a post request. So on line 3, I define def post book. It takes a book parameter, which will be a Python dictionary, and it prints posting book, and it puts the data of the book, so .format of book. And then the URL is http:// of localhost :5000/API/v1/book, like we defined in app.py. And then we have res equals requests.post, and then we set the URL parameter to URL, and JSON equals book, the dictionary. Then when it returns, I print the result res, which will show us the status code, and I print res.json to show the contents of the response. And then I print an empty line. So then on line 11, outside of the function, I create book data equals the dictionary of title equals Pride and Prejudice, author equals Jane Austen, and publication year is equal to 1813. And then I call postbook of the book data. So now I can switch over to the terminal window and run Python of run.py. So this will launch the server, and I'll tab over to another terminal window, open in the same directory, and if I look, I have the testpost.py, and I'll run using Python of testpost.py. And I get a response of 201, and it says the created date, the current date and time, the ID, 2, publication year, the author, and the title, all what I passed to the function. And if I switch over to a third terminal window I have open inside of the book database using Postgres, I'll do a select star from books. And that shows I have book ID 2 with Pride and Prejudice inserted and saved into the database. And that concludes this demonstration of implementing a post handler. In this video, I'll demonstrate how to implement a put handler for an API endpoint. So the put handler replaces an existing resource if it exists, and if it doesn't exist, then it behaves identically to the post handler. And in this example, if the resource doesn't exist, it just calls the post method. So I'm in my Flask RESTful resource called bookview in this book.py file, which defines the handlers for the endpoints. So I've implemented a few already, the get and post handler, as described in the videos titled Implementing a Get Handler and Implementing a Post Handler. So I'm building on from there to implement a put handler. So if I scroll down in the body of this class, there's a function defined on line 32, def put of self with ID equals none. So the ID parameter is optional. If it's there, it will replace the resource with the particular ID. If the ID is not specified at all, either in the URL or in the body, it passes the function off to the post handler and tries to add the resource if the data is valid. So inside the method, I get the book data from the request.getJSON. Then I check if the ID is not none. So if the ID parameter is not none, I set the book variable equal to book.getById of the ID. Otherwise, so elif book data ID, so the ID in the request JSON, if that is not none, then I set the ID equal to the book data ID, so the ID that's passed in the body of the message. And then I set book equal to book.getById of ID. Otherwise, there's no ID passed. I try to do a self.post, so I treat it as a post message and return whatever post would handle in this case. So it could still fail, but it will add it if it doesn't exist. So at this point on line 43, if not book, so if the book variable wasn't set, so if I couldn't get it from the database, then the book wasn't found, and I abort with a 404, saying that the book with the particular ID was not found. Then on line 46, I do a try block, so if there's a validation error on the data, I will abort again with a 400 message in this case. So on line 52, I have the accept of validation error as E, and I abort with 400, a bad request, with the E, the error result. So inside the try block on line 47, I do book.update. So I've added this update method to the book model, and I pass bookschema.load of book data. So it's going to take the data, the fields that are passed by the book schema, and update the ones in the book that are there currently. And then it will save the results. And then it returns the bookschema.dump of book with the response code 200, the successful or OK HTTP status code. And then if all of that fails, I return an internal server error from the method with an empty body. So the open and close brace and empty body, comma 500, the internal server error. So now I'll close this file, and then we'll go into the book.py with the book model. So this is the SQL Alchemy model that maps our book object to the database. So in this method, it's the same as I've done in previous videos, such as the implementing a post handler, but I've added a method called update. So that's on line 23 in the body of our class book, where I have def update of self and data. So data is the dictionary, the actual schema dictionary that's passed in, and I loop over the keys and values in this dictionary. So on line 24, I have 4 key, comma value in data.items, and then I call set attr, so set attribute of self with key and value. So the attributes will be the actual fields, the ID, author, title, publication year, and created date, if they exist, in this object. And then I call self.save, which will call the save method. Now the db.session.add method doesn't just add, it will actually overwrite an existing entry, an existing database entry. So it's it's add or update, and then it returns self. So now I'll close this file and go into our test put file. So this is almost identical to the implementing a post handler, but I've replaced the word post with put in this. So we're putting a book instead of posting a book. And I'm posting it to book ID 2, so on the second endpoint for the Pride and Prejudice book. And on line 11, I've set the book data to be identical to what it was in the other video. So what I'm going to do is make a small change and see if that change is made. So instead of saying Pride and Prejudice, I'm going to replace it and call this book Prejudice and Pride. So now I'll go to the terminal window. I'll run Python of run.py to launch our server, and I'll open another terminal window where I'll run Python of test put.py. And here it tells me I'm putting the book with Prejudice and Pride, author Jane Austen, publication year, and it gives me a response code of 200 with the ID 2. So I've changed the title to transpose the words Prejudice and Pride. Now if I go to the database, so I have another terminal window that's connected to the database, and if I do a select star from books, it shows in the database that the words have been transposed and the book is Prejudice and Pride. Now in the next video implementing a patch handler, I'll demonstrate how to switch that back and change it just by partially updating the title. And that concludes this demonstration of implementing a put handler. In this video, I'll demonstrate how to implement a patch handler for an API endpoint. Since I've already implemented my other endpoint handlers for our RESTful API, I can leverage what we have already, up until the video titled Implementing a Put Handler. The difference between put and patch is that the put handler expects the entire resource to be provided for updating, and if it doesn't exist, it creates it. With patch, the handler can partially update a resource, so a single field if that's all that's passed to the method. But if it's passed all of the fields belonging to a resource, it can behave exactly as a put, which in turn can still behave like a post if the resource does not exist and all of the data has been submitted to the endpoint. So we can use what we have already and make the necessary adjustments to accommodate the patch request. So I'm in my Flask RESTful resource book view where my endpoints are defined. So the methods get, post, and put respond to those particular methods. So those are the handlers that we have already. Now down on line 57, I define a patch method with a single line. So I def patch, so it's defined exactly as a put with self and ID, where ID is an optional parameter that can either come on the URL or it can be posted in the body of the message. So this returns self.put with ID equals ID and partial equals true. So the put handler method has an additional argument called partial to handle a partial request. So this is a change from the previous video implementing a put handler. So I'll go up to the definition of put, where I've changed the definition of the put method. So it has self with ID equals none, and then the additional parameter partial equals false. So it will default to false to not allow a partial request unless it's coming from the patch handler. In that case, partial is set to true. Then on line 47, where I use bookschema.load to load the book data that's posted to the request, I add the additional argument that's part of the Marshmallow library with the partial equals partial. So this will use the partial variable, which is set to false if it's a put method, and set to true if it's a patch method. So it can handle both cases. So now I'll close this file, and we'll go into our test patch.py file. So this will test a patch request. So this test code for test patch is very similar to the other implementing handler videos that I've created. So it imports requests, then it defines a function called patch book, which takes a book as an argument, and it tells me I'm patching the book, so it prints patching book of the book data. And the URL is the localhost :5000 at api/v1/book. So it doesn't supply the ID on the URL, but it will be in the body of the message in our request JSON. So on line 6, I have res equals requests.patch of URL equals URL and JSON equals book. I print the result, print the res, and print res.json, the body of the response. And then on line 11, outside of the method, I set book data equals to the dictionary of ID equal to, and title is equal to Pride and Prejudice. And then I call patch book with the book data on line 14. Now, in the video implementing a put handler, I changed the title of the book from Pride and Prejudice to Prejudice and Pride. So I want to change that back, but I only need to change the title field. I don't need to change anything else. So I'm going to use a patch method, what I've just described in the test function, to make this change. So if I go to another terminal window, I'll launch the application, my RESTful application, so Python of run.py. And then in my third terminal window, I'll run Python of test patch.py. And this tells me I'm patching the book with ID 2 with the title Pride and Prejudice. The response code is 200, so it's an okay response, a successful response. And if we look at the response text, the JSON text, the title is now Pride and Prejudice. Now if I go back to my database and I'll rerun select star from books, it will no longer be Prejudice and Pride, it will be fixed to be Pride and Prejudice. And that concludes this demonstration of implementing a patch handler. In this video, I'll demonstrate how to implement a delete handler for an API endpoint. So this is the final video where I finish implementing handlers for this Flask RESTful resource. So this has been built up from the REST handlers for the get, post, put, and patch methods for RESTful APIs. In this video, I implement the final one, the delete handler. Then I demonstrate the testing of these endpoints using PyTest in the video titled Testing a RESTful Service. So here I have my book.py file open with my book view resource defined, and I have the get, post, put, patch, and finally the delete handler, which I'll explain now. So on line 60, I have def delete with self and ID. So this method requires an ID to be passed on the URL so that it knows what book ID it's deleting from the database. So on line 61, I get the book, so book equals book.getById with ID as its argument. Now, if the book is not found, we'll abort and return a 404 to say that the resource wasn't found. So I have if not book, abort 404 with message book with the substitution of not found, where I use .format, the Python 3 formatting of the ID. So we create the string to be the message returned. Otherwise, I call book.delete on line 65, and then we'll add a return. So here, if it's successful, we can type in return. We can leave it empty, so an empty body, but we should use a code like 404 to say it's successful, but there's no content in the body of the message. Because we don't need to return anything back when an item is deleted, we just need to say it's successful. And now I'll close this and have a look at the delete method, which we apply to the model for our SQL Alchemy model. So this is in our ORM model. I'm going to scroll down to line 30, where I've added the delete method. So I define a delete method, def delete of self, so it's a member function of this book. And I just call db.session.delete of self, and then I return the result of commit, and I can choose to use that result or ignore it. So I return db.session.commit, so we can get some message back from the delete if we choose to look at it. Now I'll close book. And now I've created this file test delete with the delete book method that uses the requests library to make the requests and test out that the delete actually works. So I import requests and I define a function called delete book that takes an ID, the book to delete. I print a message saying deleting book, and I use .format to transplant the ID into the string that's being printed. And then on line 5, I have URL equals http:// of localhost 5000, so where the server is running, our REST server, /API/v1/book/, and then I substitute the ID in. And then I call the requests.delete on line 6, so I have res, the result or response, equals requests.delete with URL set to the URL variable I just defined. And then I print the result, which should give us the status code of 204 if it's successful, or 404 if the resource has already been deleted or it can't be found. and then I print a blank line. So now I'll switch over to my terminal window. I'll run Python of run.py to launch the server, and then another terminal window to run Python of test_delete.py to see if we can delete number 2. And it returns a response code, an HTTP status code of 204 to say it's been successfully deleted. Now I have another terminal window that's connected to the database, our Postgres database, where I'll do a select star from books, and there's no longer an ID of 2, so it's been deleted. Now if I go back to my command line where I've run the test and run it again, in this case it returns a 404 to say that it's not found because the book had already been deleted. And that concludes this demonstration of implementing a delete handler in a RESTful service. In this video, I'll demonstrate how to validate a RESTful entity using PyTest to call its methods. Now I'm using the Book API RESTful service created through the series of videos in this course, which was completed in the video titled Implementing a Delete Handler. So that finished off the REST methods. Now using PyTest in the way I'll describe here in this video is the first step to test-driven development, or TDD, of RESTful services. This won't be a full coverage test, but it will demonstrate the essentials to get you started. With PyTest, when you run it, it will look for directories, files, and functions with the prefix test. So that's why everything has this test underscore as its prefix. Now I'll walk you through the code in this file testbook.py, and we'll run it to check our tests after I describe the code. So at the beginning of this, I import requests. So this is an important library we use to call API endpoints. Then I set the URL to our RESTful service, which is the string http://localhost:5000/API/v1/book with the trailing slash. Then our first function is to test our get method. So it's called test_get, and it sets the test URL equal to the URL where I append the ID 1 at the end. So 1 will be the ID of the book that it will look for in our database. So then I set the result equals requests.get with the URL set to the equal to this test URL. And then when we receive the response, we want to assert that the res.statuscode is equal to 200. So we're using the double equal sign because we're comparing the status code, the HTTP status code, with 200, which is a successful request. Then we check the content equal to res.json, and then we assert that the content ID is not none, so we should receive the ID in the body of the message as JSON, and we assert that the content title is equal to Ulysses, because that's the first one that was entered in the database with ID 1. Then we move on to test post on line 14, and then I set book data equal to the dictionary, so dict of title equals Pride and Prejudice, author equals Jane Austen, and publication year is equal to 1813. So it's going to post this, which will add it to our database, our Postgres database. Then I check the result. So res equals requests.post. So the requests library has a function for each RESTful method. So we did get, now we're doing post, and there will be put, patch, and delete that we'll get to in a moment. Then we set the URL equal to the URL, and JSON equals the book data. So we submit it as JSON. Then the content, the result, is equal to res.json. Then we check the status code. So when we add a new entity, the result is a 201, which means created. So we assert that the res.statuscode is equal to 201. We assert the content ID is not none, and we return the content ID, because I'm going to use this return ID later on when we test our delete. Then on line 27, I do a test put. So I set the book data equal to the dictionary with the title set to Pride and, author, Austen, Jane, publication year is 1813. So I've made up this dictionary entry with the valid fields, but I set the test URL equal to URL plus 99999. And now this is not a valid ID. So we should get an error code come back. So I set res equal to requests.put. So I carry out the request with the URL equal to the test URL and JSON equals the book data. And then I assert that res.statuscode is equal to 404, which means not found. So it should return a not found because this ID cannot be found in our database. So the response will be unsuccessful, but the test will be successful because that's what we're expecting. Then I do a test patch on line 36, def test patch. I set the book data equal to the dictionary, so dict of ID equals 1. So we're going to modify the first ID in the database. In this case, the first book is Ulysses by James Joyce, and I'm going to change the publication year in this entry equal to 1920. So this is not a full request, it's only a partial request, which is why we're doing a patch. And then on line 40, I set res equal to requests.patch with URL equal to URL and JSON equals book data. And then I need to assert the res.status code is equal to 200. And finally, I test the delete. And what I do here is on line 45, I set the ID equal to the result of test post. So we're going to post the book, get its ID, then set the test URL equal to the URL with the ID appended onto the end of it, and then call our delete. So on line 47, I have res equals requests.delete with URL equal to test URL. And then I assert that the res.status code is equal to 204, which means successful, but the body of the message will have no content. So the delete doesn't return any useful information back. It just says if it's been successful, which will be a 204, or there'll be some other error code, such as a 400 series error if it can't find it, like a 404, or a 500 if there's an internal server error. But we're expecting a 204 for this one. So now I'll go to the command line. Now in one terminal window, I already have the server running. And then in another terminal window, I'm going to run PyTest. I'll go into the root folder. So I'm in Documents Rest 12 in the current folder. If I do an ls, you'll see that there's a tests folder. So now if I run PyTest, it will look in the tests folder and find our test file. And in this case, it has 5 pass in 0.15 seconds. So it's carried out all of the tests and they've all passed, all 5 of them. And if I look in my server console, I'll see that there's a get, post, put, patch, a final post where we used it to create an entry to get the ID and then delete it. My final terminal window, I'm connected to my book database in Postgres, and I can do a select star from books. And there's Ulysses by James Joyce, and the publication year was changed to 1920, and the other entry was Pride and Prejudice by Jane Austen. And that concludes this demonstration of testing a RESTful service. In this exercise, you'll build an application server using Python and Flask, create a Flask RESTful resource, and inside that resource, implement the get, post, put, patch, and delete handlers for your entity. Then test each endpoint using PyTest. Now you can pause the video and perform the exercise, and when you've completed it, come back to the video to see what I did. So in my exercise directory in Documents Rest 13, I'll type the tree command so I can see all the files in my Flask application. So I've used Python and Flask to create this app. I have the Flask RESTful resource under app API v1 memo.py, where I implement all of the handlers required by the exercise. I point the endpoints using app.py. I have a model directory with the model called memo, so it's to store a note at a particular timestamp, and its schema. Then in the tests folder, I implement the PyTest tests to test the endpoints in testmemo.py. So now I'll run the code, so I'll run python of run.py. Now before I describe the Python code, we'll have a look in the database to see what's there already. So I'm connected to Postgres in this memo database, and I've created a table called memos. And right now it has an ID, a note with hello world, and a created date. So it has a timestamp when the note was created. So now I'll switch over to Emacs and describe the code for this exercise. So I'm in my memo.py where I've declared my Flask RESTful resource called MemoView. So inside my MemoView class, I define the endpoints for get, post, put, patch, and delete. So starting on line 10, I have my get handler. So I define get, def get of self, so it's a member function that accepts an ID. So it's going to retrieve the memo by its ID. So I set memo equal to memo.getById. So this calls the memo inside of my ORM, and it gets it by the ID from the database. If not memo, if it doesn't exist, I abort with a 404, which is for the resource not found, and I send a message saying memo of the ID is not found. Otherwise, I return memo schema.dump of memo, so I serialize it and return the result to the client. On line 17, I define the post handler, so I set memo data equal to request.json. So the data gets posted, I read it as JSON, and then I try, so I have a try block in case we fail to validate the memo. So on line 21, I have memo equals memo, so I'm using the ORM, and then I use a double asterisk so we can pass the schema to the memo using memo schema, so I create an instance .load of the memo data. And then I save it using the ORM. So memo.save will save it into the database, and then we return memo schema with a dump of memo, so we serialize it for the client in JSON format, 201, the HTTP status code for created. And then we have the end of the try block with the accept validation error as E, and I abort with a 400, assuming a bad request, and I return the error. Otherwise, I return an empty response with a 500, an internal server error because it wasn't handled. The put method will replace an existing resource, but if the resource does not exist, it will add it. And it also has a partial parameter, so we can combine put and patch into the same function. So if I scroll down to line 56, you'll see that I define patch with self and ID, so it's an optional ID for patch, and it just returns self.put of ID equals ID and partial equals true, because patch can partially update a resource, and put will replace a resource. So I combine them into the same function, so I just call self.put with the ID and partial is true. So by default, when put is called, on line 31, partial will be set to false. And in this case, I read the data, so memo data equals request.getJSON. I read what's put to the server, and then if ID is not none, I set memo equal to memo.getById. If the put request doesn't contain the ID on the URL, it may contain it in the body of the message, so I check for it. Elif memo data ID is not none. I set the ID equal to the memo data ID, and then I call memo equals memo.getById of the current ID. Otherwise, I return self.post, where I assume that it's a post request because it doesn't supply the ID of an existing message. And then if not memo, if the memo can't be read, I abort with a 404 with message memo not found. And then I have a try block where I call memo.update with the memo schema where I load the memo data and partial equals partial. So the validation of the schema will be partial for a patch request and full for a put request. And then I call memo.save and I return memo schema.dump of the memo, so we serialize it to JSON, 200 for a successful HTTP status code. And then I do this except with our validation error to check for a validation error. And if there is a validation error, I abort with a 400, a bad request, and I return the exception. Otherwise, I return an internal server error with an empty message. So the open and close brace, 500. Now I've already explained the patch, and the final endpoint to implement for this exercise was the delete. So I def delete on line 59 with self and ID. So delete expects an ID, and then it gets the memo. So memo equals memo.getById. If the memo does not exist, so if not memo, I abort with a 404 saying the memo was not found. Otherwise, I call memo.delete and I return an empty message with a 204, which is an HTTP status code for success, but there'll be no content in the message. So all we're saying is the delete has succeeded. So I'll close this file and I'll have a look in app.py. So when I'm creating the app, I add the resource, I add the Flask RESTful resource for memo view, and I specify the endpoints. So on line 12, I have api.addResource with memo view and the other arguments for the endpoints. So /API/v1/memo/ in angle brackets int :ID. So we can have an ID on the URL. We can have API/v1/memo without a trailing slash or API/v1/memo with a trailing slash. So we can submit to memo view to the endpoints using any one of these endpoints. Now I'll close this, and the final part is to test the memo. So I have a test get, a test post, a test put, a test patch, and a test delete function that will test each one of these endpoints when I run it from the command line. So when PyTest runs, it will run each one of the functions. So now I'll switch over to a terminal window. Inside of the current directory, I'll run PyTest. And in this case, all 5 of the tests passed. And if I go into my database and write select star from memos, there'll be another memo added called hello test with ID 2, and then a patched memo that was modified the original memo of ID 1. And that concludes this exercise on how to build RESTful services and test its endpoints and methods.
In this video, I will identify the important role played by the databases in the FSD development process. A database is used by a full-stack web application backend to store important user information. The database is accessed by the backend of a full-stack web application by an API or application programming interface. CRUD, or create, read, update, and delete, are operations which an API can implement in order to interact with a database. Create deals with inserting new data into a database. Read deals with getting existing data from a database. Update has to do with modifying existing data in a database. And delete, just as it sounds, removes data from a database. Return data from a database is converted into a front-end object, which is then displayed on the front end of the web application to a user in a browser. An example of this can be a user requesting to update their account information. In this case, a GET request would be sent via the web application backend to the database, and the user's current information will be returned to the front-end browser display. Then once the user updates their information, an update request can be sent into the database to modify the existing user account information. Throughout all these steps, data integrity and security checks are added, both for data in transit and for data being added to the database in order to prevent a malicious user from gaining access to sensitive information. There are different types of databases which are used in FSD development. These include relational, NoSQL, and distributed. Relational databases store data in a structured row-column format, where the rows in the table are the table data and the columns are the table attributes. Popular relational database management systems include MySQL, PostgreSQL, and SQL Server. These systems use the SQL or structured query language in order to run update, delete, insert, and get commands in a database. NoSQL databases are better at storing unstructured data, and they store each data point individually with a unique key. A popular NoSQL database management system is MongoDB, which stores data in documents with a JSON-like schema. Distributed databases run across networks or in the cloud and do not store all data in one location. They improve performance and data reliability as more than one machine may be processing a transaction. Distributed database management systems can be either homogeneous, where the same database management system and operating system is used across the network, or heterogeneous, where different database management systems and operating systems are combined. A relational model is the model used for relational databases. It specifies that data is stored in columns where rows and columns are related, and that a column specifies an attribute such as a phone number, whereas the rows contain user data such as a row for every employee in the database containing the name, email address, and phone number of that employee. The relational model not only relates rows and columns to each other, but can be used to relate one table to another by using a primary key attribute for each row in a table. Insert, update, delete, and select operations are all supported by relational databases. The select operation is essentially a get operation where a query can be sent to a database to return a certain subset of data. A hierarchical database model organizes data in a tree structure. Data is stored in records, which is a group of fields with one value in each. Records are connected to other records through links. The hierarchical model uses a one-to-many architecture where each record has only one parent and data is found by moving down the record tree using pointers. The network database model is an extension of the hierarchical database model, with the difference being that many-to-many relationships are used. This allows the record to have multiple parents and sets, which are the relationships between the children and its members. Sets are implemented with a circular linked list with one node for the parent and multiple nodes for the children or members. Due to this architecture, there is more than one route to access a data record as compared to a hierarchical database model. Relational SQL databases provide ACID or atomicity, consistency, isolation, and durability compliance. ACID is important when dealing with errors or failing transactions on a database, as it ensures that data integrity is not compromised when the database recovers. Atomicity basically means that all transactions have to be atomic, or either all succeeding or all failing. So if only part of a transaction is successful, it'll automatically fail the transaction. Consistency deals with having all data adhere to a set of rules, constraints, or triggers to ensure that it is uniform across the database. Isolation ensures that all transactions are mutually inclusive and that a transaction cannot be interrupted or modified by another parallel running transaction. Durability describes that when a transaction completes successfully, that the result is stored in the database no matter what happens in the future in terms of database failures. Terms such as sharding, replication, and scalability are often used with databases. Sharding basically means taking a large and complex database and splitting it up into smaller parts which run horizontally on different servers. This helps spread the database load and is often done automatically on cloud-based databases once a certain database size or load is reached. Scalability deals with the ability for a database to increase or decrease in size to accommodate varying levels of data without the need to compromise performance. Scaling can be done vertically, where a more powerful database server is used with growing data load, or horizontally, where sharding is used to distribute a database into smaller chunks which can run on multiple database servers. Data replication is the process of storing the same data in more than one database server to improve the performance, availability, and integrity of data. Replication can either replicate a full database or only parts of a database. In this video, I'll describe best practices associated with the design of database systems in the FSD development process. In order to build a full-stack web application, which performs well under various load conditions, it's important to design the database correctly from the start. There are several database design best practices to consider during the architecture phase of developing a full-stack application. Getting input from stakeholders is critical, as it can help clarify which types of data is stored in the database, the size of data, and the search queries that the end users may run against the database. Choosing a type of database generally is a choice between a SQL database or a NoSQL database. SQL databases are better for data requiring more structure and a higher level of integrity, while NoSQL databases are better for large unstructured datasets where performance is critical. The type of data to be stored is generally found by meetings between database architects and domain or subject matter experts. Domain experts need to provide the requirements of data to be stored in the database, while the database architects translate these requirements into a database's structure. It is also of value to know how the end users will be interacting and querying the database of an application to get a better picture why certain data is being stored the way it is. Many modern companies with complex web applications use a mix of NoSQL and SQL databases working together. In order for data to be stored efficiently, it is important that it be normalized in order to eliminate redundant data and to reduce the number of attributes with multiple values being stored in the database. A logical structure for a database can be developed once all dependencies between various data points have been determined. This logical structure can then be translated to storage objects, which differ for each database management system. A database also needs to be easy to understand and modify for users in the future. In order to achieve this, database architecture should be made with consistent and logical, easy to read naming standards, as well as logically placed attributes. In order to have accurate and consistent data in a database, data integrity constraints need to be adhered to. In order to stop unwanted data from getting stored in the database, checks like not null and foreign key constraints can be used to avoid bad data from breaking the link between database tables. Documentation is crucial in database design, and everything should be documented, including database schema, triggers, and table relationships. Configuration drift is when a development environment and a production environment are out of sync. Therefore, just because something works in a development environment doesn't mean it will function when pushed into production. In order to avoid this, automatic scripts can monitor environment configurations before pushing updates, and that will ensure that configurations are kept in sync. It is also important to keep good channels of communication between developers building the web application and DBAs, or database administrators who work on the database. If a DBA makes a change without a developer knowing, it can cause issues with the web application functionality, where oftentimes a simple conversation is all that is needed to fix the problem. Data privacy has been in the news more than ever with the new General Data Protection Regulations, or GDPR, in Europe. In order for a database to keep privacy as a top requirement, things such as encrypting sensitive data, both at rest in the database and in transit, reducing the volume of sensitive data stored, and improving database administrator training can all help. By automating the code review process, database integrity, security, and regression tests can be run on a frequent basis, which is especially helpful when working in an agile environment. Manual reviews are oftentimes consuming and will increase the time and cost required to make database changes. Preparing for outages and natural disasters is another thing to consider when designing a database. Things such as replication, automatic failover clusters, and automatic data backups can ensure that a database integrity and performance is maintained with minimal downtime during a database failure scenario. Speed and performance is vital to database end users. In order to improve these, common queries should be kept track of, and index pointers or a clustered index to reorder database rows can be used to improve query performance. A database should also run on its own separate server from the web application or even in the cloud. This is done mainly to improve performance and also to prevent malicious website users from accessing the database. By having the same environment for testing and development as in production, it becomes easier for database testers to apply loads to a database, as would be seen in real life, and they could also then test how it would react to real users. This knowledge can then be used to tune the database for better performance in production by doing things such as adjusting query buffers and adding column indexes. In this video, I'll differentiate between relational and non-relational or NoSQL databases. A relational database is used to store structured data and can also be referred to as a SQL database. Examples of popular RDBMS or relational database management systems are MySQL, SQL Server, and IBM DB2. RDBMS are used with transaction-oriented applications, which basically means that operations involve inserting, deleting, and updating data in a database, and that a lot of small transactions occur by a large number of people or users using the database. Examples of this could be a bank website or a rental car booking site where many users may be logged in. As I mentioned in a previous video, RDBMS supports ACID or atomicity, consistency, isolation, and durability to guarantee database data integrity even in the face of things such as failures and natural disasters. Non-relational or NoSQL databases are used to store partially structured or unstructured data and do not contain a database schema like a relational database does. Some popular NoSQL databases include MongoDB, Cassandra, and HBase. NoSQL databases are becoming more and more popular as big data applications grow in popularity. This is because they have better performance along with the ability to store loosely structured data, which is critical in big data, IoT, and machine learning applications. A relational database often uses tables with row and column relationships to organize data. The columns are the data attributes with certain types such as integer or char and contain one type of data such as a name or phone number, and the rows are the actual data points or records. A table can contain millions or more rows depending on the number of transactions being placed on the database. Structured Query Language, or SQL, pronounced SQL, is used to run transactions and access data from relational databases. It can be used to insert, update, and delete and return information from a database. Some popular relational databases include MySQL, Oracle DB, and IBM DB2. Relational databases are not perfect for all use cases. One particular issue is that they do not scale well horizontally. Horizontal scaling basically means dividing a database into parts and running each part on a separate machine at the same time. Instead, scaling must be done vertically, meaning adding memory and CPU and storage to an existing database server. This only works to a certain point where NoSQL databases are better at scaling horizontally and can accommodate larger data sets. Since data is normalized in a relational database, join operations must be used to combine data columns from different tables. These operations are very resource intensive and affect database performance. Since relational databases have a rigid schema in place, they are not good with dealing with semi-structured or unstructured data, which does not conform to a single data model. There are 4 types of NoSQL databases. These are key-value store, document-based store, graph-based store, and column-based store. Key-value store databases use associative arrays, which are also referred to as dictionaries or hash tables, in order to map data. A unique key is used to access a dictionary which contains a unique object or record containing fields with data. An example of a key-value store NoSQL database is Redis. A graph-based NoSQL database uses a graph data structure with nodes and edges to store data. Data is stored in nodes, and relationships between data is represented by edges connecting the nodes. Neo4j is an example graph-based NoSQL database. Document-based NoSQL databases such as CouchDB expand on key-value store databases by providing APIs or a query language to facilitate the updating and querying based on the internal structure or types of data in a document. The main difference to the querying as compared to a relational database is that in a document-based NoSQL database, the data formats are not defined in document store databases. Column-based store NoSQL databases such as HBase and Cassandra use tables, rows, and columns similar to a relational database. The main difference is that the name, along with the formats of the columns, can vary from row to row in a single table. It can also be interpreted as a two-dimensional key-value store database. Just like relational databases, NoSQL databases have their issues as well. NoSQL databases don't support ACID transactions like relational databases do. This means that data integrity cannot always be guaranteed and that database nodes may be out of sync with each other. NoSQL databases also don't support data joins, and instead they have to be done manually in code with separate individual transactions, some of which may pass and some of which may fail because ACID transactions are not supported. This can cause extra workload as transactions have to be manually confirmed for their success. Since data is denormalized and there is no set schema in a NoSQL database, something simple like a product name change will require a massive update to each individual document. This would not be the case in a relational database. Since NoSQL databases don't support ACID data integrity checks, need to be done manually in code by adding extra code statements which would add extra overhead and potentially performance penalties. Due to the unstructured nature of data and the lack of a database schema, indexing in a NoSQL database is limited, meaning that frequently used queries may take longer to execute than they would in a relational database. In this video, I will recognize the advantages with relational and non-relational or NoSQL databases. Relational databases work best with structured data, where many small transactional operations may occur on the database by many users. An example of this may be a travel website where logged-in users can book vacation packages. Since relational databases support ACID or atomicity, consistency, isolation, and durability, transactions are guaranteed to maintain data integrity even with a database server failure. A data warehouse is a system which uses many different data sources to create reports which are used by businesses to analyze and report activities. Since data warehouses allow users to explore data, oftentimes using SQL queries, relational databases in the SQL language are a better choice for them. NoSQL databases are better suited to high volumes of data as the databases are more scalable, can support unstructured or partially structured data, and can scale horizontally, whereas relational databases scale vertically. NoSQL is also a good choice for full-stack web and mobile apps, as it is highly available and offers caching even when not connected to a data or Wi-Fi network. And it also has a schema-less design and the ability to scale horizontally, across cloud database nodes as an app usage grows. One of the main advantages of relational databases is strong data types and validity checks to ensure data integrity and consistency is preserved with structured data. Transactions also protect data changes and ensure that even if a server goes down, that data integrity is not compromised. A transaction cannot be partway complete. It either fully succeeds or fully fails so that there is no gray area about what happened. Database maintenance is simplified with built-in automation tools which enable database administrators to back up, fix, and test databases more easily than with NoSQL databases. Due to these benefits, relational databases are often best used with high-security enterprise-level applications such as banks, travel websites, and employee payroll portals. Other benefits of relational databases include data normalization, SQL queries, and a flexible data schema. Normalization deals with structuring data into a certain form to reduce the redundancy and improve the integrity of the data. Database integrity constraints ensure that tables and columns in tables of a database are properly organized to better structure data. SQL statements are used by relational databases to do queries and return data from the database. SQL is an easy-to-use language which is intuitive to most English speakers and can be used to quickly and efficiently form large and complex database queries. The schema of a relational database is flexible. This means that an update to a data type or an addition of a column to a table or the removal of a table altogether can be done without having an impact on the other data in the database. Furthermore, a table in a relational database can grow to an infinite size, provided that the database server can support the storage, memory, and CPU demands placed on it. A NoSQL database also has several advantages. It supports simple data structures by using key-value pairs and is used to store unstructured or partially structured data in documents without a set schema. Documents can have various formats such as JSON or XML and can be stored in a flat data hierarchy. Unstructured data is growing daily as companies collect more and more analytics, and this data can be indexed and used to make more meaningful business decisions through the use of NoSQL databases. Since NoSQL databases are very flexible, they can also easily scale horizontally by using sharding to divide the database into smaller pieces. They could scale horizontally on various types of often cheap commodity hardware or in the cloud, and they're also better at accommodating large unstructured data sets, as would be the case in big data or machine learning applications. NoSQL databases are also more flexible with the type of data structures they can store. They can store simple data structures such as integers, strings, lists, and maps, and also more complex data structures such as relationship tables and graphs. Parent-child hierarchies and indexes of varying complexities can also be managed from the document database. Since most NoSQL products are open source and can run across various types of hardware or in the cloud, costs for startup and support are kept lower than with relational databases. In this demo, I will go over how to download and install the MySQL relational database system for use in FSD development in a Windows 10 home environment. MySQL is the most popular open source relational database management system, or RDBMS, and uses SQL for accessing, managing, and adding content to a database. It is currently owned by Oracle and is part of the LAMP stack for web development, or Linux, Apache, MySQL, and PHP. Due to its popularity, MySQL is also used as a database for web applications outside the LAMP stack, such as web applications built using Node.js or Django. In order to install MySQL in the Windows 10 edition, requirements are that we need to have Microsoft Visual C++ 2015 redistributable package installed, as well as the requirement to install Visual Studio 2015 in order to access the debug binary PDB files if we want to debug MySQL installation issues. So what we're going to do is first we're just going to open up our programs and we're going to make sure that we have the Microsoft Visual C++ 2015 redistributable installed for x64. So I have that installed. If you don't have it installed, you could get it from the following link. So microsoft.com/en-ca/download/details.aspx ?ID = 48145. And here you could see Visual C++ redistributable for Visual Studio 2015. You just select the language and you download it and install it. Now I'm going to go to the MySQL installation for MySQL 8. So that's under dev.mysql.com/doc/refman/8.0/en/windows-installation.html. So under the MySQL installer method, we're going to download the MySQL installer from the link. So dev.mysql.com downloads installer. So I'm going to go click on that link. I'll just download the MSI installer here, the x86 32-bit installer. So once that's downloaded, I'm going to go to my downloads directory and I'm going to launch that installer just by double clicking that MSI file. And I'm going to select yes here, and then it's going to get configured. And I'm going to select yes to that as well. And once that's configured, I'm just going to select the setup type as developer default. I'm going to click next. So here basically we get the requirements. So we have a requirement for the Python connector. We don't really need that right now because we're not going to be using Python with MySQL. And we have the MySQL for Visual Studio. So that's Visual Studio versions 2012, 2013, 2015, or 2017. So that's once again for the PDB debug files. So you could see that the status is manual. So that basically means that you have to install these manually and then do a check. And once it passes, we're going to get that the status passed. This first one, MySQL for Excel 1.3.8, that's an automatic install, so you don't have to manually install it. So I'm just going to skip over these two, the MySQL for Visual Studio and the Python connector, because we won't be using them for our demos. And I'm just going to click next, and then I'm going to click yes, because it says one or more product requirements have not been satisfied. I'll click yes to acknowledge that. And then I could see all the things that are going to install, and I'm simply going to click execute, and that's going to download and install all my files. And when that's done, we're going to go set up the MySQL installation. You could see here that we've installed everything. So we're going to click on the next button, and now we have to configure the MySQL installer. So we're going to click the next button to start the configuration. We're just going to set the standalone MySQL server, so the classic option as a standalone database server, and click next. The config type will be development computer. We're going to select all the default settings, and the pipe name, memory name, everything will be MySQL. All the ports will be at the default. We'll click next. We're going to select use strong password encryption for authentication. Click next. We're going to set a password. So I'm just going to set a very basic root password. And I'm going to add a user. So I'm going to call my user Boris. Host all hosts, role dbadmin, and the password will also be root and root. It's not a very strong password, but for the sake of this demo, we'll keep that and we'll click next. Then we're going to select start the MySQL server at system startup. We'll see the Windows service name, and then we're going to run Windows service as standard system account. Click next, and then we'll click execute to run the configuration steps. Once that's done, we'll be able to continue the configuration and check that the service is running. So the configuration steps have completed. We'll click finish. Then we're going to configure the router and the sample example. So click next. For the router, we're just going to keep all the defaults and click finish. And then for the sample examples, we're just going to set the root password, click check, make sure it succeeded, and next. And then we're just going to execute once again. And once that's done, we should be good to start up the server. So we'll click finish. Next, and we're going to select Start MySQL Workbench after setup. So that's going to be our graphic display for MySQL Server, and the shell will be the shell display. We'll click Finish. We could see the shell come up, and we're going to see the workbench come up, and we could click on a connection. We could enter our password as root, click OK, and we could connect to our database. And we could also go under our services, and we could see that if we scroll down to MySQL, we should see, if we refresh our services, we should see that MySQL 80 is running now. And basically, MySQL Server is now installed in a local Windows 10 Home Edition environment. In this demo, I will configure the MySQL relational database system for use in FSD development with a Node.js and Express.js project. So the first thing we're going to do, we're going to, here in our Windows 10 Home Edition environment, we're going to click on the Start menu, and we're going to scroll down and we're going to find MySQL, and we're going to click on it, and we're going to open up the MySQL 8.0 command line client. Once that's open, we'll enter the password as root, and then what we're going to do is we could open up our cheat sheet here, and we're going to set the MySQL native password for the root users from the MySQL command line. So this changed in MySQL 8.0, but we could get it back to the old way by running the alter user root at localhost identified with MySQL_native_password by root. So that's going to allow us to use our root password when connecting to the database from our Node.js and Express.js project. Once that query runs, then we're going to be creating a new database and switching to use it. So we're going to create a database called test, and then we're going to use test. So that's basically going to tell us to switch to that database. So let's run that command. Test, and then use space test, and we see database changed. Once that's done, we're completely done with our setup for the MySQL database. So let's go inside our Windows command prompt inside our database_node_express directory, and we're just going to run npm install to install all the dependencies for our Node.js and Express.js project. Once that's done, we'll open up the Atom code editor, and we're going to go to our database_node_express project, and inside there we're going to open up the main server.js file. So in here it's going to be all the code for connecting to the database as well as running the Express and Node.js app. So we're going to be requiring Express on line 1. We're also going to be requiring body parser on line 4, which is going to be used to parse the request bodies. And on line 5, we're going to be requiring the MySQL 2 module, which is going to be used to connect to the MySQL database. We're also going to define the Express app on line 3, and we're going to define the port on line 2. We're going to set the settings for body parser between lines 7 and 9. And between line 12 and 17, we'll be connecting or creating connection parameters for the MySQL database. So we're going to be connecting to the localhost host. The user will be root, the password will be root on line 15, and the database on line 16 will be test, which we just created in the MySQL command prompt. Between line 20 and lines 38, we'll actually be creating the connection to the test database. So what we're going to be doing is we're going to be running the connection.connect command. And then if that fails, we're going to return an error on line 23. Otherwise, we're going to log connected to database on line 25. And then once it's connected, we're going to create a table with a SQL query between lines 26 and 30. And it's going to be called people. So it's going to have a primary key, which is going to auto increment by itself, and a name varchar as well as a city varchar. So a very simple table. Once that's done, we're actually going to run the command. So on line 33, we're going to run connection.query create people. We're going to pass that SQL statement in, and we're going to have a function and return an error on line 35 if the table is not created successfully. So once that's all up and running, we're going to define 2 routes. So the first route is going to be /, and that's just going to display a form here between lines 43 and 52. And this form is going to take a city in or a name in on line 47 and a city on line 49. And once it's submitted, it's going to post to the /entry route on localhost 3000. We're going to define the entry route here between lines 56 and 72, and that's simply going to have an insert SQL statement on line 59. It's going to insert into people, so it's going to, by name and city, 2 values. So we're going to put question marks to hold a place for the values, and then we're going to define the values arrays, so request.body.name and request.body.city. So the 2 values that were set in the form here on line 61. And then on line 63, we're actually going to create a query, execute the insert statement to our database. So we're going to pass the SQL statement in, the values, and return an error on line 65 if there was an error. Otherwise, on line 68, we're going to log the ID of the inserted row. And finally, on line 71, we're going to end the connection. And between lines 74 and 76, we're just going to listen to port 3000 on localhost for our Express application. So let's go back to the command prompt. Once that's all done, we could run node server.js to start the application. We could see listening on HTTP localhost 3000 and connected to test database. So let's open up a web browser, go to localhost 3000, and we're just going to enter a name. So we're going to call it test, and a city, we could call it test city. And we're going to click submit. And once that's done, we could now go back to our commands. So we could run 2 commands basically to make sure it's working. We could run show tables. So if we open up our MySQL command line and we run show tables, we could see we have a people table created. in the test database, and we could also run select star from people. So let's do that. Select star from people. And this is going to display our contents of our table. So we could see we have one ID, we have test for the name, and the city is test city. So we could see that actually by executing that insert statement from the form from our browser, we were able to update the people database, or we were able to update the people table within the test database. And it's just a very simple example of how we could do that from an Express.js and Node.js web application. In this demo, I will install and configure the PostgreSQL relational database system for use in FSD development. PostgreSQL is a free and open source relational database management system, or RDBMS. Its design highlights technical standards compliance and extensibility, and is available for Linux, Windows, and Mac OS. PostgreSQL offers more scalability and more customization options compared to MySQL. So the first step to install it is to go to the enterprisedb.com/downloads/postgres-postgresql-downloads. Since I'm in a Windows 10 x86-64 environment, I'm going to go to PostgreSQL version 12.0 under Windows x86-64 and click download. That's going to download the exe installer file, which is about 186 megabytes in size. Once that's downloaded, I'll go to my downloads directory, and I'm going to double click the exe installer file. I'll click yes to allow it to install, and that's going to trigger the PostgreSQL installer. So once the installer starts up, it says welcome to the PostgreSQL wizard. I'll click next. I need to specify the installation directory, so C program files PostgreSQL 12, that's the default directory. I'll select that one and click next. Then it asks me what components I want to install, so definitely want to install the PostgreSQL server. pgadmin 4, it's a graphical interface for managing and working with PostgreSQL database and servers, so I'll take that. Stack Builder is used to download and install additional tools, drivers, and applications, so I'll install that, and the command line tools, so I could use the command line to manage PostgreSQL. So I'll install all of those, click next. The directory for data will be C program files /PostgreSQL /12 /data, so just the default. I'll select that and click next. So now I need to provide a password for the database superuser called Postgres. So I'm going to give the password as root and then retype root. It's not very secure, but just for the sake of this demo, and click next. I'll select the default port 5432 that the server should listen to, the default locale, and then I get all the installation settings that will be installed. I'll click next, and the installation will begin. And then once that's done, it says setup is now ready to begin installing PostgreSQL on your computer. So I have to click next one more time, and here goes the installation. So it says that my install completed. It gives me the option to launch Stack Builder at exit. That allows me to download and install additional tools, drivers, and applications. So I'll select that and click finish. Stack Builder will pop up. I want to select the version of PostgreSQL, so PostgreSQL 12 x64. Click next. That's going to download the application list. I could see I have various categories. So for example, if I go to the web development tab, I have this PM HTTPD version 2.4.39-2. So that just says under here is the description. PM-HTTP is a pre-configured Apache web server compiled for use with PostgreSQL packaged by EnterpriseDB. So I can install that or anything else under these tabs. I'm just going to instead click cancel and just go with the default configuration and click yes to close the Stack Builder wizard. Then I'll click on my start menu. I'll scroll down. I'll find PostgreSQL, make sure it's installed, PostgreSQL 12.0. And I'll launch pgadmin 4. Now pgadmin is the web-based management tool for PostgreSQL. That's going to start up, and I could use the username and password that was created for me to log in. So I'm just going to enter the password root, which I created, and click OK. That's going to log me in. And once I'm logged in here, I could simply go to PostgreSQL 12. I could see I'm logged in. I could go to schemas, public tables, and in here, for example, I could right-click, click Create Table. and that's going to allow me to create a table. So I'll call the table people. The owner will be Postgres, schema will be public. I could create columns, so I'll click the plus sign to create a column. I'll call this first column ID, data type. I could scroll down and pick the various data types. So I'm going to scroll down and pick integer, and I'll set it as the primary key. Then I'll create one more column, call it name. I will set that as a char. It's not null, I'll say yes, and primary key no, and one more, for example, address. One more column, address, and that's also going to be a char, not null, yes, and I'll click save to create the table. Then I could right click my people table, and I could click on scripts, insert script, and that's actually going to generate a script with SQL that I could actually add the ID, so insert into public.people on line 1, and then ID name address line 2, and the values will be 1. I'll just say the name as Boris, and the address will be test. And I could click on the lightning bolt to execute the query. It returns successfully. I could then right click on table. I could click view, edit data, all rows, and I could see my people table, and I could see I have one row. Since I only have char length 1, I only have the first letter, so B and T, and the integer ID for the row 1. So you could see how I could connect to my Postgres SQL database, go to my public schema, just create it by default, create a table, add rows, view rows, and that's all done through the pgadmin web-based dashboard. It's a very nice and easy tool to manage PostgreSQL. I could also do it through the command prompt as well. So if I go back to my start menu, so I could just scroll down to PostgreSQL 12.0 and go to SQL Shell, and I'll just click enter for all the defaults. So database Postgres, port 5432, username Postgres, and password I'll enter as root. And here I am in my Postgres shell, and I could execute SQL statements from here as well. So that's how you could configure PostgreSQL in a Windows environment for FSD development. In this demo, I'll go over how to install and configure the MongoDB NoSQL database system for use in FSD development. MongoDB is a NoSQL database storage solution which stores data in documents with a JSON-like schema. It is popular with many modern big data web applications due to its speed and ability to store unstructured or partially structured data. Mongo Community Edition is free and can be installed on Windows, Linux, and Mac OS. I will be going over how to install MongoDB in a Windows 10 Home Edition environment. So the first step is to open up our browser and to go to docs.mongodb.com/manual/installation. We're going to be installing the Community Edition. So we're going to scroll down to MongoDB Community Edition Installation Tutorials. And under Windows, we're going to click the link Install MongoDB Community Edition on Windows. Once that loads up, we're going to scroll down and take a look at the prerequisites. So we could see that we need Windows 8 or 2012 R2 and later. So we have Windows 10, so that's going to work. And we also need to provide the Universal C Runtime Support update to make sure that's installed on Windows. So we could actually open up that update and take a look at it here. So it says here the Windows 10 Universal CRT is a Windows operating system component that enables CRT functionality in the Windows operating system. This update allows Windows desktop applications that depend on the Windows 10 Universal CRT release to run on earlier Windows operating systems. So we could see here that the update applies to the following operating systems: Windows Server 2012 R2 8.1, Windows RT 8.1, and so on, Windows 7, and Windows Vista. Since Windows 10 isn't on here, we don't have to worry about installing that update. It will already be installed with the Windows 10 Home Edition environment. So if we scroll down to install MongoDB Community Edition, we could see the first step is to download the MongoDB Community Edition MSI installer from the MongoDB Download Center. So I'll click that link to go to the MongoDB Download Center. And here we have to select our version 4.2.0. I'll pick for the current release. I'll pick my Windows x64 operating system here. And the package will be MSI. And I'll click download. Now this is about 250 megabytes for the download. I've already downloaded the MSI file, so I'll cancel the download and I'll open it up in my downloads directory. We see we have our MongoDB-Win32-x86_64 MSI file. I'll double click it, and that's going to run the MongoDB installation wizard. I'll click next here, accept the terms, click next. I'll select the complete installation, which is the default, and I'm going to install MongoDB as a service. So that means that it's going to be automatically started by Windows when it launches, and we're going to run the service as a network service user. So that's the default. The service name will be MongoDB, and the data directory will be program files MongoDB server 4.2 data. The log directory will be program files MongoDB server 4.2 log. I'll just accept these defaults, click next, and then it's going to give us the option to install MongoDB Compass. So that's basically the official graphic user interface for MongoDB. So we could do our CRUD operations in the graphic user interface and manage with MongoDB. I'm going to install that. It installs by default by checking the box install MongoDB Compass. Click next, and then click install, and that's going to trigger our installation. I'm going to say yes to this question here, and once that's done, once it's installed, we'll be able to see MongoDB running. So we could see here we get the prompt completed the MongoDB 4.2.0 setup wizard. I'm going to click finish to close it. We could also see that the MongoDB Compass GUI tool loaded up. So we could either connect to our MongoDB database through this GUI tool or through the command prompt. So I'm just going to minimize the GUI tool. And I'm also going to open up my services. And we could see here under services that we have the MongoDB server, and it's automatically started up on Windows Startup. So our MongoDB server is running. So what we could do now is we could go under our MongoDB directory. So program files, we'll see under the C directory in program files, we have a MongoDB directory, and we'll go to the server directory 4.2 bin, and we're going to double click the mongo.exe, which is going to open up the command prompt, and we could issue commands to the running instance of MongoDB. So the first command I'm going to do is I'm going to insert a single document from the MongoDB shell into a collection called stock. The document's going to contain an item bread, a quantity of 100, and the tags will be bakery. Dimensions will be height 15, width 37, and the unit of measure will be centimeters. So I'm just going to copy this command in, and I'm going to paste this command into our shell. Once that's done, I'm going to display all the inserted documents in the stock collection. So I'm going to run db.stock.find, and then I'm going to do open bracket, close bracket, and put that in braces. And just going to run that. So that should return our bread item along with the auto-generated ID by MongoDB. And then I could also run the db.stock.delete many command, which is just going to delete all the documents from the stock collection. So if I copy that in, I'll paste that inside my window, and then I could do another find command, db.stock.find, and I could see I have no more documents inside my stock collection. So that's how we could install MongoDB Community Edition in a Windows 10 Home Edition environment. In this demo, I will go over how to install and configure the SQL Server Relational Database System for use in FSD development. Microsoft SQL Server's Relational Database Management System, or RDBMS, which is owned by Microsoft. It comes in paid and free versions and works with software applications to store and retrieve data on either the same computer or across a network. In this video, I will go over how to install Microsoft SQL Server Developer Edition in the Windows 10 Home Edition environment. So let's get started. The first thing is to open up our browser and go to sqlservertutorial.net/install-sql-server. So here there's an installation guide for installing SQL Server 2017 Developer Edition. So I'm going to click the link first, download SQL Server, and open that in a new tab. That's going to take us to the Microsoft download site. I'm going to scroll down and I'm going to go to download a free specialized edition. Under developer, it says SQL Server 2017 Developer is a full-featured free edition licensed for use as a development and test database. So that works for us. So let's click download now. That's going to go ahead and save it. Then if I go to my downloads directory, I could go ahead and open up that file that I downloaded, click yes, and that's going to run the installer. So I want to select custom for the custom download option. So once I do that, I have to select a directory where the download's going to be stored. So I'm going to store it in my C drive SQL Server 2017 media. And you could see it's 1.5 gigs in size. I'm going to click install, and that's just going to download SQL Server. Now I've already downloaded it, so it's going to launch immediately. Otherwise, you might have to wait a few minutes because it is quite a big download. So once it downloads, it automatically launches the SQL Server Installation Center wizard. So I want to click on the Installation tab on the left and click on New SQL Server Standalone Installation or Add Features to an Existing Installation. So once that happens, we're going to get another window open up. And so here for the edition, we're going to specify a free edition as developers, so no need to enter a product key. Click Next. The license terms will accept. Click Next. That's going to check the rules. Once it does that, we're going to be able to see all the rules there. We're just going to click Next through that. So for the feature selection, for now, we're just going to install the database engine services, and it's going to be installed in the root directory C program files Microsoft SQL Server. And click Next. And we have other options to install other things, but for now, we're just installing the basics. So the default instance MS SQL Server, we're just going to leave all of that and click Next. And we're going to go to the server configuration after that. So it's just loading up. And here for the server configuration, we're going to leave all the defaults and click Next. For the database engine configuration, we're going to select the authentication mode as mixed mode. We're going to enter a password as root and confirm the password as root. We could add a more secure password, but just for the sake of this demo, we'll use root. And we're going to click Add Current User. So that's going to add my Boris-laptop user for an admin account with the password root. Click Next. And that's just going to give me a summary of all the things that I selected. And I'll finally click Install, and that is going to install SQL Server 2017 Developer Edition on my computer. So we could see here it says your SQL Server 27 installation completed successfully with product updates. So I get the details, install successful. I could close this window. Then I could go under my Start menu. I could scroll down, go to Microsoft and SQL Server 2017, and I could open up the SQL Server 2017 Configuration Manager, click Yes, and I could see that SQL Server is now running. What I'm going to do now is I'm going to open up the browser, and I'm going to download SSMS, so that stands for SQL Server Management Studio, and it's required as a graphical user interface management solution for SQL Server installation. So I'm going to click on the link here on the page docs.microsoft.com under download-SQL-Server-Management-Studio. I'm going to click on this link, Download SQL Server Management Studio 18.3.1. So that's 500 megabytes. I've already downloaded it, so I'm going to cancel the download. Go to my downloads directory. I'm going to click on the ssms-setup-enu.exe file to run that installer for SSMS. I'm going to click Yes, and that's going to go ahead and install it in the directory. So C program files x86 Microsoft SQL Server Management Studio 18 is the default. I'll click Install. And once that launches, it'll run the installation, and then we could launch it and connect to our SQL Server instance. So we could see that we have Microsoft SQL Server Management Studio setup completed. It says all specified components have been installed successfully. I'll click Close. Now to open it up, I'll click on my Start menu, scroll down, and I'll go to Microsoft SQL Server Tools 18. And then I could open up Microsoft SQL Server Management Studio 18. So I already have that open. So I'm going to go take a look at it. So you could see the Microsoft SQL Server Management Studios there. I'm going to click on File, Connect Object Explorer. The database engine, the server name will be Boris-laptop. I could either use the SQL Server authentication or the Windows authentication, which is going to use my default Windows password. So I'm just going to leave that. The username will just be Boris-laptop/Boris, and I'll click Connect. We could see that we're now connected to our SQL Server instance running on Boris-laptop. For example, we could click on Databases, System Databases, Master, Tables, System Tables, and we could click on this MS Replication Options table. And for example, we could click on select top 1000 rows or something, and we could take a look at the results. So that's how we could view the SQL tables, execute inserts, deletes, and so on from the graphical user interface in the Microsoft SQL Server Management Studio. So that's it for installing Microsoft SQL Server in the Windows 10 Home Edition environment. In this video, I'll describe the components required in both the test environment and a live environment for FSD development. There are various environments used for FSD development. These include staging, development, testing, and production. A development environment is where developers spend the majority of their time writing the code for a full-stack application. The test environment is where the testing teams primarily work in running manual and automated unit and regression tests in order to ensure that the application works as expected and that new updates do not break the application. A production environment is the live environment that the actual users interact with the application once it is deployed on a web server. A staging environment is very similar to a production environment and is used to test code and updates to ensure that they will work in the production environment. A common setup for full-stack developers is to work on their machine in a local development environment, which is synced to the staging environment. Once they complete a feature, they run manual and automated tests locally to verify the code works as expected. After the testing is complete, they use a version control tool such as Git to push and merge updates into a staging environment, where further tests are done before the update is released on the actual web server production environment to be used by end users. A testing environment is used by the testing team to do automated and manual tests to ensure that an application is behaving as expected. There are often various testing environments such as QA and staging intended for different purposes. User interface tests can often be done through virtualized hardware in their own environment, while performance tests often use actual physical hardware in a separate environment. Having testing environments which are highly automated and running in parallel through DevOps principles is crucial in adhering to the agile methodologies of rapid development in small stages. The last stage of the testing cycle usually ends in a pre-production or staging environment where a stable release is run in an environment almost identical to the one used in production, and key stakeholders may do acceptance testing to ensure that everything works as planned before being released into production. As I mentioned in previous slides, a staging environment should be almost identical to the production environment and can be used for key stakeholder or user acceptance testing. And it also serves as the last step before deploying an app into production. In this environment, the release already passed initial testing and is considered stable and is now undergoing integration testing under real-world conditions. An example of this may be for an iOS mobile application, which needs to support various versions of the iOS operating system and needs to be tested against each one of them. Once all the tests in the staging environment pass, the last step is to merge any changes into the production environment, which runs on a live production server. A code inspection should be carried out before merging into production to ensure that no incomplete features or unnecessary logging statements are left in the code. Once all the changes are merged into a production branch, a manual or automated deployment can occur, and applications will then be running and visible to real users. Oftentimes, when an update is released into production, a restart of the server needs to occur for the update to take effect. More complex applications may use hot swapping, where an update is deployed without restarting the server, and some services may temporarily shut down or be switched over to another server by a load balancer. Sometimes an update may only be deployed to a subset of the application's users at first, and this is done to ensure that no issues occur, and then a full rollout to all users follows in a few days afterwards. In this video, I'll identify the requirements of the FSD test environment and specific challenges. A test environment for full-stack applications is where the quality assurance or QA team runs test cases to ensure that an application is working as intended. The test environment includes either physical or virtualized server hardware, which runs an operating system and additional software required to run the full-stack application and test cases. The server has both private and public networking set up with access to the internet and a local LAN. Aside from the test server, there's also the need to have the application which the test will be running on, and realistic test data that simulates real-world test use cases and server loads. Setting up a testing environment is a collaboration between several experts from developers to database administrators or DBAs and quality assurance specialists. The test environment needs to be able to run the full stack application and also execute any automated or manual test cases planned by the QA team. Having effective test data is crucial to ensuring that a full stack application will behave as expected in production. One approach is to use no data or default data values to set a benchmark and ensure that the proper error messages are raised. Testing illegal input is also another thing which should be done. For example, if a field requires a string and a number is entered instead of the string, there should be an error message presented to the user and the transaction should not be completed. Boundary case testing deals with testing data at the upper and lower edges of acceptable data and beyond. For example, if the acceptable input for a field requires numbers from 1 to 10, a number of 10 should work, but a number of zeros should produce an error message. Testing with production data, if available, is a great way to ensure that the application runs as expected. In order to do this, however, it's important that sensitive user information is masked or removed to avoid privacy and data security issues. Performance tests ensure that an application performs as expected under load conditions. For database performance tests, large amounts of test data need to be put into the database with many parallel transactions to ensure that the database does not reach a bottleneck at higher loads. Extending on the previous slide, testing should be done with both valid and invalid data, as well as large data sets which are primarily used for performance and stress tests to test the load. If production data is available, it should be copied into the testing environment as it produces the most realistic data for testing, but once again, we should watch out for the sensitive data when copying the data over. If this is not an option, default values should be used with an input from key stakeholders on how the users will interact with the application when it does go into production. Invalid data can range from boundary case data to data which breaches security permissions, and data which is mangled or the wrong type of data for the field in question. In all cases, the transaction should fail, and the appropriate error message should be displayed to the user. There should also be a log message to tell developers, QA staff, and database administrators where and when the error occurred. Setting up a test environment for a FSD application is not always straightforward. If a test environment is not in the same location as the testing team, hardware and software needs to be configured either remotely or through a support team, which may take longer, especially if there's a time zone gap between the testing team and where the test server is located. If the test environment is used by more than one testing team, there may be a lack of resources to support all the teams at the same time. Another issue with multiple teams is that there may be interference between applications being tested, such as two applications trying to use the same port at the same time, and that can mangle the test case output and make the application crash. Sometimes in order to set up a test environment for automated or integrated testing, there are complex hardware and software configurations which need to mesh together and can take a long time to set up properly. Some tests need to run in multiple steps where the output of one step is an input of another step. Getting the testing environment to run these test cases in a serial fashion with the expected results may take some massaging of the test environment setup. There are best practices that, if followed, can help set up a test environment properly. The first and main step is to understand the testing requirements and ensure that all team members do as well. This generally starts by meetings held between software architects, managers, and key customer stakeholders. These requirements are then translated to developers and testers to ensure that everyone is kept in the loop. The network should be set up properly, and the test server should have access to the internet as well as a private LAN connection before tests are executed. The proper hardware to meet application requirements and resource usage limits should be installed on the server and configured along with the correct licensed versions of software packages, libraries, and browsers to ensure that the test won't encounter any issues when launched. This test environment should be scheduled to be available for certain teams at certain times of the day if it is used by more than one team. Maintenance and software upgrades should be done during the off hours to maximize test environment usage by the testing team. Automation tools that launch the application as well as run automated test cases such as cron and Jenkins should be installed, configured, and updated to their latest versions before application testing can begin. In this video, I'll identify the requirements of the FSD production environment and specific challenges. A production environment for a full-stack application is where a live application resides and runs and is being used by real end users. There are several challenges when dealing with databases in a production environment. In order to deploy a database in a FSD production environment, it should first be tested with a large dataset of real-world or realistic simulated data containing both valid and invalid inputs to ensure that it behaves as expected and that it meets load and performance demands. Databases are often deployed late in a production FSD environment, especially if they're being deployed and configured manually. This is why a database should be deployed in an automated fashion if possible by using scripts and pre-written configuration files stored in version control. Deployment automation tools can also be used to ensure a repeatable deployment model is used. These methods not only speed up the deployment of a database, but also ensure that it is deployed in a consistent fashion with the proper configuration every time. Legacy data often needs to be formatted and imported into a newly running database. This can pose a challenge as the data may take a long time to get into the proper format for the new database schema. When upgrading a database, it is best to use handmade scripts or synchronization tools to update the database schema and values. It is crucial to have the ability to preserve database integrity and to have the option to roll back to a previous version of the database if needed. Database servers running in a staged environment would be updated with the new changes first, and then there would be a script which synchronizes these updates into the production environment and the production database once testing is complete. A new database can either be deployed or an existing database can be upgraded. I will start by going over the deployment process. A database can either be deployed manually through a tool such as the SQL Server Management Studio or SSMS for short, or automatically through either a single script or multiple scripts, or by copying an existing database from either the staging or development environments to the production environment. Single script configurations are easy in that there is only one file, and it's easier to keep track of it in version control and apply it to the database during creation. Downsides are that all configurations would be identical, when in fact there may be different requirements for configurations in various environments such as production, staging, and development. Multiple script configurations offer more customization options. However, they have an issue in that it is often complicated to figure out the order to run the scripts, as one script would only set up one database. Scripts in a multi-script deployment are generally run either using batch jobs or through a configuration management tool which sequences the scripts. Copying databases between environments is not frequently used for a number of reasons, and one of the main ones is that the security of sensitive user information could be used in less secure environments such as development or staging. If a database is already running within a production environment and needs to be updated, it should not be removed and recreated from scratch, but instead the original database must be updated with new constraints. The database upgrade process needs to be a process which can be repeated and which is consistent, so it is best done through either synchronization tools or migration scripts if the database update is more complex or custom. The synchronization tools compare schemas between databases in production and staging as well as development to find the differences between them. T-SQL scripts are then applied to synchronize the databases. The second method is that developers can actually create their own update scripts, which are given to the database administrators or DBAs to run. This method offers more customization, but has the downside that it is not very repeatable or well documented. Previous database schemas and code versions should always be tracked in version control if a database rollback is necessary. Testing a database often comes with its fair share of challenges, one of which is too large of a testing scope. This often occurs if testers don't have a good grip on database requirements and end up spending lots of time testing unimportant objects contained in the database. If testers only test a development environment database, there is a strong possibility that it won't contain real-world data and that the database will only contain the bare minimum data to run the application. Due to these issues, it is critical for testers to also test the staging and production databases with larger real user datasets. If a database schema changes without a tester being made aware, tests which previously had passed would start failing. This would require the tester to learn the new schema and to modify their test cases to get the test to pass again. Without a good test plan, the tester runs the risk of missing important tests or even testing the same thing twice inadvertently. This is why a well laid out test plan needs to be created before test cases are written. Finally, to run relational database tests, a tester must have a good handle on the SQL language for executing queries, and they should also know how to use database management tools such as SSMS for Microsoft SQL Server. Oftentimes, a database needs to import legacy data from an older web application or from a different application altogether. This can pose challenges, particularly if the data isn't formatted in the same way and if there are duplicate or null data values or empty rows in the legacy data. One way to solve these issues is to normalize the data by using a program such as Microsoft Excel and creating a CSV file with the legacy data, which can then either be manually or automatically massaged and normalized to be the same format as the database that it is being imported into. So in this course, we've examined relational and non-relational databases in the FSD development process, and how they are used in a test environment and a live environment. We did this by exploring the role of databases in FSD development, best practices related to design of database systems, differences between relational and non-relational databases, and the advantages associated with each, how to install and configure the MySQL, PostgreSQL, MongoDB, and SQL Server database systems, and the components and requirements of the FSD test and production environments.
In this video, we're going to discuss full stack software testing. Now, the nature of a full stack developer is to deliver and ship a complete bundled feature without having to involve other parties. So this means handling all the work for the database, the platform, and the application for the testing. A full stack developer's testing methods and requirements may vary from a dedicated test team and will need to be performed end-to-end for the application. Testing is there to ensure that the functional requirements are met by checking that the application does as it was intended. Now, building strong tests can be labor-intensive and have an upfront cost, but getting them right allows for quicker approvals and deployments. Weak testing will result in software that frequently ships with bugs, or will require an external team to validate before pushing to production. A full stack tester will find that they require both unit and end-to-end functional tests to get the most of their application. But this needs a balance, or the project will bog down in constant reruns. Now, tests should be balanced to be maintainable in the future, requiring only slight changes as the application changes. But significant workflow changes will always result in significant test rewrites as well. Now, there are many types of tests, but two major ones for full stack development are as follows. We have end-to-end test. So these are designed to simulate users' behavior when they use the application. For example, if it's a web app, then the test might use a browser engine and be written to click on buttons, enter strings into text boxes, and determine the results of an expected return. These tests can have significant returns and confidence in the product, but they are also slow to run and sensitive to changes to the UI. Unit tests are used on sections of code rather than the whole application. They utilize the exposed API to exercise the unit of code to validate its design and behavior of creating an instance of a class or calling methods. Usually the test validates that the expected outcome was provided to assign pass or fails. These work for small code changes, but do not validate that all components of the application work together. Now, there are also tests that should be performed that do not measure the functions of the application, but instead measure how the application will perform. So performance tests measure the responsiveness of the application, like how quickly the page loads. Speed tests are a measure of how quickly the application responds to requests from the users. Load tests add multiple connections to the app to see how it reacts when there are different amounts of users accessing it. And stability tests put artificial load on the application for prolonged periods to monitor performance degradation over time. Now, scalability tests are used when the application and platform are designed to scale with the load. This means either adding more resources or deploying more copies of it behind a load balancer. The output of these tests is a measure of how the app can handle the resource transitions and maintain performance figures without significant impact. Industry standard tests might be specific to a type of application or use case, following certain expectations. An example would be for software controlling sensors and the expected feedback from the sensor when external factors are applied. Security testing is a complex and important factor that often gets overlooked. There are many tools that integrate into the developer's pipeline to automate security testing, but there are still requirements for some platform-specific tests to be written and undertaken. Usability tests can be subjective and prone to user interpretation or preference. As such, testing should be done on documented standards, like the shapes and color schemes present in the application, to ensure standardization across the app, regardless of which developer builds the feature. Now, there are many benefits for a full-stack developer integrating their own testing into the workflow. The ability to find bugs early in the development cycle helps to save time, and saving time means saving money. Software that is delivered bug-free increases customer confidence and reusability. Customer incidents will be reduced, allowing for more resourcing into feature delivery instead of bug fixing. And implementing end-to-end user testing will find bugs that users would and help to mitigate them before the product is delivered. In this video, we're going to discuss end-to-end software testing. Now, software testing is a necessary function in the software development lifecycle. End-to-end software testing is running a test, automated or manual, to test the flow of the application from the start of the user experience to the end. So end-to-end testing is attempting to simulate the process flow that a real-world user would perform to validate that all components in the solution integrate efficiently and that data integrity is maintained. Now, usually the end-to-end test will be performed after any functional or system or unit tests are performed to ensure that the new changes integrate with existing components. So these kind of tests also help to determine if there are dependencies in the application and to ensure that the data communicated between components is accurate. End-to-end testing is especially relevant to the full-stack developer who has worked on all layers of the application. It is good confirmation that the application is healthy through the entire stack, from the database to the user interface. And by including many of the subsystems in the application into the test, you expand the test and code coverage and can cover test cases that may not have been thought of. Testing is a costly process in both working hours and direct costs. By incorporating end-to-end testing, you can reduce the need to repeat unit and functional tests, saving both time and money. And if the development team are working in an agile development style, end-to-end testing will usually be performed after each iteration or sprint. This helps to reduce the chances of bugs making it to development or release stages, ensuring that productivity of the end user is increased and the developers can focus on new features rather than bug fixes. Now, end-to-end and system testing are very similar processes, except that end-to-end tests incorporate any interrelated components and systems as well as the core application. So end-to-end tests also validate subsystems within the application, with the emphasis being on testing the process flow of the application. With this style of tests, the back-end processes are tested as well as the user experience. Now, tests are run once, and when completed, the test suite is considered closed. There are no dependent tests. External interfaces are also tested, making the test scenarios complex and variable, so ideally end-to-end tests should be performed manually. System testing only validates the single application based on the requirements and does not extend to connected components. Its emphasis is on verifying the functionality of the core application. During testing, only the functional and non-functional areas are tested, leaving out external components. Now, generally, system testing is performed after any integration tests are complete. System testing can be both manual and automated, where end-to-end testing is usually only manual. With any form of testing, there should be metrics assigned to track the team's error rate, as well as to track the testing processes to help understand bottlenecks and identify efficiencies. So, the test case preparation status can be displayed in a graph to show the progress of the planned test. A status report should be generated daily to show the defects, any relevant details, and metrics like the percentage of open and closed bugs. The weekly test processes should be charted to show the execution times and results like pass, fail, not executed, and invalid. Metrics can be gathered around the test environment availability to identify and reduce bottlenecks in the team's performance. There are many test tools on the market, but not all of them can provide end-to-end testing. Most tools are specialized for specific tasks, like UI testing on web pages or code searching. So some examples that can provide end-to-end testing are things like Testcraft, which is a codeless rebuild of Selenium that does not require test scenarios to be coded, instead allowing the testers to build them with a graphical user interface. Ranorex Studio can be used to test desktop, web, and mobile apps. Test inputs are CSV or Excel files, meaning codeless test cases as well. And Catalan Studio can be integrated with an automated pipeline and works with web, mobile, and desktop apps. It is built on Selenium and Appium and integrates well with continuous integration, continuous deployment work methodology. In this video, we're going to discuss full stack UX testing. Now, the user experience is important to the continued use of the software as the functionality is. Graphical glitches, screen flows, self-explanatory icons and their placement, and messages can all have an effect on how the user feels about the application. Usability testing is the process of testing how easy it is to use the software and ensuring that the user gets the best experience they can from the product. So testing the user experience, or UX often, helps do things like reduce risk by providing a superior experience, leading customers to adopt the product. It can reduce costs by getting it right the first time, instead of coming back for a redesign later on in the project, and create a better product that will flow and sell well. Now, there is a checklist that development teams should follow to ensure UX testing is successful. First off, assign a single observer to a single tester. If one observer is split between multiple testers, crucial problems may be missed. Users should be from a selection of experts and non-experts to ensure the app is accessible to all users. Testing is always time-consuming and can put on constraints for a project release, so testers should focus on critical and frequently used functions to get the most out of their time. Performing usability testing on competitors' products can give your team directions on what to improve or set a baseline to aim for when developing their own product. If the product is a web app, then the end user's bandwidth should be considered. If the users are rural or in a location with poor bandwidth, then a traffic shaper could be employed to emulate the available bandwidth. User experience testing should be started during the design and development phases. Testing after release could result in expensive redevelopment time. Usability testing comes with many advantages to the project team. Usability issues are uncovered before the product is released to production, and user satisfaction is improved, leading to lower redevelopment issues and higher adoption rates. The overall system will be more effective and more efficient, and UX testing helps to gather true feedback from the target audience rather than opinions with no facts. So testing the user's experience will always be a manual process, but the workflows and concepts will be the same regardless of the application. So let's go through some examples of UX testing methods. So first we have time-based user tasks. Test the workflow within the app to measure user success and total time taken to complete a task. The objective is to look for where efficiencies can be found. And we have user observation is when a user records themselves completing a task. The recordings can be reviewed to evaluate large and small user pain points. Automated visitor screen recording is when the website tracks users' movements to uncover flaws, reveal click behavior, and give insight into the user's behavior. And user surveys can be used to capture suggestions and rank features based on scoring, showing where pain points exist and give the team feedback on the positive points of the app. Some other testing methods a team could consider are things like trust, which trust tests take a few seconds and are used to measure confidence that the user would actually use the site or application based on initial response. Comparison or preference tests are when two or more comparative apps are presented to the user, and then their preferences are gathered and used statistically to evaluate a hypothesis. Blur tests are obscured images to evaluate what calls the user's attention on the page. And impression tests use keyword summaries and initial commentary to evaluate a user's response to their first impressions of an application. So employing these tests into your software development lifecycle early on can help a team to improve their product, increasing user adoption, and reduce future changes. In this video, we're going to discuss software testing strategies. A full stack software testing strategy uses tests at all levels to ensure that every part of the system works correctly and together. A strategy provides targets and outline rules and guidelines towards achieving the end goal. Some components of a testing strategy should include things like setting aside time for fixing bugs. So gathering test results is pointless if changes are not made to match the needs of the users. Testers and developers should be encouraged to collaborate to fix bugs, instead of testers just providing a report into a black hole that goes nowhere. Testing can be manual or automated, but manual testing should be exploratory, allowing testers the freedom to move around the app without it being scripted. And bug reports need to be clear and precise. Generating templates and ensuring that the language used is the same across all testers can speed up writing test results and developers interpreting the requested changes. And code changes should be tested frequently. Waiting too long can result in large backlogs and bottlenecks that delay releases. So there are various types of strategy that could be leveraged in software testing. So a standards or process complement strategy will work to ensure the application functions within guidelines set by an external industry standards agency like the FDA or healthcare regulatory bodies. A reactive strategy works on bugs that are found in a system that has already gone live. And a regression-averse strategies attempt to reduce regression risk and often employ automation to run unit tests against all code changes. Consultative strategies used input from stakeholders to determine the scope of the test. An analytical strategy defines the test conditions based on a set of requirements, like rendering a page within a certain time or generating a type of output. A model-based strategy works to an expected situation. These models are developed to emulate a scenario, like automatic scaling of an application or load or performance testing. Methodical testing follows a set of test conditions to form a checklist of pass or fail results. So there are factors to be considered when selecting a software testing strategy. So regression-averse strategies work best for systems that are in production and have few changes or is slowly evolving. A reactive strategy works to find as many defects as possible to generate a backlog for the developers in an agile development shop. A standards complement strategy works for when the testers are not experts in the software purpose, like healthcare, or when there are time constraints. So the requirements-based analytical strategy works only when there are clear, well-defined requirements, documents produced for the testers to follow. A model-based strategy is used when a legacy system is being replaced with something more modern. And methodical strategies are employed for heavily regulated systems like financial systems. In this video, we're going to discuss full-stack development automated testing. So application testing is a complex process that involves ensuring all components of an application functions as expected while recording any issues encountered and logging a bug fix with the development team. Now, not all testing needs to be undertaken by a person though, opening the door for automation to be introduced into the pipeline to speed up the testing process and ensure certain tests are repeatable and robust is the normal. Automated testing should be written using a framework and libraries that are suitable for the requirements of the test and to match business rules. So a framework provides a standard way to create and deploy applications using a universal, reusable software environment. An inversion of control allows the program's flow to be dictated by the framework, not by the caller. Default behaviors are determined by the framework, and the framework should be extensible, allowing users to selectively override the code to create specific functions. The framework's code is in use in a non-modifiable way, meaning that while it can be extended by users, they cannot modify the core of it. When choosing a framework to author tests with, the team needs to understand the requirements of it. The framework should be chosen based on its core functions, but also on the core features it can deliver. So some desirable features would be things like the framework should be OS agnostic. So the application should be cross-platform for Windows, Linux, and Mac OS, making it portable and easily adopted by any customer. Many organizations are using cloud services, so tests should be capable of executing in the cloud and against cloud resources. Cloud readiness should be assessed when choosing a framework, and the framework must have readily available documentation, and somebody in the team should have experience and knowledge using it. Transferring knowledge to team members is critical to ensuring successful adoption. So testing frameworks need to have two critical features present. The framework needs to be easily able to troubleshoot, and teams should be able to debug issues found in existing tests as well as new ones. The library the framework uses should be shared across the organization, but not all of it may be relevant to each team, so it should be customizable and extendable. Now, there are various types of automated testing frameworks that will be used to build different types of tests. So a linear scripting framework removes the need for testers to write code. Instead, they record a series of steps, and then the test engine plays back the script as the test. Modular-based testing is similar to linear scripting framework, but instead of providing a static script for playback as testing, the test can be exported as code and edited and combined into a bigger test suite. Library architecture tests are built on modular-based tests, but instead of creating a series of test scripts, the tests are separated into functions that are stored in a library. The library then gets used to build new test cases and test suites. And data-driven testing stores the test data and the test logic separately. The test data is stored in a database and then called by the logic when the test is executed. So a keyword-driven framework is similar to a data-driven test in which the test logic and data are stored separately. However, an additional layer is added where keywords are assigned to each function of the application and stored in a table. The keywords are mapped to the objects or the UI that the test is being performed against. So the test executes and uses the keyword map to define its steps. Behavioral-driven test development automates the functional validations for non-technical and technical users to understand. Selenium is an open-source, portable framework used for authoring tests. It provides a trusted framework and library that comes with benefits like standardization around test outputs and improving maintainability, while giving the testers and developers extensibility to create their own tests. Hybrid testing frameworks are a combination of one or more of the previous framework types, giving the team much broader tool sets and capabilities. In this video, we're going to discuss full stack development testing plans. Now, a test plan is a document used by all members of the test and development team to help understand boundaries and how to implement tests. So it defines the scope of the testing, test items, responsibility of testers and developers, and the test environment to be used to execute the testing. The plan outlines the guidelines for the testing processes, like the tasks, constraints, and procedures. It also provides step-by-step details of the items to be tested. Now, there are many benefits to writing a test plan before the development effort begins. It provides a roadmap to the testing process, controlling risk and setting a clear direction for the testers and developers. It schedules testing activities, giving time and effort estimates, and team member roles and responsibilities are defined and clarified, outlining the resource requirements and can be used to build a skill matrix. Involving the team in the planning encourages communication and collaboration between the team members and with other teams. A clear test plan helps stakeholders and non-technical testers to understand the testing processes without having to be experts in the field or be involved in the work. Now, not having a test plan can have negative effects on the team and on the outcome of the software development lifecycle. The scope not being properly defined can lead to misunderstandings or lack of understanding between testers, developers, and business stakeholders. So without clear objectives, testing will be incomplete and unorganized. No defined end dates will degrade software quality. Functionality and efficiencies will not be properly tested before release, meaning more bugs in live systems and more bug fixes in the backlog. A test plan outlines the responsibilities of the teams. Without it, teams will be unsure of their roles, leaving gray areas and unfinished work. Now, there are 6 steps to writing a good test plan. So, analyze the product that we'll be testing, understanding what it is expected to do in terms of key outcomes. Develop the test strategy to define the scope of the testing. The strategy will outline testing techniques and will outline the following 4 steps. Now, objectives for the test scope and boundaries should be defined, including listing the software features to be tested and defining the testing targets. A resource plan is a summary of all types of resources required to complete the testing tasks. Scheduling resources, both human and technical, should be undertaken from the beginning. Bottlenecks caused by environments being unavailable or overlapping schedules of the testers can cause backlogs and missed deadlines. And finally, to determine the deliverables expected from the testing process and how they apply to each stage in the software development lifecycle. In this video, we're going to discuss full stack end-to-end testing. Cypress is a locally installed, browser-driven front-end testing tool. Most industry standard test tools execute outside of the browser, requiring waits and scheduling to be involved in writing the test case. So Cypress executes a browser and runs the tests internally, meaning it can execute as quickly as the website can render. Tests are written as spec.js files in your favorite editor. So in my case here, I'm using the Visual Studio Code. All right, so if I want to create a file, for example, I can come over here to my left-hand navigation and have this Cypress test project in a folder called integration. If I right-click on that, I have a context menu that flies out. And the first option in that menu is new file. So I could do that. And I could call this simply, let's call it tests.spec.js, for example. All right. And if I hit enter, it'll give me the open canvas here where I can now start typing code. Now, assertions are used to tell Cypress what the application's desired state or output should be, enabling it to be used with very complex JavaScript frameworks and UIs. So what I'm going to do here, I'm just going to pound here, insert. Actually, I'm just going to paste this instead. It'll be a little quicker. Okay, there we go. That's a little faster just by pasting it. So our demonstration here is going to test the connections for the Skillsoft website and look for keywords. So in this case, the title of the page should include the word Skillsoft. What I'm going to do now is save the file here, and I'm going to open a command prompt to actually run this here. So we're just going to go here, File, and we're going to go Save. And now I'm going to switch over to my command prompt. Okay, so now I'm in my command prompt here, and I just have my Cypress test project open. Just do a quick directory listing so you can see this. So what I'm going to do now is jump into the node modules here in the bin and execute Cypress open. Okay. Fire this up. And once Cypress is going to be open here, we can see all the existing integration tests in the folder here. This just takes a moment. There we go. Just going to bring this into full view here. So our test that we created, sitting right down here, test.spec.js, it's the very last file. If I just go ahead and click on this, it'll go ahead and run. You can see that it says Chrome is being controlled by automated test software. So at this point, as the user, I can just sit back and wait for this test to complete. So what's really going on here is this test automatically executes the browser, which in this case is Chrome, but it's configurable, by the way, to use other browsers. So the test is running, and it's going to give an output of the steps and the results. And then eventually we'll give a pass or fail response. Now, while this is running, I should mention that multiple tests can be grouped together to run sequentially, allowing for a full workload or workflow to be tested. And different viewports can be specified to ensure testing across multiple device types and screen sizes. Data can be entered into fields for validation, and AJAX or XHR requests can be handled and measured. And just finally, because this can take some time to run, I just want to point out all the commands here that you have. So docs.cypress.io/API/commands. This happened to just be looking at the then command. You can see full documentation of everything that's available for Cypress.io. In this video, we're going to discuss full stack unit testing. So JUnit is a framework for performing unit testing on applications written in Java. Unit testing is usually done by the developer before committing changes to a system and before it gets to the testing team. Units are a single entity, like a class or method, and can be tested in one of two ways. You have manual or you have automated. So unit tests written in JUnit need to have a known input, which tests a precondition, and expected output, which tests a post condition. So I have a sample up and running here. I'm just going to open up a couple files here. So we're going to start with my JUnit class. Just going to pop this open here. So for our demo, we have a simple class that has a function that adds two integers together, a plus b. And this is the unit that we'll be building a JUnit test against. So I'm going to open up another file. It's called add class test Java. I've added it here. Now, the JUnit test has the class defined, which is then used to call the add function from within the my JUnit class. And we specify the integers to be added. The result will be the sum of the two numbers added using that function. And then we can check for the result using the assert equals function by taking the value we are expecting, in this case 300, and comparing it to the result generated by the add function. So this test is ready to run, which is done through a debug action against the test class we've created. So I'm just going to right click on add class test, and we're going to run debug as, just down here on the context menu, about 3/4 of the way down. And we're going to click on JUnit test. This will start up. Okay, it's running here. Okay, so once it's done here, this ran very quickly, ran in a fraction of a second. Notice the green bar here. This means that things were successful. Okay, and I'm going to run this again now to make the test fail. So to do that, we're going to change the expected result or the post condition. So I'm just going to close this up here. And back in the add class test Java file, we're going to modify what I have here at line 13 from 300 to 400. We'll do that. Just going to hit save on that. So we know that obviously 100 plus 200 is 300. So that should be the expected result. Changing it to 400 as a known failure we can verify it by running the test again. So we're just going to do the exact same steps here. I'm going to right click on Add Class Test Java, come down to my Debug As, and JUnit Test. So we're going to run it here, and obviously this time the bar is red for failure, and there's a failure trace present in the bottom pane as well down here. So this pane is the most important one, the one on the left here. So the trace shows that the expected output was 400, but the result returned was 300. In this video, we're going to discuss full stack performance testing. Apache JMeter is an open source tool used to perform load testing and measure performance, mostly for web applications, but can be used in other scenarios as well. So it runs from an IDE where the test plans, recording, and reporting is all done, or it can be run from the CLI, which is 100% Java-based, which means that it can run from any operating system that can run Java applications. So we'll be doing a basic performance test against a website to measure its response times when under load. So when JMeter is going to be started, as I have right here, it has a blank test plan. So the first step here is to add a thread group. So the test plan that is here by default in the very top left of the screen, just underneath the ribbon, I'm going to right click on that, and the submenu here is Add, and then it has a second menu off of that that has threads. All right, so we're going to click on that. That'll pop out a third menu called Thread Group. This is the one that we're interested in. So the thread group is the beginning of any test plan, and where you set how many threads or user connections you are going to emulate. There's also a scheduler available to control the duration and delay of the test process. So we have a number of threads here. We're going to just set this to maybe, we'll set it to 100. And ramp up period, we'll set that to be 100 as well. We don't want to do too much here. And the loop count, we'll set that to 10. We don't want to create any kind of, DOS or anything like that. So the number of threads is the number of the users connecting to the target website. The loop count is how many times the test is executed. And the ramp up period is how many seconds it should take to get the maximum number of threads specified. So now we can add the elements to the test here now. So to do that, we're going to come over to the thread group that we just added. In the left-hand navigation, we're going to right-click on it. We're going to find Add here. And we're going to look for Configuration Element. It is the second one up from the bottom. So when I hover over that, because this is a website, I'm interested in HTTP request defaults. So that in the third menu here is the 2, 4, the fifth item down. All right, so I'm going to go ahead and click on that. And this brings up a new pane. So the HTTP request defaults are where you specify the target website or service, its ports, and any other parameters to send with the request. So server name or IP in my case here, I'm just going to use a sample one here. This. And I'll specify my protocol port here. All right, so it's going to be HTTP and port number. Do it against 443. There's a certificate. Okay, now you can save obviously your changes here. There's a save button here in the ribbon. You can just go ahead and click that. And you can give this a proper name. We'll just call it testing. Here, just to save that. Now that the information is all filled out here, we can go and add samplers. So to do that, I can right-click on my thread group, add, and the first option is called sampler. So samplers are basically where you specify the request to the server, like an HTTP request or an LDAP request or something along those lines. So if I want to, say, pick an HTTP request, I can just select it like this. Now, if we leave the server or IP name blank in this case, then it's going to use the default one that I specified here. All right, so the HTTP request defaults, it's like a base or a foundation. And the HTTP request sampler will revert to anything in the default configuration if not specified. This allows you to basically do specific overrides. And again, you could add as many samplers or as many requests as you like. In this video, we're going to discuss full stack database unit testing. So SQL Server unit tests are used to baseline the functionality of an application database and then to verify any changes made to the objects within the database. So tests are written in Transact SQL and should be run and verified against an independent development environment prior to using them on production databases. They can be written to verify changes to any database object and can have tests stored around the stored procedures, triggers, and functions. So this test database has been created to emulate a customer database that holds details about the customer, their orders, how many have been filled, and how many have been canceled. All right, so we're just going to be interacting basically with the sales database. So I have a sample function up here. In Visual Studio, I have this SQL Server unit test1.cs file open to design. All right, so what I'm going to do here is expand the top left drop down, which gives me all the items available. I'm going to select sales _ USP new customer test. All right, and this is going to change what I'm looking at here. So this test verifies that the customer table contains the correct amount of data. So the test conditions look for a row count condition and has a row count value of 1 set. So any number other than 1 will cause a failure in the test. All right, so let's take a look at a couple of the other ones here that I've written here. So let's go to place new order test. Okay, I'm going to have to do a little bit of scrolling for this one because it's a little bit longer. So this test has a pre-test that will execute to ensure the changes made to the database object that is being tested. So the pre-order test adds a customer into the database. This is what the executes are doing here. And if there's only one previously, there will be 0 out their year-to-date sales and order fields, basically kind of resetting them. Okay, so that's what's going on here. So what I'm going to do now is select test here. Just up here in the menu. So test. Then we'll go to run. I'm just going to run this selected test here. Okay, run test started. We can see my output window that it's running. This will just take a moment. There we go. I'm just going to pin this Test Explorer here just to the left-hand side of the screen so that we can track it a little easier. Okay, then I can just move up here just to see my results. So I can see on this USP fill order test that it was successful. But notice that the exclamation mark on the cancel order test was unsuccessful. So we have a message here saying the assert.inconclusive.failed. So this gives me some information that I can now use to go see what might be wrong with this. And this is the whole point of this test platform, of course. If I want to rerun any particular test, I could just click on it, right click, run selected tests. It would run this specific one here that I have selected. Notice how it changes to clock. It's spinning now, running. And it'll just take a moment here. And there we go. So now I have this test passed. I can track a few things here in the output window. And I also have my test conditions window here. All right, so this one here is inconclusive.condition4 and enabled is true, test is inconclusive. All right, so again, you can change these assertions, of course, to whatever makes sense for your business case here. Just going to right click one more time here on the one that gave me a warning, run selected tests. Okay, and it'll start running here now again. So again, I could run all tests at the same time. If I move up a level, for example, I can run all the selected tests, which will basically select everything. I also have the option to do that even from the Visual Studio menu here, where I could actually run all tests. So you want to kind of use this on a case-by-case basis. In this video, we're going to discuss full-stack automated API testing. So automated testing provides many benefits over manual testing processes. It ensures the tests are repeatable, providing expected results regardless of who is executing them, reduces the amount of time testing takes, and can be inserted into the CI/CD pipeline to expedite the development iteration. So unit, functional, integration, end-to-end, regression, and API tests are good candidates for automation. And there are many tools available to provide the functions to do that. So Postman, which I have open on my screen, is a utility that can be used to automate API testing and offers both a graphical user interface and a command line interface for scaling the testing. So with this open here now, I'm going to come up in the very top left and click on the little arrow beside New. And this will bring down a menu here, and I can click on Request, basically to create a new request. So I can create a new request here. I'll just call this Test. And I'm just going to scroll down and create a collection for this here. So click on Create Collection. I'll just call this Testing. That's it there. And now with my collection specified, I can now save this, and then I can start executing my request. So the drop-down get list here, it's default to the verb get, but it supports all methods, as you can see here, like post, put, delete, and head, options, link, unlink, purge. So this is a pretty extensive list. Now for this test, we're going to perform a simple get request. So I'm just going to select that. Now we'll use the JSON placeholder website, which is an open REST API for testing. Query strings can be added to the request URL as well. So I'm just going to type in a URL here, HTTPS. Okay, so JSON placeholder, right, dot type code.com/users. All right, so query parameters can be specified as well, like key value pairs. So if I click on headers here, for example, headers can be added, like if you're doing a post or a put test, which requires uploading a file where you need to specify the file type, or basically you would do all that kind of stuff here. So this get request test does not require any further configuration, so we can click send to run the request against the target URL, which I'll do now. So it says sending request, and then I get a JSON result. So the contents here in the body, I'm just going to move this up so you can see it a little better here. Let's move this down. There we go. So the contents in the body field will populate with the return from the website. So the default view is in the pretty editor here, as you can see in this little submenu, which allows you to collapse sections and highlights text to make it relevant. It can also be used as raw or visualizers so that you can create graphs or any of those type of things. I'll just click on preview here to see the full JSON. Here's the raw view and the pretty view. Again, when visualize becomes available, you'll be able to go ahead and leverage that as well. So I'm going to click on the JSON drop down here, which is just to the right of that submenu. So the return can be expected in different formats. So you can switch between viewing the results in JSON, XML, HTML, or plain text. Auto will attempt to determine the data type and display it properly. All right, so you have some options there. Going to scroll up a little bit now, just so I can click on the headers that was returned. And I'll scroll back down so we can see them all here. So these are the response headers for quick reference. So in the top right of the pane, you can see the status of the API, for example, the time taken to run the test, and the size of the file that was returned. Just going to highlight that because it's a little hard to see. So just where I have the blue highlights there right now, this is what I'm referring to. All right, so a lot of times you can use these kind of tests just to figure out how big the payload is. In this case here, it's 6.11 kilobytes. And there's 19 results in this header that I've returned. Again, ideal for testing. In this video, we're going to discuss full stack security testing. Security testing is the responsibility of all members of the organization, from the developers to the testers to the security team. Developers and functional testers may not have the deep skill set that a dedicated security professional would have, but there are tools on the market to aid them in security testing their applications as they produce functions. So the Open Web Application Security Project, also known as OWASP, is a non-profit organization founded to establish methodologies, tools, and frameworks used in secure development practices for web applications. Now, one of the tools developed by OWASP is ZAP, or Z Attack Proxy, which is used to define security vulnerabilities in web apps and offers automated tests or can be used for manual penetration testing. So I have ZAP opened here. The left-hand side of the ZAP interface shows the context and list of sites to be attacked. This is the scope of testing to be undertaken today. The right pane is where we specify the target. So an automated scan, for example, I could click on that. The screen is where you specify the URL to launch an automated attack against. You can manually type the address, or you can save it into the list of URLs for reuse later on. So I'm just going to enter a site here that is mine here, so nobody will freak out. So I have basically typed that. And now spidering, by the way, is used to map all endpoints of access into the application. All right, so this is what this Ajax spider is all about. By default, ZAP's using a traditional spider, basically. So one is synchronous versus asynchronous is the easiest way to explain that. Just going to click this down here so you can see all the different type of options here. We have Chrome and basically all the browsers here that I have installed with the head and without the head. And then we have HTML unit, JX browser, and Phantom JS as options. And just to make this a little shorter here, I'm going to send this to a specific page so that it's not so much information here. So go ahead and select that. Okay. So with everything good here, I'm now going to click the attack button, which is right here underneath the Spider Ajax. And it's going to start running a series of gets here. It's going to run me a percentage here that I can watch. Okay. It's just going to take a moment here. So what's happening here is ZAP's crawling the pages and starting with the contact page and scans each page returned. So that's what I'm getting here is a list of processed URIs filtering in the bottom pane of the application. That's what's coming underneath here. So it's looking at the whole site index once it started from the contact page. So what it'll do is it'll discover pages, parameters, and functions, providing detailed information of all requests and responses. So it knows, for example, that I have login and register URLs, and it's testing all types of query parameters and those kind of things. So you can see the URL counter continuing to rise here. In some cases, this could, if you hit it hard enough, of course, this could be considered a DOS style attack, which is why I'm doing it against a safe site here. Okay, so I've gone in and skipped ahead here. Now the attack is complete. I have the alerts pane here that's by default selected here. And it tells me that there are basically 9 types of things I'd be interested in. So in this case here, the wildcard, directive, script, source, unsafe, inline, and tells me all types of information that I can use to help elevate the security of my site. Cross-site scripting tokens, for example, the absence of it, of the suppression of it. So you can save these as report outputs as well. And I can even drill into these alerts here and get some additional information here. This is a pretty handy tool in that regard. Now, a couple of things I want to mention here. Zap can also act as a proxy between the attacker's browser and the target URL. So gathering data from both sides and using man-in-the-middle methods to manipulate and form requests and responses. So it is an extensible platform with more functions available from the marketplace and is ideal for use in automated security testing, running in a headless mode with a powerful API available for integration into the CI/CD pipelines. The only thing I will leave you with in this video is never put in a URL that is not your own or that you would be concerned about, because this can be considered an attack and certain laws will be applicable. Right? So when you're doing this, always do this against your own websites, never do it to someone else's. So in this course, we've examined FSD testing, including test plan creation and a number of different testing methods and strategies. We did this by exploring the types of tests required for FSD testing, the key components of end-to-end testing, and comparing full-stack usability testing methods, the available of software test strategies and when to use each, the framework for FSD automated testing, and how to create a FSD software testing plan. We then talked about how to perform end-to-end testing using Cypress.io and how to write and execute unit tests using JUnit. We then went on to how to create a demo test plan using Apache JMeter, how to create a unit test for a SQL Server database, how to perform automated API testing, and how to perform security vulnerability testing using OWASP Zap. In our next course, we'll move on to explore relational and non-relational databases and the role they play in both the test and live environments of FSD development.
NoSQL databases have various advantages, especially with cloud computing. Before getting into the advantages, let us quickly explore the need for NoSQL and its databases. Many organizations are adopting to NoSQL due to the complexities and limitations of relational databases, especially with unstructured data. Also, if agile methodologies is being adopted within your project, a relational database can slow you down. So what are the advantages of NoSQL databases? NoSQL databases are more scalable. Most of the SQL databases are vertically scalable, which usually is adding additional horsepower to the existing infrastructure, whereas with NoSQL, you can scale horizontally by adding additional servers. NoSQL provides superior performance with faster throughput and generated uptime. It overcomes some of the key limitations of relational databases with big data and complex database model. NoSQL can efficiently handle large volumes of data, and it has the ability to change the data type dynamically. It works well with both structured and unstructured data. NoSQL works with agile sprints, quicker iterations, and frequent code pushes more effectively. With growing architectural demands, it is easy to scale with a NoSQL database. NoSQL database supports storing data as is. This removes the need for having ETL processes, which typically extracts, transforms, and then loads the data. NoSQL databases handle partitioning of database across several servers. With growing storage needs, an inexpensive server can be added to the existing database cluster to make them work as a single data service. They provide support for a range of data structures. It can handle a variety of complex data with interrelated storage structures. With faster aggregations and query handling, analysis is passed to the database for execution next to the data. So what are the best places to use NoSQL databases? User profile management is core both to mobile and web applications. It enables online transactions, user preferences, and user authentication. With the need to support hundreds of millions of users, it is easier to scale with NoSQL database by simply adding an additional commodity server. NoSQL has the ability to extract dynamic information in real time. It increases operational efficiency, reduces costs, and increases the revenue by enabling to act immediately on the current data. With billions of smartphone users, mobile applications face scalability issues in terms of growth and volume. With a distributed database, mobile applications can start with a small deployment and expand as the need arises. For financial service organizations, fraud detection is key. It identifies the profit loss, minimizes financial exposures, and complies with regulations. When customers pay with a credit or debit card, they expect to know immediate confirmation after the transaction has been completed. NoSQL databases can reliably deliver the required performance to meet the latency requirements. Everything from smartphone to tablets, systems installed in our cars, hospitals are connected to internet. The volume and variety of mission-generated data are increasing day by day, which is semi-structured and continuous. The key to effective content is the ability to select variety of content, aggregate it, and present it to the customer at the time of interaction. NoSQL databases are perfect for storing any type of content because they are document database and do not require the data model to be defined first. There are 4 basic types of NoSQL databases. The key value store, also known as hash table, organizes data as sequence of records. They are indexed by a key or hash value that points to one or more data objects or records. Column-based store organizes data by columns rather than rows. Columns are grouped into families of related data that is accessed together. Document-based store is a subset of key-value database. The values in a document store follows a predefined hierarchy that embeds metadata about the stored contents. They are often encoded in formats such as XML, JSON, or binary formats such as Microsoft Office file or PDF. Graph database, on the other hand, is a network database that uses edges and nodes to represent and store data. Now let us review some of the key value databases. DynamoDB is a NoSQL database offered by Amazon.com as part of their web service portfolio. It is a multi-region and durable database with built-in security, backup and restore, and in-memory caching for internet applications. Google Cloud Memory Store provides a fully managed in-memory data store service built on scalable, secure, and highly available infrastructure managed by Google. Microsoft Azure Table Storage is a service that stores structured NoSQL data in the cloud. It provides a key attribute store with a schema-less design. Redis is a key value in-memory database storage that also supports disk storage for persistence. Google Cloud Data Store is a highly scalable, fully managed NoSQL database service offered by Google on the Google Cloud Platform. It is built upon Google's Bigtable and Megastore technology. REAC is a distributed NoSQL key value data store that offers high availability, fault tolerance, operational simplicity, and scalability. In addition to the open source version, it comes in a supported enterprise version and a cloud storage version. Amazon DocumentDB is a fast, scalable, and highly available document database that supports MongoDB workloads. Cosmos DB is Microsoft's globally distributed multi-model database service. It enables you to elastically and independently scale throughput and storage across a number of Azure regions worldwide. Google Cloud Firestore is a fast, NoSQL document database that simplifies storing, syncing, and querying data for your mobile and web applications. MongoDB is a free and open source document-oriented database which uses JSON-like documents with schemas. It handles database management and it operates as a distributed database cluster. Couchbase is a JSON document support database platform, and it provides full support for document flexible data model. Amazon Neptune is a fast, reliable, fully managed graph database service that makes it easy to build and run applications with highly connected datasets. Cosmos DB Gremlin API is used to store and operate with graph data on fully managed database service designed for any scale. Neo4j and Google Cloud have teamed up to deliver Neo4j for Google Cloud, which is a graph database. Neo4j is a graph database management system developed as a transactional database with native storage processing. Janus Graph is an open source distributed graph database under the Linux Foundation. Now let's explore some of the popular column-based databases. Amazon Elastic MapReduce is an AWS model for big data processing and analysis. Google Cloud Bigtable is a NoSQL database service for large analytical and operational workloads. Azure HD Insight is a full-spectrum open-source analytics service in cloud for enterprise systems. Apache HBase is an open-source non-relational distributed database modeled after Google Bigtable. It runs on top of HDFS, providing Bigtable-like capabilities for Hadoop. Google Cloud Dataproc is a fast and easy-to-use managed cloud service for running Apache Spark and Hadoop clusters. And finally, Apache Cassandra, which is designed to handle large amounts of data across many commodity servers, providing high availability with no single point. Relational Database Management System, shortly referred as RDBMS, is the basis for SQL and for all database systems like Microsoft SQL Server, Oracle, MySQL, and Microsoft Access. The data is typically stored in a table which consists of numerous columns and rows. NoSQL, on the other hand, can handle a wide variety of data models and are especially useful for working with large sets of distributed data. Now let us quickly explore the key differences between RDBMS and NoSQL database. NoSQL is very powerful for storing unstructured data, which is growing far more rapidly than structured data. Common types of unstructured data include user and session data, chat, and data from IoT devices. RDBMS handles OLTP transactions more efficiently. OLTP databases are operational databases characterized by frequent and short transactions that include updates to the data. Some of the examples include banking applications and online reservation systems. NoSQL databases are schema-free and does not require any definition for the data. RDBMS supports ACID transactions. ACID refers to atomicity, consistency, isolation, and durability. Atomicity is when any statement in a transaction fails, the entire transaction is rolled back. With consistency, no partial transactions are allowed. Isolation ensures each transaction stays independent and does not have access to others that are in intermediate state. And with durability, it ensures that once a transaction has been committed, it is preserved through backups and transaction logs. There are 4 different types of NoSQL database systems. Key value stores are the simplest form of NoSQL databases. Every item in this database is stored as an attribute name or key together with its value. Document databases pairs each key with a complex data structure known as a document. Documents can contain many different key value pairs or key arrays or even nested documents. Graph stores are used to store information about networks such as social connections. Some of the graph stores include Neo4j and HyperGraphDB. Column stores such as Cassandra and HBase are optimized for queries over large datasets. They store columns of data together instead of rows. Even though there are lots of advantages for using a NoSQL database, there are some key issues associated with them. Most of the NoSQL databases are not ACID compliant. NoSQL follows base compliance, which stands for basically available soft state eventual consistency. This means eventually data in all nodes will be synced up and display the same data. NoSQL has limited support for joins, and they are really hard in distributed database because of the overhead while looking up the keys. As NoSQL deals with lots of unstructured data, where the data is usually denormalized and it requires mass updates. NoSQL has zero built-in support for the data integrity. It has limited indexing capabilities. Indexing is a way to improve the performance of a database by minimizing the disk access when a query is being executed. A relational database is a type of database which uses predominantly structure to relate and associate other data within its system. Data in relational databases is organized into tables. RDBMS uses structured query language to query data. SQL is a programming language to communicate with data stored in RDBMS. The syntax is similar to English language, which makes it relatively easy to read, write, and interpret. Relational databases are based on relational algebra. Relational algebra is a procedural query language which takes instances of relations as input and yields instances of relations as output. It uses operators to perform queries. The data is typically stored in a table which consists of numerous columns and rows. Some of the examples are MySQL, Oracle Database, and SQL Server. Now let us explore some of the issues with relational databases. In relational databases, the data is normalized because we deal only with structured data. So in order to process the data, a lot of joins needs to happen, and that will eventually impact performance. Relational databases do not scale out horizontally, and they only support vertical scaling. So if you need additional power to your existing system, a new configuration can be added to the existing server, whereas we cannot add an additional server similar to NoSQL databases. RDBMS has no support for semi-structured data such as JSON format. So what are the reasons to use NoSQL databases? They work really well with both mobile and web applications. Especially in mobile, where you need offline support to process and store data. Also, NoSQL totally eliminates the need to make frequent requests for fetching data by caching it locally. NoSQL doesn't have any storage limit. It can handle large amounts of data without any constraints on the structure. As most of the organizations follow agile process, it's hard to keep up with relational databases when developing in a fast-paced environment. With agile sprints, quick iterations, and frequent code pushes, NoSQL is the best fit. NoSQL supports object-oriented programming. For instance, MongoDB is a simple object-oriented NoSQL database based on the document store. The data objects are stored as separate documents inside a collection. The biggest advantage of NoSQL is its ability to handle big data, which in turn drives the popularity of other NoSQL databases like CouchDB, MongoDB, Cassandra, and HBase. NoSQL database ensures that data doesn't become the bottleneck when all of your other server-side components are designed to be more efficient and seamless. With NoSQL, we can store huge amounts of data with little to no structural changes. The data can be stored in one place without defining the type of data in advance with document-based databases. NoSQL databases are designed to be scaled across multiple data centers without any cross-cutting concerns. In order to scale a NoSQL database, we can just add an additional server and make them scale horizontally. Cloud-based storage is a good cost-saving solution, although we have to spread the data across multiple servers to scale up. As NoSQL deals with both structured and unstructured data, database schema doesn't need to be developed in advance. Now that we have explored the reasons to use NoSQL databases, what are the limitations for adopting to this technology? A major issue with NoSQL databases is the lack of reporting tools for performance testing and analysis. With SQL, on the other hand, you can find a wide range of reporting tools to help you prove your application's validity. The NoSQL community lacks the maturity of the MySQL user base since it's a relatively new concept. While the community is rapidly growing, SQL database management systems is hard to compete with for its vast network of highly experienced end users. There are a lot of NoSQL databases and still no standard like the ones that exist in relational databases. This lack of standardization of NoSQL can cause a big problem during migration. NoSQL has compatibility issues with SQL instructions. New databases use their own characteristics and they are not yet 100% compatible with structured query language used in relational databases. Providing perfect data security is a challenge on any platform, but NoSQL databases are generally subject to a fairly long list of security issues. Even though most of the issues would likely be solved as the NoSQL community continues to mature, for now, security is a limiting factor for NoSQL deployments. Most NoSQL databases do not comply with ACID transactions, a technique that ensures data remains consistent across the entire database as it moves around. Instead, NoSQL relies on the principle of eventual consistency. Even though this provides some performance advantages, it poses the risk that data on one database node may go out of sync with the data on another node. MongoDB is a document database which stores data in JSON-like documents. It is much more expressive and powerful than the traditional row-column models. Now let's explore some of the key features of MongoDB. Ad hoc queries are not known while structuring the database. MongoDB provides extensive ad hoc query support as they are updated in real time, leading to an improvement in performance. One of the key features of MongoDB is that it uses BSON format. BSON, also known as binary JSON, is a binary encoded serialization of JSON-like documents. It supports data types like date and binary that aren't supported in JSON. Another advantage of using BSON format is that it enables MongoDB to internally index and map document properties. MongoDB provides extensive support for aggregation feature. MapReduce is an implementation for processing and generating big data sets. It is composed of two procedures. The map procedure performs filtering and sorting, whereas the reduce procedure performs a summary operation. MongoDB can be used as a file system with load balancing and data replication over multiple machines for storing files. This is achieved using the grid file system. MongoDB has the ability to batch process data and get a single result even after performing different operations. There are three ways to achieve aggregation, and they are the aggregation pipeline, MapReduce function, and the single-purpose aggregation methods. Grid file system is a feature of storing and retrieving files. This is very useful for the larger files as it divides the documents into chunks and stores them in separate documents. When we query the system for the files, all the chunks are assembled together to form a single file. MongoDB is a schemaless database, which makes it more flexible and popular than any of the traditional databases available in the market. The major and very common problem with growing web applications is scaling. To overcome this problem, MongoDB has come up with a concept called sharding, which is the method for distributing data across multiple machines. Each shard holds a portion of the data, and it functions as a separate database. Collection of several shards together forms a single logical database. MongoDB is a document-oriented database. In relational databases, data is stored in tables in the form of rows and columns, whereas with NoSQL, it is stored as fields. MongoDB supports fixed-size collections called cap collections, which maintains the insertion order. Once the size has been reached, it starts behaving like a circular queue. Indexes are created in databases to improve the performance of searches. In MongoDB, document can be indexed with primary and secondary index, which in turn enables the database engine to efficiently resolve queries. MongoDB provides replication by distributing data across different machines. It can have one primary node and one or more secondary nodes known as the replica set. The key feature of MongoDB is its automatic failover. When one of the set members can't reach the primary instance for more than a particular number of seconds, the replica set will automatically elect and promote a secondary instance as the new primary. This adds data redundancy and increases uptime. MongoDB is an open source database with high performance and provides high availability and scalability. It has faster query response because of indexing and replication. MongoDB Management Service, shortly referred as MMS, is a powerful web-based tool for tracking databases as well as backing up data. It also tracks hardware metrics for managing deployments. Custom Alerts helps us to discover issues before the MongoDB instance is affected. MongoDB supports multiple storage engines. Storage engines manages how data is saved in memory and on disk. It also provides pluggable storage engine API for third parties to develop storage engines. There are various factors to be considered while deploying the NoSQL application into production. First, it's very important to understand your storage needs. How much disk space do you need to maintain your data? Poor storage management may impact your business as well as your client's request. What is the growth rate of your application? How much data do you anticipate in the next 3 to 5 years? Next, it's determining how much CPU speed your application needs. CPU speed is the amount of cycles that a processor can perform per second. CPU core is actually a part of the processor. In the olden days, processors had just one core for performing one task at a time. But now there are multiple cores for performing multiple tasks in parallel. Determining this factor is very crucial for NoSQL deployments. Launching an application on any database typically requires careful planning to ensure performance, high availability, security, and disaster recovery. Some of the popular hosted solutions are on-demand pay-as-you-go model, seamless upgrades and auto-healing, fully elastic where you can scale up and down with ease, highly secure by default, and finally continuous backups with point-in-time recovery. So how do you deploy MongoDB in production? The first step is to create a MongoDB image. Then you should be able to start the MongoDB container from the image that was just created in the previous step. Once the container is up and running, we can access it the same way as accessing a remote database instance. You can use any utility to connect to this instance. Also, you can connect to the MongoDB container from other containers using the link argument. Now it's time to explore the Couchbase NoSQL deployment. You can provision the Couchbase server by creating a custom Docker image of Couchbase. We can have a series of runtime commands to support the deployment. The next step is to create a Docker file without an extension, and this file will act as a blueprint of our custom image. You can join Couchbase nodes into NoSQL cluster via the administrative dashboard. As we have already created the custom image in the previous step, we can deploy more than one container and actually create a cluster with replication. First, we need to give a name to each container and define the network that the containers operate on. We can also join the Couchbase nodes into NoSQL cluster via the command line interface or scripts. Docker containers plays a crucial role for NoSQL deployments. Docker containers can be deployed to DigitalOcean or Linode. Both of them are cloud infrastructure providers that help to deploy and scale applications for running simultaneously on multiple computers. Docker is a software platform that simplifies the process of building, running, managing, and distributing applications. It does this by virtualizing the operating system on which it is installed and running. Docker deployments allows for quick ramp-ups and system scaling based on the need. NoSQL databases are subject to a long list of security issues. So what are the key security concerns? By default, the NoSQL database is installed with no credentials. It is left to the individual developers for running it in a trusted environment, and this results in a very poor authentication management. Administrative user or authentication is not enabled by default, and it also has a very weak password storage mechanism. NoSQL doesn't have authorization flow. So if a user is created, by default, he or she will have access to the entire database. This makes the system more vulnerable to data leaks. In NoSQL, client communicates with the server via a plain text. So this allows the hackers to intercept the data and capture them. A user with access to admin database has read and write access to everything. There is zero granularity here. As we know, there is no admin password. By default, we have access to everything. NoSQL doesn't have support for external encryption tools like LDAP to improve the security of the system. NoSQL is vulnerable to SQL injection attack. It lets the hackers take control of the database to modify data expose your application, and even bringing it down. By default, the service will bind to all available interfaces. So if you're installing it in a dual-homed environment, you could essentially expose the whole database to a less trusted DMZ. DMZ is a demilitarized zone that exposes organizations' external-facing services to an untrusted network. A denial of service attack is a cyber attack which typically is accomplished by flooding the targeted machine or resource with multiple requests. This is done in an attempt to overload the system. NoSQL is highly vulnerable to this kind of an attack. Most of the popular NoSQL databases are open source, and it is highly recommended to configure stronger authentication and encryption systems to the NoSQL implementations. We shouldn't be waiting for the publisher to make changes. NoSQL data stores are basically vulnerable to the same security risk as traditional RDBMS data stores. So the usual best practices for storing sensitive data should be applied here as well. Now let us look at some of the key best practices for securing our databases. Always disable anonymous access, where anyone without a proper user privilege will not be able to access the database. Administrators have to assign appropriate roles for new users. Use sufficient input validations to control the data being fed into the system. It is always best practice to change the default port in which the application is set up to run against. Never run the server as root or admin. So this way we can contain any security attack to that particular non-admin resource rather than the entire system. Disable the default status page using the No HTTP interface option to turn off the default port. Always ensure the REST services in production environment is disabled. It prevents the users to access the database using REST APIs. Encrypt all communications using the SSL layer. Never use an unsecured connection for hosting your application. And finally, you need to encrypt every sensitive data that's being stored in NoSQL database. This can be achieved by encrypting the contents of the fields that hold secure data in the application layer. The first and foremost thing in attaining high performance is understanding and determining what your needs are. Let us go over them one by one. The first step is to determine what your data sets and your data model will be like. The data model will depend on the data sets and the typical operations your application will perform. The next step is to determine your requirements to support transactions. Do you even need transactions in your application? Choose wisely if you need replication. It closely ties with requirements for supporting data consistency. Determine your performance requirements, which is key for running any application successfully. If the project is based on an existing solution, always evaluate if it is possible to migrate existing data. Warming up indexes and data is a common technique used by SQL and NoSQL databases. For instance, MongoDB offers the touch command, which lets us specify what we want to preload, either the data or the index, or both the data and indexes. To get the best of preloading, we need to analyze our data size and how we are going to query it. The very first tests are going to be run on a freshly started database instance. So between each test, we will be restarting the database so no index gets preloaded. This is called cold database testing. Most NoSQL databases comes fully equipped when it comes to analyzing your data as well as the data size footprint. This allows us to introspect our needs and make decisions accordingly. Always check your database log. For instance, MongoDB records all queries which takes longer than 100 milliseconds. The location is usually defined in the configuration setting. Use slow queries to get intelligence about your system behavior and performance bottlenecks. Usually, there is a very high correlation between the two factors. Always analyze your database queries. If the number of examined documents exceeds the number returned, the query may not be efficient. In worst cases, the database might have to scan every single document in the collection. Create indexes when there is an absolute necessity. An index is built from one or more fields to make querying faster. Using sparse indexes can reduce the size of the indexes defined. If you use sparse documents and heavily use exist keyword in your queries, the sparse index can minimize your index size and boost the query performance as well. Sorting works effectively when an appropriate index has been defined. Without an index, the database must sort the result itself, and this can get problematic when a large set of document is being analyzed. When building an application, you can increase its efficiency by having a single persistence connection object which will be reused for all queries and updates. This will work fine if the queries are simple. If you have a complex query which takes more time to run, no one else can interact with the application at the same time. So this issue can be overcome by defining more than one database connection object where each object is treated as separate database client. A slowly executing query can hold up your web application and can eventually time out. You can specify a time limit in milliseconds for any command which is likely to take considerable amount of time. A replica set can be used as a slave for reading queries. By changing your connection string to secondary preferred, your application will try to run read queries on the slaves before doing it on the masters. Horizontal scaling is usually achieved by adding additional servers to your infrastructure to support the growing needs of your application. As a result of this scaling strategy, complexities increase within the system. This is where CAP theorem comes into play. So what is CAP theorem? The CAP theorem states that network shared data systems can only guarantee two of the three properties, which are consistency, availability, and partition tolerance. Now let's look at these properties in detail. Consistency is a guarantee that every node in a distributed cluster returns the same most recent successful write. There are various forms of consistency, but in CAP theorem, it refers to sequential consistency. Availability ensures that every non-failing node returns a response for all read and write requests. To be available, every node on the network must be able to respond in a reasonable amount of time. With partition tolerance, the system continues to function and uphold its consistency guarantees in spite of network partitions. Distributed systems guaranteeing partition tolerance can gracefully recover from partitions once it heals. The CAP theorem categorizes the systems into three further categories. CP systems are consistent and partition tolerant but never available. It refers to a category of systems where availability is sacrificed only in the case of network partition. CA systems are consistent and available systems in the absence of any network partition. Often a single node's DB server are categorized as CA systems. The available and partition tolerant systems are always available and partition tolerant, but it cannot guarantee consistency. It is impossible to have all three properties of CAP theorem in network shared data systems. In any network shared data systems, partition tolerance is a must. Network partitions and drop messages are very crucial and must be handled appropriately. If a system has been running normally without any issues, it implies that consistency and availability properties of the theorem have been satisfied. Choosing consistency means not being able to answer a client's query, as the system cannot guarantee to return the most recent write. This sacrifices availability. On the other hand, being available means being able to respond to a client's request, but the system cannot guarantee consistency. Available systems usually provides the best possible answers under any given circumstances. With available and partition tolerance category, system is always available to respond to request. Every non-failing node returns a response for all read and write requests in reasonable amounts of time. Being available means being able to respond to client's request, but the system cannot guarantee consistency. When choosing availability over consistency, the system will always process the query and try to return the most recent available version of the information. Even if it cannot guarantee, it is up to date due to network partitioning. Consistent and partition tolerance refers to a category of systems where availability is sacrificed. In this case, system is unable to respond to a client's query as it sacrifices availability. System cannot guarantee to return the most recent write when consistency is chosen over availability. Also, the system will return an error or timeout if the particular information cannot be guaranteed to be up to date due to network partitioning. Before getting into the characteristics of unstructured data, let us understand what unstructured data is and how it is different from structured data. Any information that does not have a predefined data model or organized in a predefined manner is categorized as unstructured data. One of the best examples of unstructured data is logs from IoT devices connected to the internet. Structured data, on the other hand, contains clearly defined data types with easier search capabilities. Some of the examples are profile information like names and addresses. So what are the characteristics of unstructured data? It doesn't contain predefined model as we cannot predict the schema or data type. Some of the unstructured data types are text, images, sound, and video. As it doesn't contain clearly defined data types, it is very difficult to search with unstructured data. So what is semi-structured data and where is it being used? Semi-structured data is a form of structured data that doesn't follow the formal structure associated with relational databases. It contains tags or markers to separate semantic elements, and it enforces hierarchy. XML is a semi-structured language. It is a set of document encoding rules that defines a human and machine-readable format. XML tag-driven structure makes it highly flexible and universal, and it is easy to transport on the web. JavaScript object notation, also referred as JSON, is another semi-structured data format. Its structure consists of name-value pairs and an ordered value list. Since the structure is interchangeable among multiple languages, JSON excels at transmitting data between web applications and servers. NoSQL databases differ from relational databases because they do not separate the schema from the data. This makes NoSQL a better choice to store information that does not fit easily with record and table format. It also allows for easier data exchange between databases. Some of the newer NoSQL databases like MongoDB and Couchbase incorporate semi-structured documents by storing them in JSON format. Now let's look at the various steps in which an unstructured data can be analyzed. It is very important to understand the source of data first. Usually, data is calculated from multiple sources relevant to your business. Collecting them from random sources is never a good idea because it might corrupt the actual data. Once the data has been collected, the next step is structuring your unstructured data search. This step is as important as collecting the data because if not managed properly, it can have a negative impact on your business as well as your clients. The third step is to eliminate useless data. Not every piece of information will be beneficial for your company's growth. Retaining unstructured data can take up too much of space on your business hard drives and can affect your business ability to strive. Preparing data means removing all the white spaces and formatting issues from the collected data. Always make sure you save the data, whether it is structured or unstructured. A data backup recovery system is essential and necessary, especially during the time of crisis. After eliminating useless data, stacking your data is the ideal next step. Be sure to use the latest technology to save and stack data so that it is easy for you and your peers working with the same data. Useful insights can be derived based on the relationship between the source of information and the data extracted. Your company will need to be able to explain the steps and process it took. So a record has to be kept to recognize patterns and to be consistent with the process. Once the unstructured data search has been changed into structured data, the next step is to classify and segment that data for easy use. This is the last step of indexing unstructured data. After all the raw data are structured, it's time to analyze and make decisions that are relevant and beneficial for business. In this demo, we'll install and configure Mongo database on Mac. There are two prerequisites for installing MongoDB. First, make sure you have the latest version of Xcode installed in your Mac. I have already installed version 11.2.1. The next prerequisite is having Homebrew. Homebrew is a missing package manager for Mac OS. To get Homebrew, open Google Chrome and then type in brew.sh That should take you to the Homebrew page. In the web page, there is an instruction for installing Homebrew. Copy the command under that. Open your Mac OS terminal. You can paste it here and execute. Since I've already installed Homebrew, I'm not running this command again. Now let's use Homebrew to tap MongoDB instance. In order to do that, go to your terminal and type in brew space tap space MongoDB / brew. Once the tap is complete, you can install MongoDB again using brew with the install command. So in order to do that, type in brew install MongoDB-community at 4.2. I am installing MongoDB version 4.2. Hit enter. That should begin the installation for MongoDB version 4.2. So you have successfully installed MongoDB now. There are two ways in which you can run a MongoDB. It can be as a macOS service or manually as a background process. In this instance, I'm going to run MongoDB as a macOS service. You can use the same brew to do that. Brew services, start MongoDB community. So this should start the MongoDB. There you go. We have successfully installed MongoDB and we have started it as well. To make sure that your MongoDB instance is running, you can use the grep command. So it did bring up a process saying MongoDB instance is running successfully. Now that we have successfully installed and configured MongoDB, let us quickly connect to Mongo and insert and query a document to ensure we are all set. To connect to MongoDB, once you're in the terminal, type in Mongo. Now we are successfully connected to the MongoDB shell version. To insert a document, you can simply use the insert one function. In order to do that, let's do db.inventory.insert1. I am going to insert a simple JSON document which contains ID and country. So ID is 1 and country is Canada. Close the JSON document and close the function. So now we have successfully inserted this document and it has returned an acknowledged true indicator as well as the inserted object ID. Now let's query this document. To do that, you can use the find function. So it's db.inventory.find. I'm just going to pass the ID. Now this should return us the document that I inserted in the previous step. So there you go. We have successfully installed and configured MongoDB, connected to the MongoDB shell, inserted a document, and queried the same document as well. In this demo, we'll learn how to install and configure CouchDB in macOS. The first step is downloading the installation file of Apache CouchDB. In order to do that, open a browser of your choice. I am going to open Chrome browser and go to the CouchDB homepage, which is docs.couchdb.org. In the left side menu, there will be an option called Installation. Click on Installation. And since we are going to install this setup on Mac OS, click on Installation on Mac OS on the right side. And there's an option called Installation using the Apache CouchDB native application. This should be sufficient for our demo. So click on the Download Apache CouchDB for Mac OS. And again, it'll ask which platform you're using. In our case, it's Mac OS. Clicking on the Mac OS should start the download. We have successfully downloaded the installer. Now let's begin the installation. In order to do that, go to the folder where this file got downloaded. For me, the file was downloaded in my desktop. Double-click on the archive file. It will extract the application. There you go. The next step is installing this application in Mac. Click on the Go option at the top of the screen, which is the toolbar. And then you'll see an option called Applications. Click on that. If you want to install any applications in Mac, you just need to drag the application into the Applications folder. So for CouchDB, I am just going to drag this application in here. So we have successfully installed Apache CouchDB in Mac now. So the next step is to run the actual application. To do that, double-click on the application. It will prompt you with a warning saying that this app is downloaded from internet. Are you sure you want to open it? Click on the Open button, and that should in turn open the administrative console in the browser. Before proceeding with the actual database creation, we need to make sure that all the configurations are in place. So the first configuration that we need to make sure is if the installation is successfully verified. In order to do that, in the left menu, there'll be a tick mark. Click on that. And you see an option called Verify Installation. Click on the Verify Installation button. So you've successfully verified your Couch database installation and everything is running. The next important step is defining the node configurations. Will this be set up as a single node configuration or a cluster? In order to do that, click on the Settings button in the left side of the menu, which is the second option from the top. So you have two options here. You can either configure as a cluster or you can configure this as a single node. In production, the ideal setting is supposed to be a cluster with an appropriate load balancer in place. But just for the sake of demo, I am going to configure this as a single node. So just click on Configure a single node. So you need to give brand new admin credentials here. I have not set up any administrator privileges, so whatever you're giving here would be a brand new user configuration. So I will be creating Couch user and password as demo 2019, and this is the default port that this application will run on, which is 5984. And click on Configure Node at the bottom. Now that we have configured CouchDB, the next step is to create a database and then insert and query documents. In order to create a database, click on the Create Database option on the right side of your screen. Once you click on that option, it will ask you to give a name. In this case, I'm giving demo-2019 and then click on the Create button. So your database has been successfully created. Now let's insert a document and try to query the same using the curl command. Curl is a command line tool for transferring of data as well as all sorts of URL manipulations. So in order to use curl, you need a terminal. Open the terminal. Now let's insert a document using the curl. So it starts with curl -x put. So put is one of the HTTP methods. For inserting a document, I'll be using the put method, and for getting the document, I'll be using the get method. Put HTTP, the URL in which the CouchDB is accessible, so which is localhost 5984, the database name, then the ID of the item that I'm trying to insert. For this demo, let me insert country, and then -d denotes the document. In here, I will be passing in a JSON document. So ID of this particular document is 1, and name is Canada. This should insert a document within our demo-2019 database. So there you go. We got a return of true, and the document ID got generated successfully as well. Now let's use curl to retrieve the same document that we just inserted. So for that, you need to use curl -x. The only difference would be get instead of put. Again, the same URL. So this should fetch me the document that I just inserted. So there you go. We have successfully installed and configured Couch Database, inserted a document, and fetched the same as well. So in this course, we've examined NoSQL databases in the FSD development process, including tips for their deployment, security, and performance. We did this by exploring different NoSQL databases and their advantages, cloud options for NoSQL databases, differences between relational and non-relational databases, and reasons for using each type in FSD, features of the MongoDB database system, deployment options, security issues, and performance tips associated with using NoSQL databases, how the CAP theorem and unstructured data applies to NoSQL databases, and finally, how to install and configure the MongoDB and CouchDB NoSQL database system. In our next course, we'll move on to explore the importance of SQL in FSD development, including creating and manipulating data and objects using SQL statements, and best practices for using SQL efficiently.
In this video, I'll describe the purpose of continuous integration and why it's important for FSD. Continuous integration, or CI, works with agile software development principles and promotes a development methodology where small updates of functionality are committed to a single shared code repository using version control tools such as Git, several times a day and by many team members. Each commit triggers a build which also runs automated tests to ensure that all changes integrate into the project as expected and that there are no unexpected errors. Third-party CI services such as Jenkins help to create the CI pipeline and ensure that everything is building and testing and being packaged as expected. By integrating a CI workflow, a company can quickly make changes to a project and maintain a flexible architecture in order to quickly integrate product enhancements or bug fixes. In order for a continuous integration build to pass, it must pass all automated tests run against it. Automated tests include performance tests such as load and stress tests, unit tests, UI tests, as well as integrations, systems, and acceptance tests. Tests in the CI environment need to be automated and not manually executed, as commits occur frequently and the consistency of the codebase has to be verified on a daily basis. Load and performance tests are used to measure how an FSD application's performance and speed will be affected by an increased concurrent number of users and how it will sustain that load over a period of time. Unit tests are usually written by using unit test frameworks such as Mocha.js for Node.js or JUnit for Java applications. Unit tests take care of testing the core functionalities of different components of an application. Once unit tests pass, integration tests can be run to verify that all components of an application work well with each other. Finally, systems and acceptance tests can be run to verify that an application meets business requirements before the application is released into production. Any time that a test fails, the whole build should fail and the CI service can be configured to send an error message to all team members. As I mentioned in a previous slide, continuous integration is achieved by using a third-party CI service. There are many choices for picking a CI service depending on the needs of a project. CI services can be locally hosted or hosted in the cloud. They can be open source or proprietary. They could also have various integration, security, data storage, and retention constraints, which may increase the setup and training time for a specific CI service over another. Additionally, various tools have different costs, support, reporting features, and ease of use, which are all factors that come into play when choosing the optimal CI service. Some CI services, such as Jenkins, can be set up to run on a local, on-premise, or virtualized server, while other services may run as a software as a service application hosted in a vendor's server and accessed over the internet. Open source CI tools are free to use and often have good community support. For more customized CI services, or where a high level of professional grade support is required, a proprietary solution may be a better option. Integrating a CI service will inevitably cost some time and money and will require training for team members. Questions which can be asked to help determine the best CI service to use include the number of concurrent builds planned, the number of users making regular commits, and the way that data is stored. Additionally, a CI service should have good community support and an easy-to-use user interface, along with a command line interface to facilitate the quick training of developers to use the new service. There are several steps required to successfully set up a continuous integration and continuous deployment or CD pipeline. The first step is to set up the CI and CD environment. This includes picking a version control system such as Git or SVN to store project code in a central repository, selecting a CI service such as Jenkins, and automating the build settings. After that, unit tests should be written using a unit test framework such as JUnit for Java, and the test should be set up to run automatically during the build. A branching strategy can also be implemented in order to have various streams of development. For example, there may be a branch for new feature development and another branch for bug fixes. There should be a limited amount of branches to avoid confusion, and there should also always be a master or mainline branch from which the main build occurs and which developers work from most of the time. Branches can be merged into other branches once the commit is pushed and tested and is verified to be working correctly. Continuous integration deals with the automated building, testing, packaging of code, while continuous deployment or delivery takes it a step further and actually automates the process of taking a code commit all the way to a deployed application running in a production environment. If a company uses a CI pipeline and does not use CD, they can manually copy over compiled build artifacts at the end of the CI pipeline and deploy them and test them in a production environment, as the build artifacts are production ready at the end of the CI pipeline. A CD service often integrates with a CI service and basically takes the build artifact from the end of the CI pipeline and deploys it into a production environment either automatically or through a single click, while running some additional integration and performance tests to ensure that the deployment occurred successfully. In this video, I'll describe some of the best practices for using continuous integration. When implementing a continuous integration or CI pipeline for a business, there are several best practices which can enhance the effectiveness of the process. A version control tool such as Git or Subversion should be used to store project code and configuration files in a single repository which all team members can access and contribute to. A version control tool also allows the use of branching, which essentially means that a project can have a main branch from which everyone works off of, along with multiple different development streams for things such as bug fixes and product enhancements. Virtual environments can be used to run unit, integration, and acceptance tests in parallel on one server, and they can also be set up and later taken down quickly for automated test case execution. Everything should be automated in a CI pipeline, from the build settings to the automated test cases, packaging, and release settings. An effective CI pipeline should take a code commit and use build and test scripts to automatically set up build, database configuration, environment configuration, test and packaging steps without the user having to click through any complex menus or invoke any complex commands from the command line interface. Logging should be used for all steps in the CI pipeline, from the build to the automated testing and from the packaging of the application. CI services allow the logging of every stage in the pipeline and will fail a build if a test case doesn't pass. These failures, along with their associated log messages, can then be automatically sent to all team members to get to the root of the problem as quickly as possible. Version control tools such as Git and Subversion or SVN need to be used with a software project that is to implement a CI pipeline. By using a version control tool such as Git, an application can either be run locally on a developer's machine or local server, or in a cloud environment with code commits to a centralized remote repository, causing a build and deployment to trigger. There are various tools which can be used for version control, such as open source tools like Git, or proprietary paid tools such as Perforce. The choice of which tool to use depends on the project specifications and the level of customization and support required for a project. Version control tools also allow a code repository to contain multiple branches of development. A branch is basically a separate stream of development where additional project features can be implemented, such as product enhancements or bug fixes. A project typically has one main or master branch, which most developers work off of, which the main build uses, and other branches are occasionally merged into the master branch after being tested. Version control can and should store all source code and supporting files such as build scripts, test scripts, database configuration files, third-party library files, and documentation files. Build products or artifacts should not be stored in version control, however, as they are generated every time a new build is triggered. Automated testing of FSD applications is more easily completed using virtualized test environments. The idea is that a fresh environment is created automatically and on demand through test scripts and is a clone of the production environment. There may be several test environments running in parallel on a single server, such as a unit test environment, an integration test environment, and an acceptance test environment. Once all tests are complete, a virtualized test environment can be automatically shut down using scripts. The same scripts can be reused when the next build triggers to recreate the virtual testing environment in a consistent fashion. An effective CI pipeline will use the same build and test scripts for building and testing in an automated fashion. This not only saves time from having to trigger builds and tests manually, but also maintains the consistency of the project as every build and test is run doing the same settings and parameters. As I mentioned, separate virtualized environments should be used for different levels of testing, such as a unit test environment, an integration test environment, and an acceptance testing environment. An automated rollback plan basically means that if an error occurs once the application is put into a production environment, that there is a fail-safe automated way to get the application back into a previous state in which it will work. This also allows developers to push more changes to an application with confidence, because they know that in the worst case, if something breaks, it won't cause significant application downtime. It is also a good idea to deploy an application into a test or staging environment, which is a perfect clone of the production environment, including the same operating system, database setup, and networking ports being used. By doing this, final acceptance and performance tests can be run in as real of an environment as possible before pushing the application out to real users. When implementing a CI pipeline, every member of the development team should have access to logs, which will display if any errors occurred during the build, automated testing, or release phases of an application. This can usually be done fairly easily through most CI tools by specifying email addresses of all team members. Whenever a build fails, all team members would receive an automated email containing a report with the failure message, along with any relevant log files or error messages which can be used to debug an issue. Alternatively, team members can log into a web-based dashboard for the CI service and check the build status along with any relevant log messages through their browser. A history of builds and log messages is usually logged by most CI services and can be accessed through the CI service user interface or CLI. The frequency of logging should be reduced when an application is deployed into a production environment, as unnecessary log messages will hinder application performance when being used by real-world users. In this video, I'll describe the stages of the continuous integration pipeline and the importance of each stage. In order to facilitate the quick release of code features in a software development project, many companies are turning to continuous integration or CI and continuous deployment or CD. A CI/CD pipeline is comprised of several stages, which takes a source code commit to a deployed production-ready application ready for a user to use. The pipeline starts with a developer creating a local code commit with a new piece of functionality they created. Automated unit tests would also be created for the piece of code, along with an automated code review using a code analysis tool and a peer-led code review with other team members. This code commit then triggers an automated build, where automated unit, performance, integration, and security tests can execute. If everything passes as expected, The code commit is then integrated or merged into the mainline version control branch for the project. This triggers another automated build and unit along with integration tests are run. After the build completes, functional, security, and performance tests are executed in a cloned production environment. Finally, the application can be deployed to a live production environment, and additional tests can be run to ensure that it is behaving as expected. The first step in the CI/CD pipeline is code generation. In this step, a developer would write the code for a new feature and test it locally. They would then attend a peer-led code review meeting to ensure that there are no bugs in the code. Once this is done, they would create automated unit test cases to be used by the CI pipeline in order to test their new feature. Finally, they would use automated code analysis tools to detect and fix any common issues which may not have been caught in the peer-led code review. The next step would be to integrate the new code into the mainline build. This step involves merging the developer's local branch into the mainline branch. Once this is done, build and test scripts trigger an automated build. Unit testing and integration testing also occur. All results for the build status and test results are logged by the CI service, and a report containing results is sent to the team members at the end of the build. Team members also have the option to check the status of a build in the CI service user interface along with any log files. Anytime a test case fails, the whole build fails, and the associated log messages are sent to all team members. At the end of the build and test phase, the application is deployed in a staging environment for validation, which is an exact clone of the production environment from the operating system to the database software and the port setup and so on. In this environment, additional functional, user interface, security, and performance tests can be run to ensure that the application runs as expected under simulated user loads. Once this stage passes, the CI/CD pipeline can deploy code to a live production environment in an automated fashion and run additional smoke tests to ensure that the deployment occurred as expected. Throughout the whole CI/CD pipeline, all software testing and integration processes are automated through build and test scripts, and once the commit is merged into the mainline production branch of a project, all steps are handled automatically right up to the deployment to a live production environment and user base. Another thing to note is that the best way to deploy an application is by using a strategy with minimum downtime. This may mean that the application needs to be deployed gradually in stages, or that there needs to be a mirrored production environment which can be used to deploy the new application in parallel with the old application and switch over all existing traffic to the new application once it is up and running. In this video, I'll compare continuous integration, continuous delivery, and continuous deployment and how they are related to each other. In the past few videos, I've been mentioning various terms such as continuous integration or CI, continuous delivery, and continuous deployment, which could also be referred to as CD. In this video, I will go over in more detail which each of these terms means in relation to DevOps in an FSD software development project. The first thing to note is that all three of these terms are similar in a sense that they help make the development, testing, and release of software quicker and more automated. The difference between the terms is that the actual number of steps in the pipeline and the level of automation required. Continuous integration or CI is the foundation of the pipeline and deals with the automated building, testing, and packaging of a software commit when merged into a centralized main project repository. Continuous delivery takes CI a step further and continues the pipeline to the release phase, where through one or more simple manual steps or approvals, a developer can release an application into a production environment. Finally, continuous deployment deals with taking a code commit and running through the whole CI pipeline and release phases right up to getting an application running in a production environment without any manual steps required. Continuous integration is the first step in the CI/CD pipeline. In this step, a developer merges their committed code updates into the project's mainline branch as frequently as possible. These merges trigger an automated build, followed by automated unit and integration test case execution. And finally, once all these steps pass, a packaging on the application build products is done in order to prepare it for delivery. Continuous delivery takes the build products from the end of the CI pipeline and automates the release process so that applications can be released frequently and in small batches whenever new updates occur. Deployment to production is not fully automated, however, with continuous delivery, as there is still the requirement to have at least one manual step by the development team, such as having the developer verify the application before clicking a button to trigger the automated release process. At the end of the CI pipeline, integrated application code is moved into a test environment, which is a clone of the production environment, where further security, performance, and usability and acceptance tests are run. After these tests are run and are verified to be passing, the developer can trigger an automated release through the click of a button to get the updated application running in a production environment. Continuous deployment is the most automated way to release software. It takes a developer commit, which is merged into the mainline project branch, all the way through the CI/CD pipeline to a deployed and tested application running in production with no developer intervention required. The whole process runs smoothly and fails if any stage of the build fails or if any automated test case fails to pass. By having an effective continuous deployment strategy in place, a developer commit can be running in a production level application within a few minutes, which accelerates customer feedback and encourages developers to commit code changes frequently and in small batches. Implementing an effective CI/CD pipeline is becoming a necessity for modern software projects being developed in a fast-moving agile environment. That being said, it is no easy feat to implement an effective continuous deployment pipeline and takes time and work on the part of the development and DevOps teams. Using third-party CI and CD services such as CircleCI and Jenkins, along with automated build and test scripts, aids in the creation of an effective CI/CD pipeline. Unit tests and integration tests should be automated and be triggered to run automatically in the CI/CD pipeline. Unit tests should be written using a unit test framework such as JUnit for Java projects. Anytime a new feature is added, there needs to be associated automated unit tests added to the build in order to ensure that it is functioning as expected. The deployment process should be continuously improved and automated. For example, a project may start with a CI pipeline and then later add continuous delivery, and finally, once everything is running smoothly, continuous deployment can be implemented. In this video, I will describe the benefits of using continuous integration for FSD. Continuous integration, or CI, is gaining popularity with companies developing full-stack applications. This is due to the many benefits that CI offers, and also because CI works well with agile software development methodologies. Since developers merge code into the mainline branch more frequently in the CI pipeline, and these merges trigger automated builds and test case execution, code is more frequently verified for its accuracy and functionality. This results in having a more production-ready code base, which can be deployed in a short time span. It also means that code development and deployment life cycles can be shortened, and that features can be deployed in a smaller, more frequent chunks into a production environment. By having automated test cases and build processes and unit tests for each new feature, test coverage is improved along with test execution consistency, which results in a more stable and higher quality code base. Finally, by using CI services such as Jenkins along with build and test scripts, a repeatable build process can be implemented in order to ensure consistent and automated way to frequently build, test, and deliver software updates into a production environment. CI enables a code base to be stable and production ready by running builds and automated test cases against every single code commit on the mainline branch. This ensures that all code, even code that is still in development, maintains a high quality, and it also has the benefit of having a fast deployment cycle, which means that customer and client demos can be quickly created and improvement suggestions can be more rapidly implemented to create a better end product. By using a CI pipeline and a CI service integrated with a project version control tool, all test cases are automated and testing occurs frequently on smaller commits of code. When a developer wants to merge a commit into the mainline branch, the CI service automatically runs a build and test suite execution and only allows the merge to happen if the build and all test cases are passing. This process not only reduces the amount of time running manual test cases, but also reduces the amount of time spent doing peer-led code reviews. Since a CI/CD pipeline automates the build, testing, packaging, and delivery of an application, High-quality software can be more quickly deployed to a production environment, resulting in a quicker time to market and more efficient, shorter development lifecycle. This in turn results in a competitive advantage for a company as they can more quickly capitalize on a new idea or newly received feedback from their customers. A CI/CD pipeline, as I mentioned in previous slides, improves code quality and test coverage, which reduces the amount of time running tedious manual tests. CI services have tools built in to report on the automated test coverage for an application so that new features can be tracked and total test coverage should remain high by the creation of new unit and integration tests. By running tests in an automated fashion, test cases won't be skipped and more code errors or bugs will be caught before pushing an update into production. Logging and reporting is also included with CI services, which displays a history of the status of a build along with test case status and log messages. Anytime a build fails, a report with the associated error messages and log files can be sent to all team members in an automated fashion in order to get to the root of the problem as quickly as possible. Creating automated test cases for new features initially increases the time required for the QA team compared to manual testing. However, once the automated tests are running in the CI pipeline, the time savings and test coverage levels are greatly improved over manual testing. This frees up the QA team to focus on more critical application tests, such as usability, performance, and acceptance testing. By having a standardized and repeatable automated build process, it not only reduces time required to build for the development team compared to running manual builds, but also ensures that commands won't be missed and that best practices can be adhered to. Since every build execution is the same and build processes are configured through centralized build scripts, it is possible to tweak the build process to ensure that everyone on the team gets the optimal build configuration every time. By implementing automated testing in the build process, every single code change is run against the same test suite, which instills higher confidence that code is bug-free and production-ready. In this video, I will identify which metrics to track when performing CI/CD. In order to improve and maintain a high-quality CI/CD pipeline, it is important to measure and act upon various DevOps metrics, which are measurements taken of various parameters in the pipeline. Some of the metrics to measure include system availability time, number of code branches, and mean time between failures. System availability time measures the amount of time that an application is available to end users to use. This metric should ideally be 100%, but in reality, things such as scheduled maintenance and application upgrades can cause temporary application outages. Ideally, these outages would occur at a time where application traffic is low, such as late at night or on weekends. In order to improve system availability, the deployment strategy can be updated to deploy gradually with minimal downtime or to deploy to a parallel production environment and then switch traffic over afterwards. A continuous delivery or CD pipeline is designed to build and deploy off of an application's mainline branch. It is important to track the number of branches a project has in version control in order to determine if code is production ready, or if the number of branches is growing, there may be a greater difficulty in merging all changes into the mainline branch and getting code into production. Mean time between failures deals with the amount of time between failed builds, and mean time to recover is associated to this metric as it measures the amount of time to bounce back from a failure. In order to increase the mean time between failures, a production cloned test environment needs to be used in order to do comprehensive automated test cases which can be run locally before the code is pushed into production. Other metrics include lead time to production, number of deploy-ready builds, number of bugs and production issues, and number of test and production deployments. Lead time to production measures the amount of time between the start of the development of a feature until that feature is running in a production environment. This metric is beneficial for project planning and in order to inform business stakeholders of how the project is progressing. A deploy-ready build is just as it sounds, a build which has passed all automated tests and can be deployed to a production environment. Measuring the number of deploy-ready builds can indicate how often commits are being pushed to the mainline branch, as well as how efficient the CI pipeline is in taking a commit and running through the build, test, and package phases of the pipeline. The higher the number of deploy-ready builds, the better, as it indicates that developers have confidence to push often and that the build and automated testing processes in place are effective. The number of bugs is another metric to measure because if a CI/CD pipeline isn't in place, Buggy code will automatically be deployed on a frequent basis to end users in production, which is a big issue. The number of test and production deployments is a metric which can give information on how effectively an application is being tested and how frequently an application is being deployed into production. There should be one or more test deployments for every production deployment to ensure that all test cases are being run before deployment occurs. Regression test duration, defect resolution time, and development cycle time are all metrics which should be tracked as well. In order to implement a successful CI/CD pipeline, automated regression tests need to be run against a new build to ensure that errors are caught before releasing into production. Regression test suites should be able to be completed as quickly as possible in order to increase the frequency of builds and deployments in the CI/CD pipeline. Defect resolution time deals with how long it takes the team to fix a bug in the code. Usually teams have a bug tracking tool such as Jira set up and integrated into their version control system, so it is possible to track this metric. Ideally, bugs should be fixed as soon as possible and should not linger on for months or years. Development cycle time measures the time required from when a commit is pushed into the mainline branch until the commit is deployed into production. Reducing this time can be done by parallelizing build processes, running unit tests early on in the CI/CD pipeline to catch errors quickly, and passing build products down the CI/CD pipeline to avoid having to rebuild in each stage. Measuring the automated test pass rate enables teams to know how the trend of recent developer commits is affecting the quality of an application. Automated unit and integration test pass rates should be tracked for each automated build execution and can be viewed in the CI service and also sent to team members using automated emails. The defect escape rate deals with measuring the number of defects found in a production environment which were not caught in the QA automated testing environment. This measure is good to know as it gives an overview as to how effective the automated tests are and which tests need to be added or updated. In order to have an effective CI/CD pipeline, broken builds need to be fixed quickly so that new commits can be added by developers. The broken build time measures the time required to fix a failing build so that the build status is restored to a functioning state. The deployment time measures the actual time spent in the deployment phases of an application. This time should be tracked and the deployment process tuned in order to keep the time to a minimum, as developers may push code changes many times a day and deploying quickly helps clear the pipeline and get changes out to customers. The number of failed deployments or mean time to failure for deployment is a metric which outlines the number of times an application failed to successfully deploy to a production environment. This metric should be kept as low as possible and rollback contingencies should be put in place to protect users from experiencing outages in the case of a failed deployment. FSD applications should keep downtime to a minimum with ideally no application downtime between deployments, as downtime impacts customer satisfaction and overall application usage levels. The production downtime between deployments metric measures downtime between separate deployments. Ideally, through improvements in the deployment pipeline, such as deploying gradually or in parallel environments, deployment downtime will decrease. In this video, I'll describe the features of common continuous integration tools. There are various tools which need to be used in order to implement an effective CI/CD pipeline. Automated testing frameworks and tools are required in order to create and execute test cases after a build is triggered in the CI/CD pipeline. Frameworks such as JUnit for Java are used to write automated tests to ensure that an application works as expected and without bugs. These test cases can either be manually run by developers or can be run by CI services automatically during and after the build of an application. Automated deployment tools take application build artifacts from the CI pipeline and copy them over to the production server, as well as running tests to ensure that everything is deployed to production as expected. Source control tools such as Git are required for all CI/CD projects. They enable a team to collaborate and work together off of a shared codebase and to merge changes in without causing conflicts. Build automation engines run using build scripts in order to automate the build of an application and create the release. CI services can run on triggers such as a developer commit to the mainline branch to automatically trigger build scripts in the CI pipeline. There are various testing frameworks which can be used to create automated unit tests for FSD projects. The framework to use depends on the programming language and technologies being used. JUnit is used as a testing framework for Java projects, and it is open source and an important framework for the creation of test-driven development. The idea behind JUnit is to write the test case code first and then to implement improvements to the application code to ensure that all test cases pass. TestNG is an automated framework for Java based on JUnit and NUnit. TestNG differs from JUnit because aside from unit testing, it can also execute functional, end-to-end, and integration tests. It has more options for test configurations as well as a concurrent testing support and a flexible execution model. NUnit is a unit testing framework used for .NET projects and is similar to JUnit in its functionality. It is written in C# and is open source. NUnit supports parallel running, data-driven tests, and is compatible on multiple platforms such as .NET Core and Xamarin Mobile. As I mentioned, automated deployment tools take application build artifacts built in the CI pipeline and copy them over to the production server, as well as running tests to ensure that everything is deployed to production as expected. Some examples of automated deployment tools include Octopus Deploy, Google Cloud Deployment Manager, and AWS Code Deploy. Octopus Deploy is ideal for .NET projects, even though it also supports other languages as well. Octopus Deploy can run either on-premise or in the cloud as a deployment as a service, and supports multiple environments such as Docker. Google Cloud Deployment Manager is used to continuously deploy applications to the Google Cloud Platform. It uses a template-driven configuration and is easy to use and supports multiple Google Cloud Platform components working together, such as Cloud Storage, Compute Engine, and Cloud SQL. AWS Code Deploy is designed to automate the deployment of applications to both on-premise as well as the Amazon Cloud EC2 instances. It works with code in Amazon S3 storage, GitHub, Bitbucket, and more, and integrates with several CI tools such as Jenkins and CircleCI. Source control tools such as Git are required for all CI/CD projects. They enable a team to collaborate and work together off of a shared codebase and to merge changes in without causing conflicts. There are various source control tools available, including MS Azure DevOps Server, GitHub, and Bitbucket. Azure DevOps Server is a tool created by Microsoft to provide version control to an entire CD pipeline, including automated builds, test execution, and deployments. It uses either Git or Team Foundation Version Control, or TFVC, as the version control system. It runs either in the cloud through the Microsoft Azure Cloud or in a local environment through Visual Studio. GitHub is the most popular place to host open source projects created with the distributed Git version control system. It has various plans available from free ones to paid enterprise plans, and also incorporates additional features such as bug tracking and task management. Bitbucket is similar to Git in the sense that it uses the distributed Git version control system along with the Mercurial version control system. The main difference is that while GitHub is designed with public open source projects in mind, Bitbucket is designed with private enterprise level projects in mind and is used more by private businesses. Build automation engines run using build scripts in order to automate the build of an application and create the release. CI services can run on triggers, such as a developer commit to the mainline branch, to automatically trigger build scripts in the CI pipeline. CircleCI is a continuous integration tool that works with GitHub and various programming languages such as Java, Python, Node.js, and PHP. It offers containers for building projects in a parallel environment, with the first one being free and a total of 16 containers supported at a time. Bamboo is an on-premise CI solution built by Atlassian, the same company which owns Bitbucket and Jira. It works with Jenkins configurations as well as supporting both Jira and Bitbucket version control systems. Bamboo comes with a 30-day free trial, and after that, there are paid versions available. Jenkins is written in Java, and it is a GUI and console-based open source CI tool for multiple platforms. It is not only free to use, but is also very flexible and powerful thanks to its wide array of plugins available from the open source community. TeamCity is a CI tool by JetBrains, and it is available on many platforms and, like Jenkins, contains a wide array of plugins. It gives developers the option to have up to 3 build servers and up to 100 build configurations for free. It supports multiple frameworks, programming languages, and version control systems, such as Git, Subversion, Perforce, and ClearK. In this demo, I will create a demo using Azure DevOps Demo Generator. Azure DevOps comes in 2 flavors, Azure DevOps Server runs on-premise, and Azure Services is a cloud-based online browser-based DevOps tool created by Microsoft. Azure DevOps is designed to manage an application over the entire duration of its life cycle and has features such as version control, requirements and project management, automated builds and testing, and release management. It allows a project to configure a CI/CD pipeline and to do continuous deployment on developer commits. Azure DevOps Demo Generator offers pre-built template-based projects to help more quickly create new projects and to aid in learning how to use Azure DevOps. In order to follow along with this demo, you'll need a free demo Azure account. In order to sign up for your free Azure account, you go to azure.microsoft.com/en-ca/free, and you simply click Start Free to get started with 12 months of free services. Now, once that's done, the next thing we want to do is we want to go and create a new Azure DevOps demo. So we go to Azure DevOps Demo Generator.azurewebsites.net, and I'm simply going to click either sign in if I already have an Azure account or get started for free. Since I already have an Azure account, which I created when I created my free Azure account, I'm going to click sign in. Here it's going to ask me to select an organization. I'll pick Boris ABC123, which is my organization that I created. The new project name, I'll just call it Test Shuttle. And the template, I'm going to click Choose Template to choose my project. I'm going to choose the My Shuttle project and click Select Template. This is basically a Java application backed by a MySQL database, and it uses Maven for building, and it deploys to a Tomcat server running as an Azure App Service. So once that's done, I could click Create Project, and that's going to take a little bit to create the project. Now let's go over to the third tab here, which is our logged in Azure dashboard. So it's portal.azure.com/home. So what we're going to do here is we're going to click on the Cloud Shell just beside the search bar here, and that's going to launch the Cloud Shell in the bottom. And we're going to be executing some commands, creating some resources within the Azure portal, which we'll be using by our web application. So the first thing we're going to do once we're logged in is we're going to create a resource group. We're going to call it Test Resource Group, and the location will be in the East US. So I'll just copy and paste that command into the Cloud Shell. Once that's done, I'm going to go ahead and create an app service plan. So I'm going to specify my resource group, and the name will be my plan, and the SKU will be S1. So I'll paste that in there. After that's created, I'm going to create the web app with a unique app name. So I'm going to use the web app create command. I'll specify the resource group, the plan, and I'll give my web app a unique name. In this case, I'll call it Test Shuttle Application. And once the previous command is done executing, I could paste in this command and run that. And finally, the last thing I have to create is the MySQL server with a unique server name. So I'm going to pass in, or I'm going to use the MySQL server create command, pass into resource group the name. So it'll be MySQL DB Shuttle Server. It has to be unique. The admin user will be BMISLGN, and the admin password will be P2SSW0RD@123, and the SKU name will be GPGen5_2. So I'll pass that in, and that's actually going to take a little bit to create, but I'll pass that in, hit paste, and hit enter, and that's actually going to create MySQL Server instance in Azure. Let's go back to the Azure DevOps Demo Generator tab, and we could see here if we scroll down that we have the release definitions created. We could click navigate to project now to take a look at the project. And inside here, we could see our Test Shuttle project. We have our repos with our files containing all our source code. We also have our pipeline. So we have our build configurations, both for the regular build and the Docker build, as well as our release and deployment configurations also for the regular one and for Docker. So we'll be working on this later. First, we'll be back in the Azure portal configuring some things. And then once that's done, we're going to hop back into the Azure DevOps Demo Generator under Azure DevOps and work on our project to configure the release settings. So now that we've created our MySQL server, we could go under our portal.azure.com. Under our main dashboard, we could go to resource groups. We could click on Test Resource Group, the resource group we created. And if we refresh it, we should see that shortly we'll have our MySQL Server come up, and then we'll be able to look at the settings in the MySQL Server, and we'll also be able to edit the security settings so that Azure DevOps can connect. So we could see now that our MySQL DB shuttle server is up. We're going to click on it. First, we're going to go under Connection Security. And what we're going to want to do is we're going to want to allow access to Azure services. We're going to click on for this. So that's going to allow us to access it from the DevOps template that we generated. And we'll click Save. If we scroll down now, we're also going to want to go to Settings here, and we're going to want to get the host name as well as the login information. So that's going to be under our properties, and our server name is going to be this one here, so MySQL DB shuttle server.mysql.database.azure.com, and the server admin login name, we're going to want to copy that in as well. I just pasted that into a notepad document, so I have the admin name, the password, as well as the host name. And once that's done, we're going to go ahead and we're going to set up some settings on our web apps stack configuration. So if we go back into our Azure portal, we're going to go back to resource groups, test resource group, and then we're going to click on our test shuttle application. And under here, we're going to want to click on configuration. And then we're going to want to go to general settings. We're going to select the stack as Java. Java version is going to be Java 8. Java minor version, we're going to select as Java 1.8 auto update, and Java container Tomcat. Java container version is going to be version 9.0 auto update. We're going to click Save. Once that's done and saved, we're going to go to application settings. And under application settings, we're going to create a new connection string to connect from our web application to our MySQL database. So this connection string, we're going to simply call it MyShuttleDB. And the value is going to be JDBC. We're going to specify MySQL. So we're going to specify the host name, MySQL DB shuttle server.mysql.database.azure.com, port 3306. Then we're also going to have to specify the user. So that's going to be the user we copied from that database. So in my case, it's bmisLJEN at MySQL DB shuttle server. And the password is going to be the password we created or we specified when we created the MySQL database. So we're going to copy this long string in and paste it as the value. And then we're going to click OK. And then we're going to click Save. So now that that's done, we've basically finished all our Azure portal configurations. We could now go back to the Azure DevOps and we could go ahead and start a build. So under Azure DevOps in our test shuttle project, we're going to go under builds and we're going to select My Shuttle Build and click Edit. Once that opens up, we're simply going to click on the Maven POM .xml and click Q. We're going to leave all the defaults and click Run. That's going to go ahead and execute a build. While the build's occurring, let's go to Releases under Pipelines, and we're going to go to My Shuttle Release and click Edit. And here we have a few tasks we have to finish, so we're going to click on Tasks and Azure Dev. So this is going to execute Azure MySQL SQL tasks, or we're going to have the SQL task file. So for the Azure subscription, we're going to click on the downward arrow, click on our subscription that we have, and click Authorize. That's going to get us to log in to our account. And then we're going to have to authorize our subscription. So once again, just the email and the password for our Azure portal account. Once that's authorized, we're now going to have to put in the DB details. So for this, what we're going to do is we're simply going to take the stuff we copy and pasted from our database, so the host name, the admin name, as well as the password, and we're going to have to paste those three things in. So first the host name, then we're going to have the admin login, and finally we're going to have the password that we created. So it's good to have this copy and pasted because we do use it a number of times throughout this process. Once the password's in, so now once everything's in, we're going to go to the next step, to the deploy Azure App Service. Once again, we're going to have to select our Azure subscription. Then we're going to have to select the app service type, so web app on Windows, and app service name. So what we're going to have to do is we're going to have to get our app service name. So in order to get that, we could go back to the Azure portal, and we could go back to our resource groups, test resource group, and we could simply look at the app service that we have. So it's called Test Shuttle Application. So I'm going to go ahead and put that name in. Once that's all done, I'm going to make sure that's all configured as expected. Everything is auto-saved. We could take a look at anything else that needs configuring. So the agent pool, in this case, we're going to select Azure Pipelines. The agent specification, we're going to want to select Ubuntu 16.04 and click Save. So now everything's configured as expected, and we could click Create Release. And this is actually going to create a release when we hit the Create command. And once the release finishes creating, we could click on it here and look at the various log files and see what's happening. Once that's finished creating, we could actually go ahead and we could log in to our running instance of the web application in our browser. So we could see that the release completed successfully. And if we go to testshuttleapplication.azurewebsites.net/myshuttledev/, we could see we have the MyShuttle application. We could log in with Fred, and Fred's password would simply be Fred password. And we could click Login. And this is going to give us a dummy user, Fred. In our test application, we'll be able to see his fare history in the shuttle application. So now the application is fully running. It's being deployed in Azure using Azure DevOps. In this demo, I'll demonstrate how to use GitHub and Travis CI in order to create a simple CI pipeline and deploy a full-stack Node.js application. In this demo, we will be creating a simple Node.js and Express.js application with one automated test case. We will add this application to a GitHub repository, and we'll create two branches. One will be used for testing and creating developer commits, and another will be the master branch, which will be used for production and which will be deployed to Heroku using the Travis CI continuous integration service. In order to follow along with this demo, you need to have a free GitHub account along with a free Heroku account, as well as Node.js version 10 and Git for Windows installed in your Windows 10 environment. So the first step is to open up our Atom code browser. We could also open up any other type of text editor or IDE for our Node.js project. And we're just going to go ahead and open up the project. So I'll go to File, Open Folder. Under Projects, we're going to scroll down and we're going to find our Hello Node project and click Select Folder. That's going to load the project in. So now I'm just going to talk about some of the files in this project. So we have our index.js, so that's our main Express and Node.js server file. We're simply displaying Hello Node on line 6. And we are listening on port 3000 here on between lines 11 and lines 13. So it's a very simple Hello World application, except it displays Hello Node. Then we're going to go to our package.json file also in our root directory. So this just specifies all our dependencies for the project. So we have supertest, npm, mocha, install as our dependencies, as well as Express. And for our test script on line 7, we're going to define mocha space -- exit because that's what's going to be running our test cases. They will be written in mocha and supertest for the HTTP requests. The proc file is simply going to contain the instructions for Heroku to launch our application. So that's just going to be node space index.js. Our test.js file is going to create our unit test using mocha and supertest. So between lines 4 and 13 is the unit test. And we're simply going to make sure that Hello Node is displayed. If you could take a look here on line 10, we actually have an error in the unit test. We have 2 exclamation marks when we're only displaying 1. So this unit test will actually fail, and we'll be fixing it in the demo. So once that's all done, let's go to our Windows command prompt inside our Hello Node directory, and let's just run the unit test. So we'll run npm space test, and that'll trigger the mocha space -- exit command with our unit test, and we see that it's failing. So what we're going to do now is we're going to go ahead and we're going to go into our browser. We're going to go to github.com, log into our GitHub account, and in the top right, we'll click on the plus sign and click New Repository to create a new GitHub repository. I'll call this repository hello-node-boris. I'll scroll down, it'll be a public repository. I'll leave everything else as default and click Create Repository. Once the repository is created, I'll go back on my command prompt and I'm going to initialize a Git repository in my hello node directory. So I'll type in git space init. Then I'll type in git space add space dot to add all the files for the commit. Git space commit space m, and then I'll put first commit in quotation marks. And then what we have to do is we have to set the remote origin which we'll be pushing to. So we're going to run this command, just copy and paste it in, git remote add space origin space https github.com/my repository/hello-node-boris.git. So once we copy that in, we could go ahead and run that command, and then we could run git space push space u origin master, which is going to push it to a remote repository that we created in GitHub. So it's just going to push that commit with all our files. So once that's in GitHub, we should be able to go into GitHub, and if we refresh our repository, we should be able to see that we have our code in here, and we do. So now what we're going to do is we're going to go to Heroku. So we're going to go to dashboard.heroku.com/apps and click on new in the top right and click create new app. We're also going to give this app a name. So hello space, we're going to type hello-node-boris. The region will be United States, and we'll create app. Then under deploy, we're going to scroll down to deployment method and we'll select GitHub. We'll scroll down, we'll have to pick our repository, so I'll just type in hello, and we could see my GitHub account is logged in, and I'm going to select the hello-node-boris repository and hit connect. I'll pick the master branch, and then I'm going to select wait for CI to pass before deploy, and I'm going to click enable automatic deploys. So now it says automatic deploys for master are enabled. So now what we want to do is we want to go ahead and we want to set up the Travis CI settings. So back in our Atom code browser, inside the hello_node project, we have our .travis.yaml file. So that's the Travis CI settings, which is going to tell it how to do builds and deploys. So you could see on line 1, I'm defining the language as node_js. On line 3, I'm defining the Node.js version as 10. So the before install command is going to be npm install space -g space npm, so that's going to install npm globally. Then I have 2 script commands on line 7 and 8. npm install is going to install the dependencies on line 7. npm test on line 8 is going to run that Mocha test before we do our deployment. Now our deployment, we're going to select the provider's Heroku, the API key. So the way to get that is to go in the browser. Under Heroku, we could click on the top right when we're logged into our account and click on account settings. And then if we click on account here at the top left, scroll down, we could actually go ahead and we could take a look at the API key. If we click reveal, copy and paste that in. Now there's another way to do it that masks the API key, which is the proper way in production, but just for the sake of speed for this demo, we're just going to copy and paste that API key in here on line 11 as the API key. The app will be the app name we created on line 12, so hello-node-boris. And on the repo on line 14 will be the hello-node-boris GitHub repo, and the branch will be master on line 15. So once that's all good, we could go to travis-ci.org and click sign up. So Travis CI works alongside GitHub projects. So if you already have a GitHub account, it's very easy to get started. So this automatically logs me into Travis CI using my GitHub account. In the left-hand menu beside my repositories, I'm going to click on the plus sign to add a new repository. I'll scroll down and I'm going to go to hello-node-boris and click on that and click on activate repository. Now that that's done, I could click on more options and click on trigger build, and the branch will be master, and I'll click trigger custom build. So this is going to trigger a manual build. I just want to make sure that what I push should pass, and it actually shouldn't pass because that test case is failing. So we could actually see in Travis CI the steps, so the jobs received, it's queuing, it's booting the virtual machine, and then we could actually take a look at the logs that it's spitting out, and we could take a look at the build status once it completes. So we could see our build failed because of that failing test case. So let's go back inside the Atom code browser under our test.js file. We're going to change that by deleting an exclamation mark. So it's just going to be hello space node exclamation mark with one exclamation mark on line 10. We're going to go ahead and save that file. And then we're going to go back inside our command prompt. We're going to type in npm test just to test it once again, make sure that everything's passing. We could see it's passing now. So let's check it into a new branch. So we're going to run git space checkout space -b to create a new branch, and we're going to call it test. So we switch to new branch test. We're going to do git add dot, which is going to add that new file. Git commit -m space test. Okay, once that's in, we could write git space push space origin space test. That's going to push it to the test branch on the remote repository. So once that's done, we could go inside Travis CI, and we should see a new build being triggered. Now, this build should actually pass because it's going to contain the fixed version of the test case. So we could see that the second build is green, it passed. So now what we're going to do is we're going to go back to GitHub inside our repository. And what we're going to do now is we're just going to refresh it here, and we should see 2 branches come up. Then we're going to go ahead and we're going to create a pull request. So what that's going to do is we're basically going to be able to pull the changes from the test branch into our main master branch, which is going to create a new build and a new deployment. So I'm going to click on compare and pull request. And basically what we're going to do is the base will be master, the compare will be test, and we could see the changes here. So we could see that we only have 1 exclamation mark inside our test branch, so that's going to get merged into master. So we're going to click on create pull request. Now, in order for the pull request to actually work, it's going to do another build with Travis CI. Once that build passes, we'll be able to merge the pull request and do a final build before deploying to Heroku. Now that we see that all our checks have passed, we're going to click on merge pull request and confirm merge. Once that's done, we could see that the pull request successfully merged and closed. Then we could go back to Travis CI, and we could see one last build being triggered with that new merge inside the master branch. And then we'll be able to see that application actually get deployed after the successful build onto Heroku, and we'll be able to see it running. So here we see the new build has started. So we see the final build passed. We can now go back to Heroku. If we go back to our dashboard, we could click on our hello-node-boris app and click on open app, and we see hello space node exclamation mark being displayed. So now we've essentially deployed that working app into a production environment running on the internet. In this video, I will perform a demo using Bitbucket pipelines. Bitbucket pipelines are a CI and CD service for use with Bitbucket projects, and they enable a project to be built, tested, and deployed through a CI and CD pipeline. Bitbucket pipelines allow you to add a configuration bitbucket-pipelines.yaml file to the root directory of a project hosted in a Bitbucket repository. This file specifies the build, test, and deployment settings for a project using Bitbucket pipelines. In order to follow along with this demo, you need a Bitbucket free account and a Heroku free account, as well as Node.js and Git installed on your computer. With a Bitbucket free account, you get 50 minutes of build time every month for use with Bitbucket pipeline. So let's get started. I'm going to open up my Atom text editor, and inside it, I'll open up my hello_node, Node.js, and Express.js project, which we've used in previous videos. Now, just to go over it once again, this project is a very simple Hello World, Node.js, and Express.js project, except it prints Hello Node. The index.js file is the main server file, and we could see on line 6 we're printing Hello Node, and we're listening on port 3000. We also have a test.js file, which simply defines a unit test using Supertest and Mocha, and it's basically going to make sure we're displaying Hello Node. If not, we're going to display an error on line 10 saying missing Hello Node, and basically the build should fail in a CI pipeline. Next, we're going to go over the proc file. So the proc file simply tells Heroku how to run our project, so node space index.js, and the package.json file, which defines all our dependencies. Let's go ahead and run the hello node project. So in the hello_node directory, we could type node space dot, and that's going to listen on localhost port 3000. We could now go to localhost port 3000 in our browser and make sure we're getting hello space node exclamation mark. Once that's all good, we could run our unit test. So we're going to run npm space test and make sure that our unit test is passing, and it is. Let's go back to our browser. We're going to go to Bitbucket and log into our account and go to the home page. Once we're at the home page, we're going to want to go to the repositories tab and click on create repository in the top right. We're going to give the repository a name, so I'll call it hello_node. And we're going to select this as a private repository, include readme no, and version control git, and click create repository. We're now going to want to go ahead and initialize a local git repository inside our hello node directory. So I'm going to run git space init, and then I'm going to run git space add space dot to add all our files, and git space commit space -m quotation marks. I'll just put first commit as the comment, and that's going to add all my files as the first commit. Now I'm going to go back to my browser. I'm just going to copy from step 2 here. I'm going to add the remote to my Bitbucket repository. So I'll run the git remote add command, and finally, once that's done, I could run the git push space -u space origin space master to push all my changes into the master branch of my newly created Bitbucket repository. So once that's done, we could now go back into our Bitbucket dashboard, and once the push completes, we should see that our source directory is going to have our code, and it does. So now what we want to do is we want to make sure pipelines is turned on. So we want to go down to settings, scroll down and go to pipelines and go to settings. And we're going to make sure that enable pipelines is checked. Once that's done, we're going to create a Heroku application. So we're going to go into another tab and go to dashboard.heroku.com/apps in our free Heroku account. And on the top right, we're going to click new, create new app. We're going to call it hello-node-boris. It's going to be in the United States region, and we'll click create app. Now, once that's done, we're going to go back into Bitbucket, and we're going to scroll down under pipelines and go to repository variables. We have to add 2 repository variables for our deployment, so we'll do that now. The first one of which is going to be the Heroku app name. So that's simply going to be that app we just created in Heroku. So that's going to be hello-node-boris. We're going to go ahead and we're going to click add here. And once that's done, we're going to scroll down and we're going to add another one. So we're going to add the Heroku API key. So we're just going to copy that in. And the Heroku API key is basically the unique identifier for our Heroku account. So to get that, we want to go back to Heroku. We want to click at the top right here for our account, click on account settings, scroll down, and under API key, we want to click reveal, copy that API key in the value field, click secured to encrypt it because it is sensitive information, and click add. So now we have the API key and the app name defined, so we'll use that for the deployment settings when we're creating the pipeline. Now we could go ahead and create the pipeline in Bitbucket. So let's go to pipelines. Scroll down, we're going to pick a language template. So let's pick JavaScript because we have a Node.js project. And we could see we already have a basic template created here. So we could see in here that we're caching the Node modules directory. We're also going to be running npm install and npm test. So now all we have to do is add the deployment settings. So I'm going to add the command to basically push any changes once the build succeeds into our Heroku repository. So we're going to use git space push space https://heroku API key. So that's that environment variable we defined at git.heroku.com/heroku_app_name. So once again, the other environment variable we defined in bitbucket.git, and we're going to push to the head of the master branch. So let's just copy that command in, and we're going to paste it under the script tag under npm test. Once that's in, we could simply click on commit file. That's going to run the commit. If we go back to our root directory of our hello node project, we could see we have the bitbucket-pipelines.yaml file created. which is our basic configuration file for pipelines. Now let's click on pipelines, and we should see that a build is triggered automatically. We could click the in progress and actually look at what's going on. So it's currently running npm install, npm test, and now it's pushing to Heroku. Now this will run by default anytime you push a commit into your Bitbucket repository. So anytime you add anything locally, you could commit it, and then once it's pushed in, it'll automatically trigger the pipeline, which will do the build, it'll run through the test process, and then finally deploy into Heroku using those deployment settings we set in the file. So we could see now that it's finally just finishing up the build. We see the build succeeded. It's now tearing down, and we see a green status for the build, meaning that it succeeded. Now we could go back to Heroku. Let's go back to our main Heroku dashboard, and we could go to our hello-node-boris application and click open app, and we see hello space node exclamation mark. So now we've deployed the app into Heroku, and it's running on the internet. In this demo, I'll perform a demo to install Jenkins in a Windows environment. Jenkins is a free open source CI service which can be installed in a Windows or Linux environment. It supports a wide network of plugins and works with multiple version control tools such as Git and Subversion. In order to install Jenkins in a Windows environment, a few requirements need to be met. The computer where Jenkins is being installed needs to have at least 1 GB of free hard drive space, as well as 256 MB of RAM, as well as having the latest Java Development Kit or JDK or Java Runtime Environment or JRE installed as Jenkins runs using Java. Jenkins is freely downloadable off the official Jenkins website and comes in 2 flavors, which are the long-term support release and the weekly release. The long-term support release is pushed out every 12 weeks, and it's the more stable and more extensively tested of the 2 types of releases, and it's best suited for most users. The weekly release is installed in the same manner as the long-term release. However, it's released on a weekly basis, containing the most up-to-date improvements and bug fixes for use by developers working on plugin development for Jenkins. So let's get started. The first thing we want to do is we want to make sure we meet all the dependencies. So assuming you have 1 GB of hard disk space free and 256 MB of RAM, we could check if we have Java installed. So if you installed either the JDK or the JRE and you set all the paths and environment variables properly, what you should be able to do in a Windows 10 environment is open up your command prompt and simply type in Java space -version. And that's going to give you the type of Java installed. So you could see here that I have the Java SC runtime environment build 13.0.1 plus 9. So once that's confirmed and installed, the next thing we want to do is open up a browser and go to jenkins.io/download. That's the official Jenkins download page. We'll scroll down to long-term support because we want that because we're not developing any plugins, we're just using it as an end user. Scroll down, download Jenkins 2.190.34. We're going to select Windows at the bottom here, and that's going to start an automatic download. So I've already went ahead and downloaded it, so I'll just cancel the download and go into my download directory. We have a folder called Jenkins-2.190.3.zip. So we simply unzip it, and then we get to jenkins.msi. So I'm going to double click the jenkins.msi to launch the installer. And I'm simply going to click next, and it's going to want to specify a default location where to install. I'm just going to leave the default in program files x86 Jenkins. I'll click next, and I'll click install. Now this is going to go ahead and install Jenkins, and once that's all done, it should launch it as well. So it says here, completed the Jenkins 2.190.3 setup wizard. Click finish button to exit the setup wizard. I'll click finish. And we should see localhost 8080. We should see that Jenkins is getting booted up and it's getting ready and started. Now, once Jenkins is started, we're going to have to unlock it. And in order to do that, I'm simply going to go to my program files x86 folder. I'm going to go inside my newly created Jenkins directory. And inside this directory, I'm going to want to get the secret password. So I'll go to the secrets folder. And inside there, I'm going to want to get the initial admin password. So I'm just going to open up this folder. I'll copy this initial admin password, which we only use to unlock Jenkins, and I'll paste it in the browser at localhost 8080 and click continue. Once that's done, it's going to give us two options. We could either install Jenkins using the suggested plugins, or we could manually select the plugins we want to use. We're just going to use the suggested ones. So those are basically the ones that are most commonly installed with a fresh install of Jenkins. So I'll click that. And we could see here we're now downloading and installing all the plugins. So we see some of them, for example, Git, we have Pipeline, LDAP, we have Ant, Gradle, Mailer, and so on. So once that's done, we're going to go ahead and get prompted to create a new admin user. So now that all the plugins have installed, we've hit continue, and then we get to the create first admin user page. So here we want to create our admin user. So I'll pick a username, I'll click, and then I'll pick a password. So I'll just put the password as admin, I'll confirm it as admin. The full name, I'll put my name, and I'll put my email address. Now, once that's done, I'm simply going to click Save and Continue. I'm going to click Update Password. For the Jenkins URL, I'm just going to leave the default localhost port 8080. So unless we're using that port for something else, we could just leave that default configuration. It's the easiest to remember. So I'll leave that and click Save and Finish. It says here, Jenkins is ready. Your Jenkins setup is complete. I'll click Start using Jenkins. And that's going to have me inside the Jenkins dashboard. I could then click on Create New Jobs to get started. Additionally, I could open up my Windows services and I could take a look and just make sure if I go to refresh my services, I'll make sure Jenkins is running. I could right click, go to properties, and I could see that it's startup type automatic and it's being started from the program files x86 Jenkins directory by running jenkins.exe. So now Jenkins is fully installed in a Windows 10 environment and ready to use for CI for a full stack project. In this video, I'll perform a demo of continuous integration using Jenkins Pipeline. As I mentioned in the previous video, Jenkins is an open source continuous integration server which can be used to implement a CI/CD pipeline for an FSD project. The Jenkins pipeline can automate the building, testing, packaging, and delivery of an FSD application by the use of a Jenkins file to specify the pipeline configuration. There are several benefits to using Jenkins pipelines. One benefit is that multiple users can run pipeline jobs concurrently, which is ideal for bigger projects. Pipelines are also fault tolerant, meaning that if a server failure and subsequent restart occurs, the pipeline will continue where it left off. In order to follow along with this demo, you need to have JDK version 13, Git for Windows, Maven 3.6, Spring Boot 2.2.0, and Jenkins all installed and configured in your Windows environment. A free GitHub account will also be required to host project source code. So let's get started. If I open up my Atom code browser in my hello-spring project, it's a Spring Boot project, and it's basically a very simple Hello World project that simply displays Hello Spring. So we have our main file here, hello spring application.java, and inside this file, we're simply going to be returning Hello Spring when we go to our request mapping of our home or root directory. So that's on line 14 here. We could also see that we're using port 9090 instead of 8080, which is the default Spring port. This is because Jenkins runs on port 8080, so we want to avoid a conflict. We have our pom.xml, which defines all our configurations and dependencies. And we have our unit test in our Hello Spring application test.java file. We have one unit test that basically ensures that we are getting Hello Spring in the browser. And we're getting that using an HTTP request. So once this is all done, we should verify that everything works as expected locally. So what we're going to do is from the root directory of the Hello Spring project in the Windows command prompt, we're going to run the maven package command, which is simply going to build, run our test case, and package it into a jar file. And then we're going to run after that and java space -jar, and we're going to specify the directory, so the target directory where that jar is going to be built, and the name of the jar. So let's go ahead and run that. And once that's all done, if everything works as expected, we should have localhost 9090 should be able to get that Hello Spring message, and everything will be working as expected. So we could see here that our test has passed, our build has succeeded, and now we've launched the project. So let's just go into our browser, localhost port 9090, and we see Hello Spring ! So now that we've ensured that everything works locally, the next step is going to be to log into our GitHub account and create a GitHub repository. We want to create a public repository. Mine's just called hello-spring, and we just want to upload all the code into it. So once you've done that, the next step is going to be to log into Jenkins using our admin username and password at localhost 8080. And inside here, we want to go to Manage Jenkins. So what we're going to be doing is we're going to be making sure that all our plugins are installed that we need for this demo. So we're going to go to Manage Plugins. And under the Plugin Manager, we're going to want to go to the Installed tab to check which plugins we have installed. So there's two basic plugins that we need. In this case, we need the Build Pipeline plugin and the Copy Artifact plugin. So I'm going to search for Build Pipeline, and we could see the Build Pipeline plugin is installed. And the Copy Artifact plugin is not. So in order to install it, we want to go to the Available tab to view all the available plugins in Jenkins available for installation. And I'll simply type copy space artifact, and I'm just going to let it load. And it should specify that that plugin is available. There it goes. Copy artifact. It says adds a build step to copy artifacts from another project. So this is what we want. We're going to check it for install, and we're going to select download now and install after restart. And I'm going to select restart Jenkins after the job stopped running. So now it's basically going to restart, install the plugin, and we'll be good to go. So now Jenkins is restarted. I'm going to sign in using my admin username and password. And once I get into the dashboard, I could start working on building my pipeline to go ahead and build and deploy our project. So I'm going to go to Jenkins up here. I'm going to click on the Jenkins icon, and I'm going to click on Create New Jobs. I'm going to select a Freestyle project, so that's the basic type of Jenkins project, and I'll call it Hello Spring Build. Once that's done, I'll click OK. And that's going to create that new Freestyle project. So inside here, I'm going to be able to specify all the settings that I want for this stage of the pipeline. So basically, under General, I'm going to leave the description blank. And I'm going to click on Permission to Copy Artifact. So I'm going to want to be able to copy my build artifact over to the next stage. So I'm going to put in the name of the next project, which I haven't created yet, which I want to accept that artifact. So I could also enter the star, which is just a wildcard character for all projects. So out of simplicity, I'm just going to enter the star character for the wildcard. Now, if you ever want to know what each field takes, you could simply click on the question mark, and it shows you what it takes. So for example, in this case, it would be a comma-separated list of projects that can copy artifacts of this project. And it says here wildcard character star is allowed. So I'll just scroll down. For source code management, I'll select Git. I'll go to GitHub, go to my repository that I created, and click on the cloner download link, copy the HTTPS link for cloning. And I'm going to paste this link as the repository URL in Jenkins. I'll scroll down, and under build, I'll add a build step under execute shell. And for the command here, what I'm going to want to do is I'm going to want to run maven space package. Now, Jenkins already has Maven built in, so you don't have to worry about installing Maven manually. Finally, I'm going to want to add a post-build action, and that's going to be archive the artifacts. So I'm going to want to archive all the artifacts that I create. So they're going to be stored in the target directory, and I'm going to archive all artifacts that are basically jar files. So I'll specify the wildcard star character.jar. So I'll copy that in and paste that into my post build actions. And once that's done, I basically have a complete first stage here. So I'm going to click save, and then I'll create the second stage of the pipeline. So I'll go back to Jenkins, and I'll go to new item. And this is going to be called hello-spring-deploy. I'm also going to select the freestyle project. I'll click OK. So in here, we're going to want to scroll down, and under build triggers, we're going to want to select build after other projects are built. And then we're going to want to select our Hello Spring build. So that's basically just showing that we don't want the Hello Spring deploy to run in our pipeline before the Hello Spring build is completed building and packaging. We're going to scroll down, and under build, we're going to add a build step, and we're going to select copy artifacts from another project. The project name will be Hello Spring build. We're going to select latest successful build. We'll leave all of this blank because it's going to find the artifacts that we've archived anyways. And then we just want to add another build step to execute shell. And in this step, I'm simply going to run java --jar target the directory where the artifacts are stored, hello-spring-0.0.1-snapshot.jar for the artifact that I built in the previous stage. And I'm going to put the and sign, so it's going to run in the background so that the stage could complete and the pipeline could execute and complete successfully. I'm going to go ahead and paste this in, and I'm going to click save. Now that we're all done our two projects, we can now create the pipeline. So let's click the plus sign that says new view. And here I'm going to select build pipeline view, and I'll call it Hello Spring -pipe. I'm going to select OK. And it's saying a view already exists. It's called Hello Spring pipe. So let's try this again. I'll just call this Hello-Spring. And I'll select build pipeline view and click OK. So now I get some options that I could enter the name, the description, and so on. So what I'm going to do is I'm just going to leave everything basically by the default. I do want to make sure that the initial job is Hello Spring build and not Hello Spring deploy. And we've already done that by setting those dependencies when we were actually creating those projects. So I'm going to click OK. And now I could see that I basically have my build pipeline is created, and I could click on run. And I could see here that Hello Spring build is starting. Once that's done, Hello Spring deploy will start. And then if everything works as expected, I should have the application deployed by Jenkins and available to me at localhost :port 9090. So you could see my build pipeline is now green. I could go back to localhost :9090, and I could see I get hello spring ! So that's a very simple CI/CD pipeline to build a Spring Boot project in Jenkins. So in this course, we've examined FSD continuous integration and deployment, including best practices, the CI/CD pipeline, and CI tools. We did this by exploring the purpose and importance of FSD continuous integration, FSD continuous integration best practices, the stages of the continuous integration pipeline and their importance, continuous integration, delivery, and deployment and how they relate to each other, the benefits of using continuous integration for FSD, the metrics to track when performing CI/CD and the features of common CI tools, how to use the Azure DevOps Demo Generator, GitHub, and Bitbucket, how to install Jenkins in the Windows environment, and how to perform continuous integration using the Jenkins pipeline. In our next course, we'll move on to explore FSD software testing methods, including end-to-end and unit testing, automated testing, software testing strategies, and test plan creation.
In this video, we're going to talk about full stack development database systems. Now, databases are the backbone of IT services, serving as both the store and provider of important data for most organizations. Now, traditionally, the most common form of database was a relational database that resided on a server or on-prem. As datasets accelerate and the need for efficient analysis grows, the requirements for database engines get harder to satisfy. So due to these various needs, the types of database services available to organizations has grown to accommodate the business uses. So cloud relational database services are purpose-built databases that are hosted in the cloud and provide and require no overhead. For example, Amazon Aora. There is little to no management from the user, but they require a knowledge of cloud services to utilize. No-code web services are digital platforms that allow users to build web applications through a drag-and-drop style graphical user interface, requiring no knowledge of application development or coding. These services often use a back-end database that does not provide many access points, limiting the use of the data. Hosted NoSQL database systems like MongoDB Atlas or Amazon DynamoDB, they provide you the power of the NoSQL database engine without having to manage your own servers and scale as necessary. And hosted relational databases are typical database instances residing on cloud infrastructure. Google Cloud Database Services or Azure SQL Database would be examples of this model of database service. So databases that are hosted in a cloud environment follow the standard rules of any software residing on shared infrastructure. And this means that they could be single tenant, which is where a database is dedicated to one customer, multi-tenant, where one database may contain data from multiple customers, with controls in place to protect the data from being read by another customer, or they could be a hybrid tenant, where a database may have allocations for multiple tenants, but do not necessarily keep data from every customer. When selecting a cloud database tenancy model, there must be an assessment done to determine which is the best fit for the organization. So there are some criteria to consider. Scalability. The solution should be able to scale with demand without significant performance decrease. The skill set of the team should be considered when determining how complex it is to develop the application around the database. Tenant isolation for sensitive data, and whether general data can be stored alongside other customers. Operational complexity for site reliability engineers or other operational non-development stuff. Per tenant cost implications may push business decisions. Single tenant databases will always cost more than multi-tenant deployments. How customizable the platform is and how much leverage the cloud provider gives you to modify the database. Now, there are some frequently used tenancy models configurations that can be used as reference architectures for designing a deployment. Single tenant databases with single tenant applications are when the application is installed once for every customer. Each instance is standalone with no shared resources. Multi-tenant applications with the database per tenant scale vertically by adding more resources per front-end node to handle more incoming client connections to the shared web service, but have a different database for each client so the data is kept separate. And multi-tenant applications with multi-tenant databases have multiple customers coming through the same front end with customer data stored in shared databases. Static data is stored only once and shared by customers. So multi-tenant applications with a single multi-tenant database is the most efficient resource use, but also carries the risk of one customer affecting the performance of all other customers. Multi-tenant applications with shared multi-tenant databases allows for efficient scaling for apps that are going to have many different customers, but adds complexity to the overhead of auto-scaling and removal of shards. The hybrid model stores the tenant data in all databases, meaning the customer data can be, but is not always stored in any database. There are many architectural models that a developer can adopt with this type, each with their own strengths and weaknesses. Consideration for which to adopt should be around cost, performance, and security. In this video, we're going to talk about MS Entity Framework data modeling. So I have just a simple open source commerce platform up here that's popular on GitHub. I'm going to use this as a baseline to talk about. So the idea here with the MS Entity Framework and a code-first approach is to basically represent the tables and data structures within a SQL Server database, perhaps, inside code, inside an actual, say, .NET application. So in this case here, I have a project and I have a domain, which is going to represent the specific entities in my database. So let's pick on one here. We'll just pick on customers. All right, so inside here, I can have say, adjoined tables here. So these represent, say, an external authentication record or roles. These are basically child tables, all right, that can be automatically linked. So this would be the equivalent of doing automatic inner joins, for example. Every single attribute here, for example, customer GoID, public string username, these are effectively the columns in the table in the database. Email, okay, so very simple types, string, bool, basically everything that can be represented as a data type in SQL, you can use in these data models here in these classes. The next thing is to do the actual mapping, all right? So we've specified all the columns here in a class, but now we need to tell Entity Framework how to do the mapping. So I'm going to open up the same corresponding mapping class here. So this is how you would do this with the Entity Framework here. So using the entity type configuration, you would specify what the table is in terms of the table name. So this way, if your class is named differently than the actual target table in the database, you can basically override it from here. You could then specify any keys. So in my case here, there's a column ID that is the key, which is the unique identifier basically for the table. And then in code first, we can apply all the properties. So username has max length of 1,000, but is nullable, right? Because it doesn't have is required. For example, if I just start typing is required, this in SQL would translate this is a mandatory field and has a max length of 100. This is important because in code first, we create the actual database. It's not created ahead of time. So inside the SQL Server database, for example, this is a blank database, and using these rules, we're going to populate and build those tables. All right, so I'll just undo that. And here we have the relationships that I talked about earlier, like these can be child tables. So you can specify these here within the mapping, and then any optional fields as well. All right, so these are downstream tables that are optional. Okay, so once you have your base entity and the mapping, you just need to have then a controller and a service to work with this. And for the service layer to pick this up, we need to have some type of repository interface here. So here's the Entity Framework repository implementation. All right, it implements iRepository, and type T is the class basically that you've created. All right, so inside here basically are the fields, utilities, methods that you can use for the iRepository. So this is the get by ID, insert, update, delete, all these kind of things. Basically, this is how we're going to do it. All right, so once we initialize a table name with the iRepository, we'll be able to have all these methods available for interacting with the actual physical database. And so finally, I'm just going to now open up some services here. And I'll grab the same customer service. So inside services, using dependency injection, here's our iRepository customer table that we've been talking about. All right, so I'm going to initialize an instance of iRepository. And then again, using dependency injection and inversion of control, I'm going to get a reference and then set that reference here. And then from here, I'll be able to perform my tasks through this service. So here you can see I'm referencing in various queries, customer repository.table. I can use standard link. So this service, of course, would be called from some type of controller that's working with this customer object. So that would probably be at the presentation layer level. For example, let me just go in here. So there's a controller and find the customer one, customer controller, there it is. So in here, I'd expect to find a service, and this is the same, here it is right here, iCustomer service. We were just looking at the customer service. So this controller would be interacting with the views. and performing all those actions. So customer list, for example, here, this would be some kind of grid UI on the front end. And then I would be customer service.getAllCustomers, and again using this, and this is connecting all the dots. This would return to the view in like an MVC5 application, which is this representing. And this is how you basically implement the code first implementation of the entity framework in an MVC5 application. In this video, we're going to talk about MS Azure SQL Database Advanced Security Management. Azure SQL Database is Microsoft's offering of Microsoft SQL Server hosted in the cloud. It provides developers the newest features of SQL Server without any management overhead required, with built-in high availability and backups. Azure SQL Database is protected by a defense in depth strategy that has 4 layers of protection around the customer's data. So the first layer is network security, where the firewalls prevent access to the database from external sources except those specified by the administrator. The second layer is access management, where user accounts are checked for permissions to the database. Threat protection is the third layer and monitors it for unusual behaviors or potentially harmful events happening against the database, sending alerts to the administrators when something is detected. And security management is the fourth layer, and its purpose is ensuring the data is not intercepted or modified by external actors. Now, network security is assured through the use of firewalls. So virtual network rules apply to organizations that have extended their virtual network capability and connectivity over the Azure backbone, specifying subnets that reside outside of the Azure subscription as endpoints for requests to Azure SQL Database instances. IP rules grant access to the database based on the IP that has the request originating from it. By default, all external IPs are blocked. Virtual network rules are used to block or allow communication only from specified subnets within the virtual network on Azure. Access management is split into 2 areas: authentication, which controls which users gain access to the database, and authorization, which controls what they're able to do. Authentication is provided through one of the following 2 methods. We have SQL authentication, which keeps usernames and passwords in the database, and Azure Active Directory provides directory and authentication services that Azure SQL Database can leverage for user authentication. So authorization is the control of what the user can do within the database after they have been authenticated and granted access. Controls are specified by database role and when the user is assigned to the role. Now, alternatively, users can be assigned permissions at the object level, restricting them to certain data structures instead of the whole database. At the smallest increment, a user can be assigned permissions through row-level security, limiting them to querying data only from certain rows related to the characteristics of the user. Now, Azure SQL Database provides auditing and threat detection capabilities to help secure customer data. SQL auditing tracks activities in and against the database. The logs can be written to a storage account in the subscription. Azure Monitor and Event Hubs can be used to collect and analyze the logs. Advanced Threat Protection analyzes the logs for unusual or suspicious activities and sends alerts when something is detected. Azure SQL Database also has features to ensure information protection and encryption. TLS is implemented to encrypt the data in transit. Transparent Data Encryption, or TDE, is used to encrypt the data at rest. Encryption keys are generated and handled by Azure, but if someone has a requirement to bring their own keys, they can use the Azure Key Vault, or TDE and TLS. Always Encrypted is a feature that can be enabled on columns and encrypts the data even for privileged accounts like the database administrator. So it should be used for credit card numbers or, say, PHI data where there should be no reason for a human to view it directly. Dynamic data masking will automatically identify sensitive data in the database and mask it from view when it is queried by obfuscating it in transit. It does not modify the database. Security management is an overview of the data and ensuring controls are in place to secure it. Vulnerability assessments can be generated through the advanced data security suite of tools, discovering and tracking vulnerabilities in the database security before they can be exploited. Data discovery and classification automatically discovers sensitive data stored in the database and can help to classify and label it and then protect it. And Microsoft routinely conducts risk assessments and compliance assessments to ensure the databases and platform that the database reside in are certified against a number of prominent regulations and certification bodies. The compliance offerings can be viewed in the Azure Trust Center. In this video, we're going to talk about MS Azure SQL databases. Now, Azure Database Services are fully managed deployments of a database instance with built-in high availability and backup services. Azure offers a variety of different databases, both relation and NoSQL, including SQL Server, MySQL, PostgreSQL, and Cosmos, a NoSQL implementation. Now, deploying a database can be done through the Azure portal or through the CLI. We're in the Azure portal right now on your screen. So we're going to click on SQL databases on the side here. And then from there, give it a moment. There we go, just get it reloaded. All right, so we're going to click on Add for creating a new database here. Now, we're going to start here looking at our subscription, and we have a pay-as-you-go subscription. So now we'll look at the resource group. So I have a resource group already created here. We're just going to search for it here. And I'm going to use the secure DB one. There we go. So the database details section is where you provide the underlying infrastructure that the database is going to reside on. So I'm going to pick a database name here now. I'll just call this SDB demo. And then we're going to create a new server here, because we need to actually have one to deploy to. So I'll go ahead and create new. And I'll give this server name on the right-hand pop-out menu a name. So call it SecureDB. And then for the admin here, I'll put one in. The password has to be complex here. So I've put something in my clipboard here that's going to meet the password complexity requirements. And the last thing I need to do now is choose a location. So East US is going to be the closest for me, so I'm just going to locate it in the list here and select it. So here we go at the top, East US, and then I'll click OK. It'll do a quick validation, and I look like I'm all set to go. So I'm going to now click on the Next to go towards networking. Oh, I should mention just one previous point. I'm just going to keep SQL Elastic Pool to no, and I'm using the default storage, so just 2 cores and 32 gig storage for this demonstration. Okay, now on to the networking here. So connectivity is the first point of security for a database. So we have 3 options that are presented here. We have no access allows you to specify your connection points after deployment, public endpoint, which gives your database a public IP, or private endpoint, which connects it to your virtual private connection. All right, so I'm going to just leave it as the default here and go to additional settings. Now, the data source can be specified, allowing you to start with a database that is from a backup, or you can populate it with the sample data for testing purposes, or it can just be empty. So let's click on sample here. So advanced data security is an additional service from Microsoft that provides functionality for securing the data and the database. It identifies and classifies sensitive data, alerts you to and mitigates vulnerabilities, and detects potential malicious activities. So now we're going to click on the button on the bottom left, Review and Create. And now we're actually going to hit the Create button. It just gives you a basic summary here of everything that we just went through. And in the same spot, lower left-hand side is the blue Create button. We're going to click on that. So databases residing on Azure have many security features and can be scaled out to suit the requirements here. I'm just going to hit reload. Sometimes this happens here. There we go. I've just refreshed here so I can see that it actually now is created. So databases residing on Azure have many security features and can be scaled to suit the requirements of the application. They support geo-replication for high availability, and it can be synced with other databases and support automatic tuning, making them resilient and easy to use for developers without requiring a dedicated DBA. In this video, we're going to talk about MS Azure SQL Access Management. Now, Azure SQL Databases is a service offering from Microsoft to provide databases hosted on the Azure Cloud Platform. Microsoft has built a series of security layers around the databases to ensure data is secure. Access to the database is controlled by a firewall limiting connections to only known and approved IP addresses. So let's explore this. First, let's go to the database here that I've created here. So I'm going to click on this off my dashboard. It's just called SDB Demo in my case. Now, to modify the firewall rules, we're going to use the center column here, and we're going to go find Set Server Firewall here. So you can see this row right across the top. So it goes copy, restore, export, and then Set Server Firewall. We can also get to that through the center column as well under security. So there's two ways to get to this. So here we are in the firewall settings. So setting the option to allow Azure services and resources to access the server whitelists all IP addresses used internally within the Azure data center, which could be a significant security hole. Now, it should be left off unless there are specific reasons to enable it. So clicking Add Client IP will add the current workstation to the whitelisted IP addresses. So there's a button for this just at the very top here. And I'm going to go ahead and click that now. And I can see here below that it now has a line that I can now modify. All right, so it has a 65.121.228.40 for me. And again, it's one IP, so the start and end is the same. So rules should be named appropriately to ensure they are understood later. So if I want to, say, apply a rule here, I could say this rule name is, say, SS Workstation or something like that. For now, I'll just leave it as client IP address underscore 2019. Now, virtual networks can be used to provide access to the database to a subnet to avoid having to manage multiple individual firewall rules. So if I click on Add Existing Virtual Network here, just down at the very bottom of the screen here where my mouse is, go ahead and click on that. A panel on the right-hand side comes out. Now, I can go ahead and leave the default name. Under subscription, I'm going to choose my subscription. So I have a pay as you go. It's going to attempt to automatically populate the virtual network and the subnet name as well. So we have a service endpoint for Microsoft.SQL on this VNet, meaning that resources in your subnets that are either in Azure or extended into Azure from on-prem through the VNet can be basically able to reach this database. So now I'm going to click on the button OK in that right-hand panel. So now that we have created the rules we can connect to the database. So we're going to go ahead and click on, I'm going to actually save all this now here. Go, and I can find that save in the top left of the main screen. Go ahead and click on that. And now it is saved here. Get a little notification. Okay. So what I want to do now is close this window. So I'm going to close this by hitting the little X in the top right of this window. And then I can look at my connection strings. So if I look down here on the center pane, it's the third one underneath settings here. I'm just going to go ahead and click on that. And it's going to pop open here. So strings or example code are going to be provided here for using ADO.NET, JDBC, ODBC, PHP, and Go. Each tab also includes a link to the download that you can get the relevant driver for implementation. Now, keep in mind that you will need to edit the string with your password if you're using SQL authentication on your database. Access to SQL databases stored in Azure is controlled at the network level by limiting the connections through the firewall and can be extended through the use of VNets to provide direct access to on-prem resources without having to traverse the internet. In this video, we're going to talk about MS Azure SQL authentication. So Microsoft SQL databases hosted in Azure support two forms of authentication. SQL authentication, which is kept local to the database, or they can utilize Azure Active Directory for users and groups. So first, an account from the Active Directory domain must be set as an admin account that SQL Server will use to authenticate other users. So I need to go to my SQL Server here, not my SQL Server database. So this is just called SecureDB, where my databases are hosted. Go ahead and click on that. And then what I need to find is the Azure AD admin account, which is going to be in the center console here, the center column. So I'm just going to go down through here and look for the Active Directory admin, for example here. I'll go ahead and click on that. So I'm going to click this Set Admin button here in the right-hand pane at the top. And I'm going to look for somebody that I know exists here in our sample. So I'm just going to look for Walter. There we go, Walter Patterson. There, Waldo here, Waldo. Okay, so I'll select this person. Perfect. Now we're going to just go ahead and save this. Again, buttons here in the right-hand panel, the top right here. I'll just go ahead and click Save. So this user will now be able to connect to the database to provide access to others. It is the only account that can be used to create logins for other AD accounts in the database. I'm now going to switch VMs here to go to my SMSS. Okay, so I'm in now SQL Server Management Studio, and I have my server name in place here. The authentication is Active Directory password that I'm going to use now. I have my username specified, and I have the password. Now, to provide other Active Directory users access to the database, traditionally we would have created a login, say in master. However, with SQL hosted Azure databases, we create the login on the database itself. This is called a contained user. So first, let me go ahead and connect. And it'll establish connection. Okay, now we're connected here. I'll expand the databases tab. And I have my SB demo here. Just going to expand this. And I'm going to right click and we'll create a new query. So we create the user through a T-SQL query. We have an account called Stephen Sams who we want to give access to for this database here. So let me just go ahead and put something on my clipboard here. I'll bring it back here. We'll execute. There we go. All right, so the create user. This is my user here from external provider. Go ahead and click on execute. Okay. There we go. I just confirmed the name and just reran this. So I needed to have stephensams_outlook.com and then ext pound. So I just added that and then it created successfully. So this is the full name. Just to show you here, let me just jump back to the other VM for a moment. There we go. This is the user I'm talking about here. So if I look at this particular user and I hover over the tooltip, this is the full name that I actually need to use in SSMS. Okay, so let's move on now. So we've now created the user account that exists in Azure Active Directory. We actually just went and verified it's in Azure Active Directory as a contained user in this SDB demo database. Now the user will require permissions to modify the database. So I'm just going to paste another line here, and I'm just going to now append this piece here, which now I know I need, onto my username. Now in Management Studio, if I just want to execute one line, I can just highlight the line that I want to execute, and no other line will actually execute here. So I can have lots of syntax here on one screen. I just highlight this one line, I can click execute, and it'll only execute that line. So I've just ran the alter role command. So now the user is added to the database and has the DB owner role. So now we can verify that the account exists or was created. So I can expand my security tab underneath SBD demo and then go ahead and expand the users tab. And I can see the Stephen Sams Outlook account right here. Now, if I right click on this user, there are no properties available for its context exists outside of the database, which is why we have to create the logins using T-SQL and not perform the actions through the SMSS console. In this video, we're going to talk about MS Azure SQL Transparent Data Encryption. Azure SQL Database is a service offered on Microsoft's cloud platform to securely create and manage databases. These databases are protected at the network level by firewalls and encrypted data transfers, and at the storage level by transparent data encryption. So transparent data encryption, or TDE, protects SQL databases from data theft by encrypting the database at rest. So encryption and decryption are done in real time of the database, and transaction logs and backups as well. However, the master database is not encrypted because it contains components needed for the encryption process. So I have a SQL Server database deployed already here. It's just called SecureDB. I'm going to go ahead and click on that. Now, when TDE is enabled, the database is encrypted with an AES key generated by the database. This is called the Database Encryption Key, or DEK. So the DEK is encrypted with a certificate stored in the master database. This is called the Key Encryption Key, or KEK. So in the center pane here, I'm just going to scroll down to the security section here, and the last option is the transparent data encryption. I'm going to go ahead and click on that. Now, sometimes organizations have a requirement to management that they have their own database keys for compliance or regulatory reasons, and that can be okay. So for this demo, though, I'm going to click on the Customer Managed Key. All right. Now, keys can be stored in Azure Key Vault, a service on Azure that securely generates and stores keys, passwords, and secrets, and exposes them via service principals to your Azure services. So what I'm going to do now is click the Change Key Vault. Go ahead and do that. And then I'm going to select the option that I have here, the SDB Demo KV. There we go. And then I'm going to change key, which is the next option here. And I'm going to select this SDB Demo RSA. All right. Now, once I've done that, I'm going to click the Save button here in the top left of the right-hand pane. Okay. Now that the key is set at the database server level, it will automatically be assigned to all databases existing on the server and inherited by any new database created. So let's go look at one of those databases here. I'm just going to go back to home because it's quick. Oh, I'm going to save that. Go. All right, so I'm going to go home and I'm going to go to my SBD demo database. There we go. Now in here, I'm going to click on the transparent data encryption now. So it's found in the same spot. I'm just going to scroll down to security. There we go. And by default, when a database is created with the TDE, it's going to be enabled now. So see how this data encryption is already enabled and the encryption status is set to encrypted. Now, I do want to point out that if you want to manually turn this off, you can do that, but it's not recommended by a security practice. When a TDE protected database is exported, it is not encrypted. So care will need to be taken of the data if it is being migrated. TDE will need to be enabled on the database after import has been completed. For example, if migrating a database from on-prem to the cloud. Now, a separation of duties can help to ensure the key and database are protected by internal actors by having the Key Vault administrator and database administrators come from different teams. In the event of a breach at the data level, the Key Vault administrator can revoke the key, leaving the database in an encrypted state and inaccessible. Event logging can be contained by role, meaning that the audit trail is a separate user from both the database administrator and the Key Vault operator. Also keep in mind that if the key is cycled out, backups taken with the old key are not updated to use the new key, so keys should never be deleted, only archived when their lifecycle comes to an end. In this video, we're going to talk about MS Azure SQL Database Auditing. So auditing a database is tracking the events and writing them to a log external to the database to ensure its integrity. Auditing Azure SQL databases will write the logs to a storage account where they can be retrieved and analyzed using log analytics and event hubs. Logs can be used for ensuring regulation compliance, getting insight into the performance of the database, and for tracking events in the database that could be malicious. Logging is defined at both the server and database level. Server policies always apply to all existing and new databases. So I'm going to open up a SQL Server here. So on my Azure portal here, I have one called SecureDB. All right, so from here, I'm going to go into the auditing section. So if I scroll down on the center pane here until I get to security section, it's second on the list here. I'm just going to go ahead and click on that. Now, auditing is either turned on or off, but the location for the different logs is configurable. So you can either store logs in a storage account on Azure or feed them directly into a log analytics workspace or event hub that is pre-configured. In our demo, we'll place them into a storage account. So what I'm going to do now is click auditing on and click the storage here. And when I do that, I need to configure the storage account here. So I'm going to go ahead and do that just by clicking that right arrow. I have a pay-as-you-go subscription here. There we go. And I'm going to just pick an existing storage account here. There. So, and then I can, of course, set my retention in terms of days. So I'll give it something like 84 here, just something a little bit random here. All right, I'm going to go ahead and click OK on that. And now with the storage details specified, it will allow me to save this now. So on this right-hand pane here at the top left of it, I'm going to click on Save. Save operation is currently in progress, it's telling me. And I'll just need to wait this out. All right, the save is complete. So that configured auditing at the server level. However, auditing can be enabled or modified for individual databases that will override the default server settings. Let's go see how that's done. I'm just going to go back to my Home tab here, just because my recent resources are easy to use. So I have a SQL database here just called SDB Demo. I'm going to go ahead and click on that. And I'm going to find the auditing in the same section. Just going to scroll down that center pane until I get to the security section. And again, here's auditing. So I'm going to go ahead and click on that. So the configuration options are the same at the server level and the database level. And here there's a banner to display whether server level settings is enabled or not enabled. All right, so I can see that right here. I can see that server level auditing is in fact enabled here. Now to understand what will be audited, there's a little information icon here that I can click on or hover over and it creates a tooltip. So the defaults audit will audit the queries and store procedures executed against the database, as well as login attempts, for example. And you can also view the audit logs through a link in this blade. So by blade, I mean these different sections up here. I can click on View Audit Logs. So the audit source can be either the server or the database logs, and there's an option to show only audit records for SQL injection attacks, for example, as these would be the most frequently seen kind of attack on a database. So I could click this little checkbox here if I wanted to do that and just have that filter. Now, Azure SQL Database provides strong logging and auditing services at both the server and database levels we've talked about, and can leverage other Azure components to collect, analyze, and correlate events happening against your data. In this video, we're going to talk about MS Azure SQL Advanced Data Security. Now, Advanced Data Security is a suite of utilities available from Microsoft to help in securing SQL databases hosted on Azure. It includes tools to discover and classify sensitive data in the database tables, identify and mitigate vulnerabilities, and detect abnormal activities in the database. ADS is enabled at the server level and can be enabled at the database level if there are use cases that require separate assessments for individual databases. So what I'm going to do now is I'm going to open up a SQL server here. It's just called SecureDB. And I'm going to move the center column down here to the security section here. And I'm looking for the Advanced Data Security here, which is the first option underneath security. So I'm going to go ahead and click on that. Now, certain settings are universal, like which storage account vulnerability assessments get stored in, and whether the automatic scan should run periodically, for example. So I'm going to go ahead now and click the recurring information here. All right, so this little kind of eye beside the periodic recurring scans, and I get this little pop out here. So if enabled, vulnerability scans will automatically run against your database every Sunday, for example, at approximately midnight. Scan reports can be emailed automatically to a security team or database administrator to review and action on. The email address listed can contain multiple values separated by semicolons. There's also an option to send the report to the subscription owner and any users that have admin accounts in the subscription. Now, alerts from the Advanced Threat Protection solution can be emailed as well, and the alerts can be configured. Just going to scroll down a little bit here. Okay, this is the little email addresses here I was telling you about Common Delimited. I'm going to expand the Advanced Threat Protection types here. Just going to click this little right arrow here. Okay, and this is going to give me a list here. We're just going to review this. So alerts are sent when any of these checked actions are detected. So the first one is basically alerts for all. And then you have when a SQL injection has been executed, if a vulnerability to SQL injection is found in the application, if data was exposed and copied or exported from the database, any potentially unsafe actions like disabling data encryption, brute force attempts at gaining access, suspicion of logins if they were detected, like if a user simultaneously logged in from North America and Europe, that kind of thing. The Advanced Data Security Suite offers proactive monitoring, alerting, and controls for working with vulnerabilities and helps organizations to better understand their security footprint with a view to mitigating issues before they arise. So it is an optional extra with Azure SQL Database and can be enabled or disabled when required. Setting at the database level provides protection to all databases residing on the server, or can be enabled on individual databases if there is a use case to do so. In this video, we're going to talk about MS Azure SQL Data Discovery and Classification. So Azure SQL Database is a service offering from Microsoft to host databases in their cloud platform. The Advanced Data Security Suite is a group of tools offered to help customers ensure their data is kept private and secure. Included in the suite is the Data Discovery and Classification tool. So the tool helps administrators to discover columns in their database that can contain potentially sensitive data. The findings will be presented to the administrator who can then classify each column. Classification labels can be tagged to columns, helping with sensitivity-based auditing. So I'm in my Azure portal now, and I have a SQL database sitting on one of my SQL servers here. We're just going to open that up and take a closer look. Now, when I get to the open screen here, there's three columns, the Azure portal column on the left, and then there's this center column, which is the different areas of options for the management of a SQL database. I'm going to scroll down here. I'm going to go to the Advanced Data Security, which is the first option underneath Security. All right, so I'm going to click on that. Now, this database that I have open here contains roughly 109 columns and 12 tables. And currently there is no data classification assigned to the database, but there are 15 columns that have been automatically identified as having potential sensitive data issues. All right, so if I want to get a closer look at that, this Data Discovery and Classification tab here, I can click into this. I can use even the little ellipse there. And here, again, here's our 109 columns, 12 tables containing sensitive information. We saw 3 at the other screen here that went on. All right, and I can drill into these to get more information. Notice this blue bar. We have found 15 columns with classification recommendations, and there's an arrow. So the system has determined that customer first and last names are confidential according to the GDPR rules, which is a set of regulations in the European Union for privacy and data protection. Now, additionally, there are a number of other labels that have been flagged as potentially sensitive based on their information type, like financial details or credit card numbers. Recommendations can be applied or dismissed. So what I'm going to do now is I'm going to select the first and last name as demonstrations here. And notice as soon as I clicked a checkbox, the accepted selected recommendations became clickable. So this button now I can click on. So I'm going to do that now, accept selected recommendations. Okay, now applied classifications can be modified to change the information type and the sensitivity label. All right, so I can click on these and I can be more specific here. So we have networking, contact info, credentials, credit card, banking, financial, other, name, which it correctly identified, national ID, social security numbers, health, or date of birth. Let's take a look at the sensitivity label here, which is the next one. Just going to click on that. So this sensitivity label is the main classification attribute and is used for auditing and reporting. All right, so this is actually correct. That's a name, like basically what it thought was correct, as we just verified. It is a name, and it is a GDPR type issue. So I'm going to click on Save in the top left of this main pane now. And it'll just take a moment to save. And now I'm going to go back and click on Overview. And I can see my view has changed. So back in the overview, we get some information about the changes we have made. It shows the number of columns and tables that we have classified. So custom labels can be created to suit your business needs outside of the default recommendations in Azure. I'm going to click on Configure now, which is just to the right of Export at the top of the pane. So the order of the labels is relevant to the way they are applied, with the least sensitive at the top and the most sensitive at the bottom of the list. So new information types can be created and mapped to the labels as well. Taxonomy can be defined in the Azure Security Center for it to apply to the entire subscription, or individual databases can be classified with the custom policies. In this video, we're going to talk about MS Azure SQL vulnerability assessments. The Advanced Data Security Suite is a collection of tools to help customers secure their SQL databases hosted on Microsoft Azure platform. So one of the capabilities in the suite is SQL Vulnerability Assessments. It's a service that discovers potential vulnerabilities in the configuration of their database and provides suggestions to remediate them. So I'm going to open up my SQL server here. It's called SDB Demo. So it's a SQL database sitting on a SQL server in Azure. So I'm going to go ahead and do that. And the first thing I'm going to do when I get here is in this center pane here, which has all the options and labels for configuring your database. I'm going to come down underneath the security section and click on Advanced Data Security. So vulnerability assessment is a scanning service built into the database. It leverages a rule base to flag vulnerabilities and configurations that are against best practices or problems with permissions creep or sensitive data that is classified or masked. The scanner will cover both database and server level issues and includes recommendations on how to remediate and, where possible, scripts to perform the steps. So the second box is the vulnerability assessment, which we're now talking about here. So I'm going to go ahead and click on this. This is just a high-level dashboard. It's like a summary, but what we want to now do is get some more details on this. So I'm going to drill into the vulnerability assessment. So from the summary here, we can see how many has passed and failed checks, and a risk summary to highlight the number of risks in each category. All right, and then into the grid below here is the details on the failed checks, and then there's another tab for the past checks right here. All right, so you have 44 passed and 5 failed. So you can toggle between them just to see them. So let's drill into one and get some more information. Let's pick on one of the failures. So let's look at this one. Server level firewall rules should be tracked and maintained at a strict minimum. This is actually at the master level here, so this is a very interesting one. Let's click on it and drill in for more information. So as you can see, when I selected that failure, it took me to a pane where the risk and status are displayed, along with where it applies, links to relevant documentation, the impact it can have, and the query used to find the results. Okay. So speaking of that, now below here are the results of the query. So in this case, the concern is that the IP addresses that are whitelisted have access through the server firewall. While there are no actual concerns about the IP addresses, the vulnerability is alerting the user to ensure that they track and monitor the whitelisted IP addresses to ensure that there are no unexpected additions. All right, we can see there's 2 in the list here. And then below that are some remediation steps or guidelines. So it's telling me that I could actually, if I felt that these were an issue, I could execute these requests inside SQL and basically run these rules to remove the concern. In this particular case, I might not want to actually do these because these would actually block my whitelisted IPs. So at the top of the pane, you have the option to approve as baseline or to adhere, just right up here where my mouse is, very top left. Approve as baseline or clear the baseline. So approving this alert at a baseline will save the configuration and alert again in future if it changes. So if a user adds another whitelisted IP, we'll flag it as a deviation from the baseline and generate an alert. This is how you can avoid alert fatigue. So I'm going to click on approve as baseline, and then I'm going to click on yes when the confirmation comes up for me to continue. So at this point now, the baseline is approved. In the top right, I'm just going to go ahead and close this window. So you are now going to be alerted that there are pending changes to the baseline. So a new scan should be run to generate any new results. We can see this here in the yellow. I'm just highlighting it right now for the screen. So running a scan will remove the approved baseline item from the failed checks. So I'm going to go ahead and click scan. Executing a vulnerability assessment scan is now in progress. There we go. And now you can see our total failing checks went from 5 down to 4. All right, so the previous one is now removed from the list. If I click on scan history, which is just to the right of export scan results in the top center pane, there we go. So the scan history can be viewed to see what has changed each time a scan has been performed and to review how many items have been resolved, showing a usable metric of success for securing the database. Vulnerability assessments is a feature built into Microsoft SQL Server that they have also made available in the cloud to help users remediate security concerns before they can be exploited by providing remediation and baseline capabilities. It offers immediate results when securing data. In this video, we're going to talk about MS Azure SQL Advanced Threat Protection. So Advanced Threat Protection is part of the Advanced Data Security suite of tools available for helping to secure SQL databases on Azure. Advanced Threat Protection helps customers by detecting and alerting an abnormal activity. Alerts are integrated with those from the Azure Security Center, detailing suspicious activities and recommending potential resolutions or mitigations. So I'm going to go into my SQL database here, which I have on a SQL server in Azure. It's called SBD Demo. Once I get this open here, in the center pane is all the options that I have to manage my database. I'm going to scroll down to the security section and click on Advanced Data Security. And the dashboard is going to open here. It's first going to show me the data discovery and classification. Then I'm going to get a vulnerability assessment. And then finally on the right, I'm going to get my Advanced Threat Protection panel, which is what we want to talk about in this video. So configuration is done through the Advanced Data Security settings here. I'm just going to drill into this. This is just giving me a high level summary here, but let's drill in and get some more detail. So this right now has no security threats. But let's alter some settings here so we can change how this looks. So I'm going to just go back up to my breadcrumb, click on my advanced data security. This takes me back to the previous page I was on. Notice in the top right-hand pane and the left-hand side, so top left of the right-hand pane, is the settings button. I'm going to go ahead and click on this. And there is a checkbox for me. It says enable advanced data security at the database level. So I'm going to go ahead and click on that. I get this warning that tells me that this is going to enable at the database level, enabling you to receive separate advanced threat protection alerts for this database only. I'm going to go ahead and click on yes to that. I'm going to save this in a minute, but first I just want to take a quick peek at the other things I need to configure. There's a storage account that I need to select here. So I'm going to select an existing one. And of course I'm going to use my current subscription, which is a pay-as-you-go subscription. And if I scroll down here just for some final items here, I could put in a comma delimited email address or semicolon separated list to direct messages from Advanced Threat Protection, with the option of sending them to the subscription owner and all administrator accounts as well. I'm just going to expand the all underneath here, this Advanced Threat Protection types, and then I get a list that is going to pop out here on the right. So Advanced Threat Protection can generate alerts for any of these conditions. So when a SQL injection attack is detected, when a vulnerability to SQL injection is discovered, when the database is accessed from an unexpected location, including from an unusual Azure data center, when penetration attacks or brute force attacks are detected, when a login is detected from an unusual SQL account, like a service account that would not usually be logged in with directly. So I'm going to go ahead and click on OK on that. And I'm going to click Save here in the top left of the center pane to save all these settings. All right, so this is now saved. I do want to point out here that I can view the Advanced Data Security server settings. Right now, we're looking at the database settings, but I could apply this to the entire SQL server. Just going to use my breadcrumb just to go back here. And just want to mention one more thing in the Advanced Data Protection. Now, obviously, none of the alerts have actually been triggered here, so we're still not seeing anything. But I do want to mention that you can download this report. You can also filter this for all types of criteria, timestamps and state, and even severity. I'm just going to click on Security Center here. So alerts will be emailed to the previously specified email addresses and will contain all the details of threat. They contain the activity, cause, remediation steps, and where possible, scripts to mitigate the concern. So in the event of a SQL injection attack, the alert will contain the executed query for you to perform triage and forensics of what potential harm was done. Okay. And there's a lot of different graphs here that you can use to get some additional information beyond what was discussed in this video. So here's our threat protection section here. Just down at the very bottom. So in this course, we've examined advanced security options in database development using the MS Azure SQL database, including access management, data encryption, auditing, and vulnerability assessment and protection. And we did this by exploring different FSD database systems and their strengths and weaknesses, how to create a database schema using the MS Entity Framework and a code-first approach, advanced security options for the MS Azure SQL database, how to configure and test in Azure SQL database, how to perform access management tasks and configure and manage Azure Active Directory authentication with Azure SQL database, how to use the Azure portal to configure and manage both transparent data encryption and auditing, and how to enable and use MS Azure SQL Advanced Data Security, how to classify your Azure SQL database using the Azure portal, and finally, how to use the Azure portal to run and use a vulnerability assessment scan and advanced threat protection alerts.